This is a conversation that I had with Matthias, Wandel, and Yacine. You might know Matthias as like a famous YouTuber. He's got like almost 2 million subscribers. His backstory, I don't know how well known it is. He grew up in Northern Ontario. His dad was trying to like escape civilization. He was a really talented carpenter, so he would just make everything by hand. And I think that influenced a lot of like who he is today. You could see in his work, he blends like carpentry, robotics, engineering. I think a lot of that has to do with the way he grew up in the past. You know, in this episode, we talked about his early experiences with a personal computer. We talked about some of the early things he made in a basement, him and his brother. We talked about how he went from there to Waterloo and how he became the 13th employee at BlackBerry, which is actually called RIM at the time, Research in Motion. This company like affected so much of culture. Like they affected like our relationship with phones, and to just get the background into what was happening and some of the specific conversations that he was having with the founders of that company, like key pivotal moments and how they thought about things, is super interesting. He's an interesting guy, Matthias. He's continuously building things. He's making potato guns to shoot blackberries to test their like durability. He's making squirrel turrets. He's making like marble catching machines. He's making contraptions to check how strong like glue is. There's just so many interesting things that this guy is always experimenting with. And I think it's both him and Yacine for me are a good, they're good inspiration to remember of what I can do on my own. What I can do, like, you know, I can just come up with an idea and can I just look at something complex and figure it out? If I have an idea, can I just make it? Why depend on someone else? Why depend on some other thing or anything? It's just like, if I have access to a computer and have my brain, you know, how far can I get with just that? And these guys are awesome. Like, there were points in the conversation where I was just watching both of them riff, and they're both way smarter than I am, and just seeing two people talk and breaking down specific engineering concepts and stuff like that, it was cool. So really, really fun episode. I hope you like it. Thank you for everything. What is this?
I wonder where he gets his pyrotechnic capacitors from.
Yeah, right. Yeah.
Like
this guy?
The latest, yeah, that's his most famous video. He's gotten more sophisticated since then. So he always has electronics that blow up, and it's very clear that it's deliberate that things blow up. And this was the latest video that the way that capacitor blew up is like,
Yep.
Capacitors don't blow up like
Yep.
that. It's like, so did he make a pyrotechnic capacitor,
Probably.
or was that put in post? I couldn't see any.
I feel like he probably just made it himself to get big
But it was
explosions.
definitely.
Can you go back to his channel?
Have you ever seen Spyro's videos?
Look for latest.
Latest. Which one?
Hang on, that's a new one. Oh yeah.
2 hours ago.
Which one should we pick, Matthias, to understand who this guy is?
Yeah, he's just outrageous.
He does things that are-
This one, don't screw into my floor. It's like he actually got
that's
AI'd
it.
on this one. So the image that this video revolves around is actually AI generated, and I don't know if he didn't realize it or just wanted to make the video. Certainly, lots of people have pointed it out to him, so that somebody supposedly screwed a pole to the floor beneath, and there's a screw head sticking out, and it's like, those are not real screws, and that floor would be a heck of a lot more messed up if those screws came out.
Yep.
And so it's like, did he actually like fall for an AI image?
He probably did.
Possibly on purpose because he wanted to make that video?
No, I think he probably just fell for it. To be honest, it's kind of hard to tell.
Well,
I think like,
I'm looking at this going, and somebody pointed out in the comments too, like one of the screws goes counterclockwise, and the pattern isn't quite square, so this is not
Fascinating.
I was kind of like, those screws are a little bit too thick, and why would they go all the way through and just stop just short there?
Yeah.
And if you're going through a hardwood floor, that would crack.
Holy fuck. Can I get audio on this?
So he is quite deliberately, I mean, I've sometimes gone through frame by frame
What the
videos
fuck?
to see it's like,
If he was really doing it, yep.
oh yeah, it's like, it's quite deliberate, like that's his
Yep.
shtick.
Yep.
So the one with the electric guitar, I think the sparks on that one were real.
Yep.
But
So wait, what does
since
this guy do?
then- he's actually quite good in terms of like he's not just doing the shtick. He's actually quite knowledgeable.
Yep.
What is his shtick?
He talks about electronics and stuff like that. And whenever he has a chance to make things go wrong, where he gets himself zapped,
He does
gets
it?
himself zapped, I suspect most of the time it's just
Yep.
like he's got the thing plugged in, but you don't know if the power cord that he's showing on the table is actually the one that actually connects to his
Exactly.
thing.
Yeah.
So he always gets zapped or some component blows up or catches fire and stuff like that.
Yeah.
And he's always being a little bit outrageous. And so that's his shtick. And it works very well. Like he's very successful.
Yep.
Interesting.
There's also Spyro.
Spyro?
Yeah.
How do you spell that?
I can't remember. He's this. That's probably not it. He put a bunch of batteries together.
Styropyro.
Yeah, exactly.
With the 400 car battery.
Yes, exactly. He put 400 car batteries together and made extremely large sparks. I'm pretty sure that's real.
Yeah. Oh yeah. No. That guy. That's completely. That is completely real.
I fell off
and
the couch when he said
he's
science
got
machete.
like megawatts going through his stuff. It's just there. So these are all car batteries, and a car battery like that, when you short it, that produces
Kill the
an
audio,
insane amount of current. And Air's got 400 of them.
So what's going on here?
So, well, this guy likes I love his videos. Like one of them, he's made how many kilowatt microwave was it?
I can't remember.
So he's basically putting large amounts of currents through there. So he'll take like a half-inch bolt.
Holy fuck.
And put current through a half-inch bolt until it melts.
Until it melts?
Oh yeah, and it doesn't take long for it to
But that's not melting, that's exploding.
Well, yeah, because it melts so fast.
What do you mean by melting?
Like it literally doesn't have a chance to move out of the way before it explodes. And so this introduces some interesting problems that you don't really think about it because when you got current going through something, you have a little bit of electromagnetism that moves things a bit. But when you've got 1,000 times more current than you would ever imagine going through there, the force goes up with the current square, and suddenly those forces that you don't even notice become very serious and become a huge problem for him. So when you short something, all those wires that go to a thing, those wires move just from the current.
Yep.
Like
what do you mean by move?
Just the magnetism from the current going through the wires
Actually physically moves them?
pulls them together.
Interesting.
Yeah. And it's just
when you push things to the limit,
Yeah.
you come across all these phenomena that you don't necessarily expect.
Yeah.
And sometimes that's the point of pushing things to the limit.
Right.
Like it's a really great way to teach people about the fact that current creates electromagnetic fields. You don't really take it into consideration when you're working on very small things.
there would be more effective ways of teaching it, but it's
Yes.
I just love the sparks.
That's true. That's a part of it is on entertainment too. Like there's a lot of education delivered through entertainment on YouTube.
Yeah, like actually he was talking about the plasma pinch in his most recent video, which actually has
Plasma pinch?
fusion. Yeah.
Can you find it, Robbie?
and also the instability of a plasma arc because it likes to curve, which is apparently a big problem for doing nuclear fusion type work.
The plasma pinch.
So you have essentially, when you have enough current, the air gets hot enough, it becomes conductive. So the air, sort of like lightning. And as the current gets larger,
I think it's
that pulls together the plasma.
this?
Yeah.
A pinch. Electromagnetic pinch, magnetic pinch, plasma pinch is the compression of an electrically conducting filament by magnetic forces or a device that does such. The conductor is usually a plasma, but could also be a solid or liquid metal. Pinches were the first type of device used for experiments in controlled nuclear fusion power. You have to explain this to me.
Well, I think the whole idea is just to get the fusion materials close enough to each other. I don't know how this relates to nuclear fusion.
Interesting.
So I haven't really, I've seen pictures of, their fusion reactors, but it's like, I haven't really considered the electromagnetics or how the containment works.
But when you said plasma pinch, are you talking about a video?
No, like with his, like he's got arcs going and there's so much current going through that he's got plasma arcs and they get pinched together from the current.
And what is that? Why does that matter?
This is cool.
No, I know,
It is
I know,
cool,
no,
but
I know,
it's like
I know
he
it's
just
cool, but I'm saying like, why is it
He
cool?
observed how he had a little explosion in his contactor.
Right.
And there was like literally a spherical area blown out of his contactor. Like he has to turn on.
What do you think it is that drives people to do these things? Just push things to the limits until things blow up. Like, what do you
he's
think?
got a high testosterone anomaly.
That's true. Yeah, that's true. So some context there is that he has a condition that increases a hormonal condition that increases his testosterone. So
Like for
testosterone
real?
Very, very high,
Oh yes, yeah.
Oh, that's like a
Like
real thing?
He's talked about this health problem, which I don't know seems to doesn't seem to
Encourage
hurt his
people in the risk-taking direction.
Damn, interesting.
Although he is he does point out that he doesn't take unnecessary risks, but he does like doing dangerous things, but he's aware of where things can go wrong.
Yeah.
So he doesn't do things stupidly. Like he'll be behind a tree and not watching it with his plain eyes when the spark goes off.
What's the most dangerous engineering project you've ever worked on?
I haven't really worked on anything dangerous. Certainly when I built my just the potato cannon.
Is there a video of that?
No, that was before videos.
So what was that? What's the story of the potato cannon?
So people do this. So you typically people use something like hairspray. So you have an ABS pipe, and then you have like a 4-inch piece of pipe where it's the combustion chamber, and you just have an explosion, just a air gas explosion. So quite often people use hairspray to give it like the fuel, and then you close it, and then you spark it with like some kind of spark plug or something like that. And it shoots a potato at the front. And my friend Ron built one, and when he'd fired out of his crotch. And I'm
like, how much damage can you do with a potato cannon?
Not a lot.
Isn't this you? Oh, this is a homemade air gun.
Oh yeah, that's my homemade air gun. Yeah.
What's the difference between a potato gun and an air gun?
So potato gun, the air gun
Holy
is strictly
shit.
fired by air. Yeah, it'll go through 30 millimeters of particle board if I'm shooting a steel ball.
That's a steel ball?
Yeah.
You shot
you
a
get
fucking...
a lot more wallop out of a steel. Like steel is way heavier than glass, than marbles. It was made for marbles, but then it's like, well, steel balls just get so much more damage.
Damn.
So yeah, this one, like you have to think about when you build something like that in terms of things can go wrong.
Like what can go wrong?
You need to have safety glasses on. When you're ever interacting with anything that has a lot of energy, put on safety glasses.
Yeah, and also, so it's got an elbow there, and it's like if that elbow blows, it's going to get me in the face.
Did you make this from scratch?
So you'll notice when you're holding a gun, there's a big piece of wood behind the copper elbow. And like if that ever gets loose, that needs
Which
to be held
wood?
in
Pause
place.
it?
Hang on. Like, can we see it in here? Oh yeah, see
Pause.
there.
Pause.
So you'll notice there's you can see the pipe goes. There's the chamber is on the bottom.
The silver pipe. Yeah, the chamber.
The barrel's on the top, and there's an elbow that goes around, and there's a piece of wood that holds that in place just in case that ever blows.
Holy shit.
Now this gun did get me in the face in a failure mode I had not anticipated, but it was just more surprise than anything else.
Like what happened?
Suggested, why don't you fill it with water and see what happens then? So I filled the barrel with water and I had to aim it up a little bit. And so it turns out that the pressure of the tank, the water has got viscosity.
Right.
So as I was pushing the water forward, it took the barrel with it because of the viscosity of the water.
Oh.
So now the barrel moved forward, and the barrel is not firmly attached to the end point there.
Right.
Like that never occurred to me. So the barrel moved forward, and then I've got this blowout, the air blowing into the barrel, which is full of water. Again, the water doesn't move that fast, so it squirts the water back at me, and I'm like, holy shit, it backfired.
Yep.
So that was the failure mode I had not anticipated. Fortunately, it was only water.
Yeah,
so
exactly.
it was completely harmless. But I had thought a lot about, or for instance, what if the failure mode, for instance, of ABS is it doesn't fragment when it fails. But in terms of pumping it up, what if it blows while I'm pumping it? Because that's the most dangerous sort of thing there. I think I've got a piece of wood that holds the valve just to contain that if it blows.
Who's filming this?
My friend Eric.
Oh, cool.
Oh, this is going back like 10 years.
What city is this
so that's
in?
the wadding. There's the steel ball.
Is this in
Ottawa?
Oh, okay.
There comes a ramrod, which has got a stop on it to stop the marble just before it gets to the valve.
Right.
And then after that becomes pressurizing it. So I never load it pressurized because again, so the thing is, if I could take that gun and go like this, it'll fire.
Yep.
So I added a safety to it because at some point, trying to deal with squirrels, I had to have the gun preloaded, and I had it in my house.
Right.
So it's like, okay, I gotta have a safety.
So you were firing this at squirrels that were getting up into your attic.
That's and
that's fucking crazy, man.
So at that point, like I had to have it preloaded.
That's awesome.
Because if I'm gonna run the compressor, the squirrel
my god.
Exactly. Yeah.
So I had this like by the back door,
just loaded with the safety on.
With the safety on.
Yeah.
So like, what is the? I'm gonna ask some dumb questions, but like, what is the? Oh, this is the potato gun.
Yeah.
Is this it?
Yeah. So this is my friend Ron's. And
okay.
Like he would fire that from his crotch from time to time. And
crotch.
Like,
from his crotch.
Yeah.
like he would
like this.
And he would fire it from his dick.
Yeah. Exactly.
Oh.
Like if the back plug came out while it fired. It's where's that gonna hit?
So like for me, I don't know anything about this stuff. But can you just help me understand like what from like an impact perspective? What's the difference between shooting like a steel ball? Like if I was to get hit with a steel ball versus like a potato, like how would it different? Like how would it feel?
The potato's got a lot more wallop.
Wallop?
more like kinetic energy.
More kinetic energy. Yeah.
interesting.
It
But
depends on what you're hitting. So
Like is shooting a potato like shooting like a bazooka?
no, well, a bazooka shoots something hard. The potato
Oh,
is
because it's kind of soft.
So the potato.
Like, would it knock me
I'd
down?
rather be hit by the steel ball than a potato. In the head.
Really?
But if it was in the head, I would rather have it the potato because the steel ball, it might go through.
Like, let's say this is good. Like, let's say you shoot like a potato at a wall. Is it like mashed like potatoes
the
kind of thing?
potato explodes. Yeah.
Oh yeah.
Yeah,
But is there like any like did you ever like eat any of it?
No.
No.
It'll be mashed potatoes, but it's not cooked.
Oh yeah, that makes
Plus, you have
sense.
to find it first.
Oh, okay. So it just
the potato-
explodes.
Yeah, the potatoes kind of. So you can scroll back there. So I switched to hardwood. I made some hardwood projectiles because the potatoes just didn't do enough damage.
Oh okay.
And I put tails on them because they're not stabilized. It's not a rifle.
What's the? Sorry, I just got to know. What's the recoil like when you shoot a potato versus
It's not that bad. I mean,
That's not-
the gun does move back by a yard or two.
a yard? That's pretty big.
Well, it just skids along the gravel. It depends on where it's at.
Like the gun would
Oh, yeah,
push you
the
back a
gun's
yard.
definitely
So
moving
your
back.
friend was shooting the potato
Yeah,
gun
but
from
it's
his
not that much
crotch with a yard of recoil.
Well, the thing is, it goes a yard if there's nothing to stop it from.
Oh, okay,
sliding
okay.
along. So think of
But
it
he had
as
his like glutes or whatever.
It's not that hard of a, and the potato gun has got a lot more mass than the potato.
Hmm.
So
but
the
as-
background of this is that you're firing the potatoes at blackberries, like the initial version of the blackberries.
Yeah, so he built a potato gun and it's like, oh, this is cool. We got to shoot at some blackberries.
Yep.
So that's what we did. And then the hardwood slugs are actually different.
Smashing,
Like his was a
yeah.
2-inch. Yeah. So there's a big steel weight. There's a 30-pound steel weight behind it because I don't want to use up the recoil. And then there's a 1-inch thick steel plate on the front.
Is this also a type of gun?
Yeah, so this this one's big enough to shoot blackberries. So I started by shooting them in the air, but I found that most of the kinetic energy gets used up
Yeah.
with aerodynamics.
Yeah, the
It
drag,
doesn't-
yeah.
It doesn't hit that hard. So
Oh
I
shit.
decided that it was much more effective you don't want to waste all that kinetic energy, so you shoot the BlackBerry to steel plate.
Yeah.
And it's kind of interesting because the circuit boards got completely depopulated of all the surface mount components because the force of acceleration from stopping
Was too hot. Yeah.
was enough to pull
Yeah.
even the little resistors off
That's amazing.
the circuit board.
Crazy.
Really quick way to desolder everything.
Oh, yeah. Except it's kind of folded afterward.
Yeah.
Wow. What
Yeah,
a-
and also like safety precautions here. So
Safety precautions?
I didn't go near the gun when it was loaded.
Like what do you mean?
So I have a long stick for opening the valve. So this is a lot more.
You didn't go near it
sophisticated.
once
this
it was
this
loaded.
one, I use oxygen and map gas
Oh, I see.
mixture.
That's a stick.
So this.
So
is
what are
my
you
stick
doing
for
with that
opening
thing?
The valve.
Opening
So
the
there's
valve?
a balloon. There's a balloon, the little red balloon there.
Yeah,
and
why
I-
is the balloon there?
to measure the gas?
Oh, okay.
Because you got to get the ratio just
To
right.
measure it?
Yeah.
You
so
measured it with a balloon?
Yeah.
Isn't that
Well, I just get eyeball it. Like, otherwise, you have no idea how much.
like
gas,
based on how the balloon looks?
how large the balloon gets.
Oh,
So
interesting.
first, I fill it with
Yeah.
oxygen, and then I drain that into the barrel, and then I fill it with MAP gas, maybe half the diameter of the oxygen, and I drain that into the barrel. At which point the gun is loaded. So at that point, you just don't touch the gun.
Wow.
And
What is that? Is that a fucking flame
torch.
thing?
I think I had a problem.
Is that
with
a
it wouldn't-
torch?
Yeah, I think it wouldn't spark, so I'm lighting it by
Oh
hand.
my god.
So here I'm just lighting it by hand because it's like it's loaded.
Yeah.
What I do now,
Exactly, yeah.
The spark won't set it off. It's
Yeah.
like I'm not touching that thing when it's loaded.
What's that's a piece of it on the roof?
Yeah. Yeah, we put a hole in the house's siding too, just from recoil. So it's like one of my things is like when it's loaded, you
Yeah.
don't touch it
Yeah, exactly.
because
With this gun specifically or with other ones or in general?
well, like this is I've got oxygen MAP gas mixture in there. That
Yeah.
is very very potent.
Yeah.
So this is where you can lose fingers.
Right.
So I'm kind of like, and so in this particular instance, it didn't fire from the I don't know, for some reason possibly from condensation inside the barrel, the spark plug didn't light it.
It didn't light it, yeah.
So I'm kind of like
And this is now
I
like,
have to light that mixture because I'm not taking that thing
Yep.
apart when it's hot.
super cool. Wow.
So
The first thing you
that's
ever-
sort
the
of-
first
you
thing you
gotta
ever-
think about what can go wrong because that's where you can lose fingers.
The first thing you ever made was like a project like this, like, you make these projects, like you make these things and you seem to just constantly be making these things. I think the first one though was like the pipe organ.
Oh yeah, that goes way back. Yeah, that
Yeah.
was in '93.
Do you have that, Robin? Was that the first kind of thing that you did like along this path?
Well, it was the first.
Like,
I mean,
this is-
I've always been building stuff. That was
Right.
really,
Was this the first like complex project
That's so crazy.
well, it
Oh
was
my
certainly
goodness.
the most complex. I mean, what are the
up until that
complex-
time?
Yeah, and it's the most visually showable. Like
Right.
hacking something together. Like I had built a homemade printer for my Commodore 64, but I didn't have video of it or anything like
Right.
that. And
You made a homemade printer for your Commodore
Yeah.
64?
yeah,
What kind of printer? Like a dot matrix?
one pin dot matrix.
Oh, wow. That's
And-
amazing.
and
That's so cool.
You know
Oh, no.
what the printhead was? The Bic-pen.
A Bic-pen. Wow,
A
that's so
Bic-pen
cool.
With a solenoid
Yeah.
that pushes against the paper or not, and it would just scan one line at a
You
time.
made one
Yeah.
out of wood. That's really...
Oh no, that was Fisher Technic and some wood and
okay.
stuff like that.
That's awesome.
It could output about 1 character per second because of course each
Right.
line of characters.
That's pretty
has to
fast
go-
still.
Yeah, that was.
That's actually pretty fast. Yeah.
Yeah, I mean the quality wasn't great, but
Yes.
it's definitely legible.
Yes. I remember being in my parents' office when they were small enough to go with them to the office, and you just hear these dot matrix printers going off.
Crazy.
Yeah. Oh, I later ended up, and then
How did you figure out how to build one? Like, did you just take one apart? Did you figure out from first principles?
well, I mean, I just knew how a printer works,
Right.
And so you build something that scans along, and then you
Right.
just need something to push the pen against the paper.
Yeah, it's basically like obvious to you, like how it should work.
Yeah.
So there's like a software layer that tells it what to print. Did you make that yourself?
Oh yeah.
That's really cool. How'd you write the software?
Well, this being, it had to be very like the timing has to be just
Yeah.
right. So that was written in assembly language on a
Okay.
Commodore 64.
That's really cool.
And I just used the bitmap characters that are in the ROM of the
Right.
Commodore 64. Like it already has all the characters defined, so I just used that font.
That's awesome.
The one font that
Yeah,
it
yeah.
has. And I just assembled each line basically like, okay, I have so many on pixels, so many off, and the
Right.
solenoid just gets timed.
Yeah,
like
it's
that.
to you can kind of like obviously see a way to solve that problem, and you have like a process to like producing the thing itself in an iterative fashion. Like you'll say like writing assembly kind of offhand, like it's an easy thing, but it's not quite so easy, especially back then without all of the information available. Did you know how to do it? Were you looking up references, or were you already like well learned at that time?
Like the nice thing about computers back then is they were so simple, so there's so
Right.
much less you had to know.
Exactly. Yeah.
So 6502 assembly language, there isn't that much to
Yep.
it.
Yep. It's basically just like a machine.
And there's some good stuff. Like there's some magazines that had
Right.
fairly good information on
Yeah.
it.
And once you have an example of something,
Books
you
that
can
were
work off
printed
of
on
it.
there about like there's books that map the entire ROM on a Commodore 64. If from assembly language you want to do this, just jump at this address and it'll do
Right.
it.
That's awesome. And like when they're that simple, you can kind of see and you have a really good understanding of how it all works. It's
Yeah.
very obvious to you how you might build like something like a dot matrix printer.
Yeah. It's like they were just, computers were simple enough that you could
Yeah.
understand them back then.
Yes. Well, I think they still are actually today. Like you just need to use the ones, you need to have the foresight to use ones that are quite simple. Like you can always, you still have access to Commodore 64.
Yeah. Or I suppose microcontrollers were,
Yeah.
then they're quite complicated, but at least you can get a bit. I love playing around with microcontrollers because there's no operating system to get in the way.
Yes, exactly. You can actually tell, you know exactly what's going to happen based on what you tell it to do.
Yeah. Although then again, it's like, it is much nicer program. So started using MicroPython and got corrupted that way. And of course now that is like an operating system in between you and the thing.
Yep.
It's interesting for me to hear like what is. Oh, also keep the mic a little bit closer.
Oh, sorry.
Or, like when you look there, the mic. Yeah.
Oh yeah.
But it's interesting to me like when you say something is like, oh, like you just have to understand how a printer works. I think some things that are obvious and intuitive to you, I don't know if they're obvious and intuitive to everybody. And and I think like even I was just looking at the way you grew up. It was like I didn't grow up the way you grew up. Like you grew up in like northern Ontario,
Yeah.
in like kind of like the middle of nowhere.
Yes.
Like, can you show it on a map, Robbie? Like, can you find it on Google Maps? Like, I think I think maybe because you're like the human in the experience, you're just like, yeah, I'm just. But I mean, as like an outsider, just like, I didn't grow up like this. Like, I grew up in like a
Search
city.
for Bruce Mines, Ontario. Okay, so we're not actually in Bruce Mines, so zoom out
So like, where did you? Yeah,
and to the right a bit.
right, isn't that the
Search,
resort?
they're just above the that Maple Leaf there. That's very close to where we lived. So
Isn't that the resort right there?
No, that's further up north. So the winter residence is right about where you're circling the mouse. Yeah.
So you grew up like right here.
Yeah.
Is it even possible to drop like the yellow dude there? Like, is that even possible? Okay, so this is where you grew up?
No, that's the highway.
Okay. Oh, that's a highway? Okay.
Give me the
so where where roughly, like, we'd have to go down one of these streets?
Yeah, exactly. So kind of on the gravel road.
Like, I didn't grow up like this.
So search for Breniff Road. Okay, hang on. Try to, there, right about there, that street. Try to, but I don't think there's so.
Oh, right there.
Go on the intersection, that's fairly close. I thought there used to be Breniff Road on there. So that's Chapman
like, does
Road.
this look familiar to you?
Yeah, that's Chapman Road.
Oh my God.
This is where we lived. Down that road a bit,
Okay. And so your dad was kind of like trying to like get, like, he was the driver of this.
Yeah,
like
he
this,
decided to
right?
move the family there from
like
Germany.
he wanted to be away from like civilization or something like that, right? So you grew up, this is how you grew up.
Hustle and bustle.
And your dad was like he was he was very capable at making things, and he seemed like he was quite an amazing carpenter.
Oh yeah.
Right. And so you're growing up in this place in this kind of like in the middle of nowhere, and you've got this probably interesting dad, obviously, who's like, I want to be away from civilization. And I think you would take like an hour bus ride to school or something like that.
Oh, yeah.
And you're coming back into this environment, I assume.
Yes.
Right. And this is like how you're growing up.
This is good.
And so,
the long sleeves are anyway.
so like, what,
The other shirt's too warm.
like, what is that like? Because I think a lot of this is what ultimately would influence any human.
Well, you ask a fish what water is like.
Yeah, for sure.
That was just life,
Yeah.
Certainly.
Is this your dad?
Yeah. Driving.
What a cool looking guy.
Driving to Toronto
Yeah.
a few times, and he's just driving on the 401 and you see 4 lanes of just like the red lights on the back of the car because it's congestion. It's like, this is insanity.
Right.
Like to see Toronto, it's like, this is just absolute insanity.
I can't believe people live in the city. Like,
Yeah.
I still can't believe people live in this city. Every time I'm here, I'm like, there's so much people. I feel like a low level anxiety every time I enter Toronto. And even when I'm walking around here, I feel like something could go wrong at any point. Humans aren't really evolved to like be around this many people at once.
Yeah. Well, I mean, Asian countries, like, they live in huge cities. So it's like the environment is the people.
Yes.
And it's like, I visit my friend Keith coming from Waterloo, and the first few times after I got my own car, and I was like, so how was your driver? I was like, oh,
Yeah.
Stress inducing.
yeah.
Yes.
But then it's like, eventually it's like, you just got to get cool about it.
Yeah.
Totally. So you're growing up here. What was your life like? Like, would you like get off the bus at school? Like when I would get home from school, I would go into my house and I'd go like right onto the computer.
Uh-huh.
And my dad was a software developer. And so there were like computers always around, and I would go get home. That's the first thing I wanted to do. And I wanted to explore the internet, and I wanted to make things on my computer. I don't know, like, what was your experience like before the computer, coming home from school in this, like, essentially like in this world of like
computer you have to redefine, because Commodore 64, there's no internet.
Yeah.
You can do programming on it.
Well, before we go to the computer, what were you doing? Like, you get off the bus, where do you go? What do you do?
Well, playing around with electronics and stuff like that. And
was there a space you would walk into? Did you have like a setup? Did you have an area that was yours? Was your dad's, was your dad like, was there a big shop? How big was the shop?
Yeah, there was a big shop. I'd build stuff in there from time to time, but it's kind of more tolerated there because it's difficult having somebody else in the shop, and especially the table saw.
Click a tour of Dad's shop.
Yeah.
So
the table saw was combined with a shaper and a slot mortiser, so that if I needed to do a cut on the table saw, I'd have to wait my dad to be done with it, or he might have something set up on the shaper, at which point I couldn't use the table saw.
Yeah.
Go to the top.
I was tolerated in the shop, and it's kind of funny. At some point, I asked my dad, "How would you do this?" And he snapped at me, frustrated. It's like, "Why do you even ask? You're going to do different. You're going to do it differently, anyways." I was like, "True." But just for reference,
you were like building things in your dad's shop.
Yeah.
And like, what drove you to build those things? Like what?
Oh, just
curiosity, fun. Like you just want to have fun. Yeah. Hobby stuff, right?
Ideas and stuff like that.
So you just come up with these ideas and you want to build it. because you're, I guess, like bored out there in the woods, and you build it to entertain yourself, or
because I want something.
Because you want something. So there's like something that you want, and you're like, well, I could probably make this.
Exactly.
And you just make it.
But I think part of it is also it's got to be like your dad, because it's like, think about it. When you're a kid, you're looking at your parents as a way of like what life is, right? So if your dad is like if you go back to that thing, click this, like look at this, like a lot of it is context too. It's like the fact that the workshop exists creates a context.
Right.
If a kid is in a workshop, they're in a workshop.
Yeah, exactly.
So it's saying like, hey, like you part of life is creating a space that you create things in.
Yeah.
Right. That's part of life. Part of life is, where are your tools?
Yeah.
Right. Are you organizing your tools correctly? What is your relation?
You're seeing someone build things all the time. So you have
all the
example.
time. And there's like nuance, right? It's like, what is your relationship with materials? What is your relationship with waste? What is not waste? Yeah. Right. And so all of that influences your values, what matters and what doesn't matter. This is a beautiful shop. If you go to the top for a sec, it says, this workshop was built in the early winter of 1986 after a fire destroyed the previous workshop and barn in November. With winter already starting, my dad decided to put the whole building on wooden posts, old telegraph poles instead of concrete foundations. Considering how some of the concrete cottage foundations worked out later on, that was probably a wise choice. This is really cool. Really cool.
Yeah, it was at the time, it was like too late to pour a slab.
Yeah.
Too late in the year for that. So let's just put it on posts.
Super cool. What was the first thing you made in this shop? Do you remember?
In the new shop?
No. Yeah. Like growing up, what is the first thing you made that you remember?
So the shop wasn't ready yet. So my dad had gone to Germany to buy some equipment, the European style table saw.
Yeah.
And I was working on the plotter.
Okay.
And
plotter?
That's also like not a trivial project at all.
Yeah. And now that one, I used a lot of Fisher technique, but I needed a good solid wooden base for it. So I just went in there, what was there, there was hardly any equipment there, but I just grabbed the board, cut it up, and a few things to that. And that was the base for it.
Okay.
And without it being set up, it's like, well, there's wood here. And
so when you need a piece for a project, do you like plan it out? When you're like, I need this component for this plotter. Do you sketch it out, figure out the dimensions that you need, or you kind of just wing it and make the thing?
I just winged it.
Okay. I like that.
I mean, a lot of times I plan things out more nowadays, but it was all very dictated by the materials.
Yeah, exactly.
So the plotter was a drum plotter, and there's these VO vodkas that came in.
VO vodka?
Yeah, that came in a cardboard tube. So there's this cardboard tube, and I'm like, that is my plotter drum.
Right.
And I had two of them. One of them was more round than the other one, so I used the rounder one, and so I need to mount this tube, and I need to have a carriage that goes along it. So my vertical axis is just rotating the tube.
Okay.
And the horizontal axis is just this carriage that moves.
So you're like kind of making it up on the fly as you find random materials around that are available.
It's not like I'm going to build this. I'm just going to see if I'm going to experiment.
Yeah, exactly. You want to find out, like you're almost like driven by curiosity to see if you can do it in a way.
Exactly.
You're like, can I actually make it? And sometimes like using less material makes the challenge funner. Using like constraining the materials that you can use, doing it like super, super cheaply. It's almost like an ego thing sometimes.
Well, it's being in Northern Ontario, it's like you got it or you don't.
Yes, true, exactly. You don't even have any choices.
There's no ordering things online. I mean, my mom might drive to Sault Ste. Marie.
Right.
Maybe every couple of weeks at best.
Right. Would you give her a shopping list of like, here are the things
it's like, can you get this part for me at Radio Shack?
Yeah.
Right.
But that was like, mostly you just kind of work with what you got. So what started the plotter is my brother he'd been home from university. And he brought this thing where he had like a couple of stepper motors hooked up to, so it could be hooked up to a Commodore 64.
Right.
And I'm like, I can use this to make a plotter.
That's so cool.
So I ended up improving on that stepper motor interface a bit to make them run a bit faster.
So you're sitting there like writing assembly.
Oh yeah, of course. Yeah. So that's very early on. So basically everything is Fisher Technique except for the base plate.
Fisher Techniques.
And you can see the horizontal carriage part. That I ended up replacing with something much lighter, made out of very light wood, which improved the performance quite a bit. So the writing here you can see is quite messy, but this is like I'd write letters back and forth with Markus. This is before email.
Yeah.
And so I'd want those to print as quickly as possible. So I basically drove the speed as fast as I could while it was still legible.
Right.
So the vertical has got a lot more distortion to it than the horizontal because that drum turned out to be much heavier than my carriage.
Right.
So I had much less control over the vertical axis than I did over the horizontal one.
This is
But
super.
that would write about
I actually cannot believe what I'm seeing.
that would write,
I can't believe it.
that would write about so now there that's so that would write about
It's like he said like totally what I was thinking.
that would write about 5 characters per second.
That's pretty fast.
Yeah, it's
That's
like,
ridiculously
that thing was
fast.
flying. Like you couldn't really follow it with.
Out of
eyes.
like
I can't believe
yeah,
this actually works.
That's remarkable.
What's
that's
this
really awesome.
this thing? What are these things called again?
It's a
Mandala or something?
Sorry, what?
What is this? What is this pattern thing here?
It's just like basically every point's connected with every other.
This is
point.
like the first demoware ever. You know, like
Yeah.
the cool demo scenes that people do.
Yeah, exactly.
That's like this is the first demo
and
scene
it's
ever.
such an easy thing to do.
Okay, so you make this thing.
It's pretty funny. You like wrote a renderer that uses the real
Yeah,
world.
you know, it's a challenge thinking about that one is so I had to do straight lines. And I'd seen an article in the Transactor magazine about that. And the core thing that you need for that is a division. You
Right.
have to do a division. Now,
Right.
The 6502, first of all, is only 8-bit. And second,
Right.
it didn't have a divide.
Right.
And I looked at the thing about how the divide routine worked in that article. I just could not figure out heads or tails of it. And eventually I was like, wait, you just do it like you do long division by hand.
Oh, right. Yeah. So you wrote the routine yourself
So I
to do
wrote-
long division
yeah,
by hand
because
with 8-bit. Okay.
To figure out where the steps go, you have to do a division. It's unavoidable. And so I wrote the division routine, and from that it became very easy to do the
That's really
interpolations,
cool.
to do the steps.
Yeah, you learned the algorithm at school. The
Not in
operation.
school,
Right, sure. Okay.
Yeah, it was
did you
school,
go to school? Or did you-
Yeah.
Okay.
But it's like there was nobody else in my school who ever programmed in assembly language.
Right. Sure. Yes. But like the long division itself, the long division process.
Yeah, of course, we learned that in school. It was fascinating is like, I remember they even taught us a square root algorithm
Right.
that worked a bit like long division, except more complicated.
Right.
That, it was like to have a procedure like that for square root, which I thought was very cool.
Yeah. That's awesome.
So your dad was not into computers though.
Not at all. Yeah.
Right. So okay. So you're growing up in this place. You're in Northern Ontario, kind of in the middle of nowhere, very different than I think how most people grew up. And then you've got this shop, you've got a dad who's constantly building things. It seems like his material of choice is wood. And then at some point you get introduced to a personal computer.
Yeah.
And I mean, what is the story of your first experiences with a personal computer?
So I was in grade 8 when the public school, so before high school, they got a couple of Commodore PETs. And
Commodore PETs?
Commodore PET.
What is a Commodore PET?
Oh, it's a computer from the 1970s.
Can I see
Came
it?
out in the 1970s. So this was in the 80s already, but that's the Commodore PET has its origins in the 1970s.
Mm-hmm.
So they got a couple of Commodore PETs, which had like 16 kilobytes of RAM and 40 built-in green phosphor screen. And you could sign out a 15-minute slot at lunch time, so take turns with somebody else. And so, of course, always
You would sign up, right?
I would sign up for the 15 minutes I could get.
So is this it? The Commodore PET is a line of personal computers.
That's the original 1970s. So the 4016, I think, is what they would have had. This is so
introductory price US $795, equivalent to $4,200 in 2025. 219,000 units sold.
CBM 4032. That would be not quite the ones that we had, but that would be about the shape of the. No, I think they were the small screen version, but that would be more of a later version.
4022?
4032.
32.
Oh, 4022. I don't know what that is. Oh, that's a printer.
This thing?
Oh, there's.
Oh,
there. So this is sort of the later ones.
Second
The larger screen.
row,
So the
first
ones in
one.
the school were basically this one right there.
This?
Yeah, this is a large. So they had when we got to high school, they had a whole room full of those, and they had a couple
Our whole room
yes,
full of them? Like how
Yeah.
many?
Oh, I don't know, maybe 15, 20.
Isn't that crazy though? Because you grew up like that. There was a school out there that had
computers?
like 15 of them. That's kind
Yeah.
of crazy, right?
Oh yeah.
So that school getting this computer basically changed your life. I mean, outside of like also growing up like in like a.
Oh well,
This is like a pivotal
I don't know what to
moment.
say about changing my life.
Well, I mean,
my life,
it
but
was your
certainly
first.
Yeah, you could play around with computers.
Yeah.
You could write programs to do things, which of course at the time is like just it computes.
Yeah.
Like holy crap!
Right. I know that was like interesting to you that you could do you could automate knowledge work of sorts.
Yeah. I mean, even just, to have a calculation repeated or something like that.
And then you would figure, like, because of your interest, you would figure out how to use it, and you were really excited to like learn about it. So you could go get magazines. Your mom would go out, and you'd tell her to pick up some magazines, or she would pick up these magazines for you because you would.
No, I just used the ones that the school had in the library.
So school had also like magazines available for you. So you just read them, and then you would do cool things on.
And back then, the computer magazines were all like for heavy duty nerds.
Right.
Like computers were not mainstream.
No.
Right.
I mean, there's people who felt they should buy a computer to not fall behind, but they didn't know what to do with it because these 8-bit computers, they weren't really all that useful for unless you're really into
like what
computers.
could you do with them?
Well, you could do word processing.
Right.
That's about the only thing useful that you could do with it. And I ended up so my brother bought a computer before he went off to university, but then he took that with him when he went off to university, and it was actually English class. So I didn't have a computer for a few months, and then I took English again. And I realized that I needed a computer for English class because I'd always get docked for spelling because I just can't spell to save my life.
So you'd use it as a spell checker effectively.
Exactly.
Okay.
And just to edit my essays.
Right.
So that's when I realized, like, now it's time to get a computer.
Right. Okay.
Because I'm going to lose too many marks.
Exactly.
On spelling without one.
Fair enough. Yeah.
So your brother buys a computer, and then that was the main computer you used, right?
Yeah.
And he bought it.
First, when he wanted to use it, he just boot me off.
Yeah. And so, I was thinking about this too. I was thinking that this might be wrong. Maybe I'm like not correct here, but I was thinking like it seems like your dad really influenced you in terms of like working with wood. But it seems like your brother really influenced you in terms of like making things on a computer and like, I don't know.
He certainly was the introduction for that sort of
thing. For sure.
He told me
Did he buy a computer from Canadian Tire?
Yeah. Oh yeah. Yeah. So
Canadian Tire sold computers?
Yeah.
That's crazy.
There's appliances, right?
Yeah.
At the end of the day, a computer's just an appliance.
Well, and it was the 80s. Computers were kind of the novel new thing.
Right.
Like I said, like there's a lot of people that bought a computer because they felt that for the kids and so we don't fall behind kind of thing, but they weren't really all that useful yet.
Yeah. So there's that like My Life as a Nerd thing, right?
Yeah, that's my brother's website.
Why does everyone in your family have like such a cool website?
Oh, for having your own personal website.
It's not that hard to have a website.
No, but I mean like
a cool thing to
this
do.
This is like
20 years ago, 25 years ago.
I still think it's a cool thing to do.
It is, but I mean like look at how dope this website is.
It's pretty awesome.
Like
I'm like a big fan of the simplicity of super simple websites.
Oh yeah, so that screen there, that's a video game Markus started
Blue
writing.
Bomber?
It was pretty good. Like
wait, he made video games?
Well, he never quite finished it.
Yeah.
A problem with this video game was, of course, as he's testing, he's playing it quite a few times, and it got too easy for him, so the game got harder and harder.
That's funny.
I felt.
Yeah, that's pretty funny.
So he never finished it, but it's kind of inspired by Ford Apocalypse.
That's probably the hardest thing to do with the computer is to make a really good video game. It's because you have to make the game engine and all these bits, and you have to make it efficient enough to run as well. Shit. Like making a video game is very, very difficult. You have to use it was very resource intensive. As well.
Well, but there's people do crazy things with Commodore 64s. Like it's sort of a retro sort of thing. So it was much easier in that you didn't need, what you're talking about, a game engine and all that. Well, just throw some sprites on the screen and you move them around.
Yes.
So I started playing around with writing my own game too, which never got as far as his game. I got I had a little helicopter could fly around the screen and shoot bullets.
Right.
That's about as far as I could get. And
yes.
It was pretty smooth that way, but then it's like, what does it do?
It's true. Yes.
Yeah.
What's happening in this photograph? If you go down a bit, there's a photograph here. It looks, what's happening in this image?
Oh, okay. So there's 3 computers on the table there.
There's 3? I think there's more than 3. Well, there's 3, and then I guess a TV or CRT or something.
That was my TV.
Can you? Yeah. So what's happening?
So the guy in the blue T-shirt on the left, that's my brother, and he loved even back then like messing around with old computers. So that's a Super Brain. It's a CPM computer that he bought used for not very much, and he got quite figured everything about it and started hacking around with it. He was much more into it than me. Then facing the camera by the chair is a VT100 clone terminal, so that's just a dumb terminal.
Okay.
And then on the right is a Commodore 64, and my youngest sister's playing a game on it because he's holding a joystick.
Wow.
Actually, there's 2 Commodore 64s, so there's mine and Markus's.
Oh, there's another one right beside it.
Yeah, right beside it. So the one behind it is mine, which would be hooked up to a small little black and white TV.
This is a basement, right?
Yeah, that's the basement.
How much time did you spend down here?
Oh, a lot.
Was this like the main? This was like the.
Well, it's like
the lair.
Yeah.
Yeah, well, so we had the wood stove going. You can see the edge of the wood stove there, and
Wood stove?
Yeah, yeah. So there's a wood stove just to the. You see the little brown thing on the left.
On the left, like beside your brother?
Yeah, so that's wood.
So what would you do with that?
Well, you put wood in it and light it.
Oh, like to keep it warm.
Yeah, yeah.
Oh, okay.
And the basement got a lot more comfortable.
You've been living in Toronto.
My brother was
for
always
years, man.
resistant to me messing around with it. So once my brother went off to university, I knew he wasn't gonna like fight me on this. So I convinced my mom. So she paid for the styrofoam, and I put
Styrofoam?
I glued an inch of styrofoam to the walls, which suddenly made the basement instantly more comfortable.
Right.
Oh,
What
I
didn't
see. I
realize
see.
at the time is that is actually like very much against building code. If styrofoam catches fire,
Right.
the fumes from that are just insane.
Yep.
Right.
So it never caught fire, so it was never a problem. But
Yeah.
it's like it. Yeah, behind the stove, I didn't use styrofoam. I just used drywall with a bit of insulation behind that. So because I knew it was like, yeah, I'm gonna be
Yeah.
careful that way.
So it was a little chilly down there.
And that made the basement so much more comfortable.
Right.
Would you
Being in a nice
say
warm-
like part of the driver for you to mess around with computers was the fact it was so cold outside all the time, and it was probably the funnest thing to do
what is
inside?
there- oh, yeah, what is there to do?
Yeah, I can relate to that. I find like people from this country and generally are more proficient with computers because what else are you going to do all winter? Like, you know, like in the evenings when it's super, super frigid outside, -30, might as well be inside using my computer all night.
Yeah, yeah. But it's like computers weren't as attractive back then than they were.
Yeah.
Like the internet is kind of, the computer is just your gateway to
Right.
the internet. So after
this
my
is
brother
pre-internet.
left, it's like I actually ended up programming a lot less because there's just
Yeah.
no one to relate to it.
Yeah.
So I remember at some point in high school, and I wrote a Game of Life on a Commodore 64, and I was kind of like, I can still do it because I hadn't been.
Game of Life isn't like Conway's Game of Life.
Yeah. Of course, an assembly language to get it fast enough.
Yep.
It turns out I had the rules slightly wrong, so it was still pretty interesting the way it
Yeah.
worked, but I didn't have the counts quite right in terms of how many neighbors needed to be live and not live, but it did produce.
Yeah. It was a set
similar
of
behavior.
rules that had interesting behaviors.
Yeah, so I had the counts not quite right, but it certainly had these formations that would spread and do a similar sort of thing.
Yeah, you make this amazing thing and your brother's not there. There's no one to talk to about
Yes,
it.
exactly. And so, like I said, there was nobody in my school that did even much in the way of programming, certainly not assembly language.
Right.
I actually had a similar experience growing up. Like, we'd have computers around and stuff like that. And one of my really good friends, he was my age. He had an older brother who was like way more proficient with computers than we were. And so, when I'd go over to I had computers in my house. Like when I grew up, people had like a family computer.
Right.
But like when my dad, because he was a developer or whatever, like I had a computer, my sister had a computer. He made this like L-shaped desk, and then the computers were on there, and he had a computer, and it was like you don't touch other people's computers, right? Like and when I would go to someone else's house, they had like one family computer. And one of my best friends, he was kind of the same way. He had his computer in his room, and his brother had his computer in his room, but his brother was older than us. And so every now and then his brother would be like, yeah, you guys can come in my room. And we'd walk in and be like, he would show us something, like something he found on the internet, some like different thing, something he was making.
Yeah.
And it was like, I don't know how to describe it. The feeling, it was just this like, it was like seeing like a superhero.
Right. Exactly. Yeah.
Like it was literally, that's the feeling I got. Like it was like looking at a real superhero.
Yeah.
And and I would be like, holy shit.
Yeah.
Fuck, man, like how do I do that? You know, like damn, that's so cool. Like it's the first time we're just being in awe of things. There was a lot of that. I
You
think
don't
like
even realize what is possible to do until you find someone else to show you sometimes. Like and then you want to impress them, and that drives you to research your own stuff and work really hard because it is very grueling. Like doing stuff on computers, like doing impressive new things on computers. You have to spend a lot of time. It's a huge time sink, like hours and hours and hours of really trying to understand how things work.
But it was not only was it seeing what he could do with the computer, but it was also my first exposure to like subcultures. Right? Because what he was making, it like it was like good in a way that like our parents didn't understand.
Yeah.
Like it was good for reasons that we only understood.
Right. Oh, yeah,
and there was like a different world, right? There was like it was a different world where like, whoa.
Yeah. So I guess like you started using computers when the internet was kind of blowing
emerging,
up. And that kind of solved the problem that you were facing when you were younger, where you have access to other people who can actually relate to you, because there's so few and far in between. People with these like very, very niche interests that are very high resource to actually get into.
Like, it's like you're saying is like, you don't touch other people's computers. Like back in the Commodore 64 days, it's like there was no my computer.
Yeah, for sure.
I put my floppy into your computer and it acts like my computer.
Yes, totally,
right? Because the entire state is on the floppy disk. There's no hard drive or anything like that. So there's no, you're going to mess up my computer. It's like you can you go wild, it's like you're not going to mess up my computer because I'll turn it off and on again and I'll put my floppy in.
That's pretty cool. Like even just sharing like things with people, like the transmission, you can build something amazing, put it on a floppy disk and just distribute it. That's
well, there was like, an active scene of trading video games.
Yes.
Because
pirating.
There's no internet to download them from.
Exactly.
Like modems did exist, but we didn't have anything at that sort of an exotic sort of technology at the time.
When did you start getting the internet? Or when was your first introduction to the internet?
Well, so the university had internet, but like the web didn't exist.
Right.
So there's no email. So I actually joined the computer science club.
Right.
So I could have an internet email address. So I could exchange email with my brother who was in Ottawa at the time. And it was amazing. Like the email would get there in hours.
Immediately. It
would only take hours for the email to get there as opposed to days for a letter.
Yeah.
It was
this
amazing.
is in Waterloo?
Yeah. And literally you could see the timestamps in the email because it went from hop to hop to hop.
Yeah.
It wasn't a continuous connection. And you look at the timestamps like, wow, that email got there in 2 hours. Amazing.
I feel like you're probably doing this thing or like sending emails for the first time and realizing the implications of the technology and realizing that the technology is only ever going to be this good. It's only going to ever be this bad. And it probably like felt alienating at the time to talk to people about the internet, about how amazing it was. Do you think other people got the internet at that early stage? Or?
Well, you're saying it's that it sucks so much that you didn't, you're just kind of going, it's like, wow, it can do these things.
Exactly. Yeah.
I can send an email and it only takes 2 hours. That is so much faster than a letter.
Yeah.
And it doesn't cost anything. That's amazing.
Yes.
So you don't say, well, this sucks compared to what's going to be in the future.
Yeah.
You're just amazed that it's even that good at the beginning.
Exactly.
I think it's also interesting that like one of the first people you emailed was your brother.
Yeah. Oh, like we had, so I had this old typewriter and like we'd send letters back and forth.
You and your brother.
Yeah.
Where were you and where was he?
So he was off at the University of Waterloo and I was still in Northern Ontario.
Oh, okay,
so
cool.
we'd send letters back and forth and I had this old manual typewriter.
Yeah. Do you remember what it was called?
Sorry, what?
Do you remember what the typewriter was called?
A Remington, I think.
A what?
Came from my art teacher. It was a Remington.
Remington?
Yeah.
I love typewriters.
And it's a manual typewriter. And the typing I did when it was pretty messy because I took typing class and the teachers emphasized like having good rhythm.
Right.
But I would just, because I mostly typed on computers.
Yep.
So I learned to slow myself down enough so the hammers didn't hit each other.
Yeah.
So I think I kind of learned like certain key combinations. You can't quite type like on a computer because you got to give time for the previous hammer to withdraw.
Yep.
Yes.
Before you hit the next one. And the QWERTY keyboard is actually designed so it has a lot of left, right.
Yeah, to slow you down.
Because if you have adjoining keys, the hammers have to come back a lot further before the next one can not hit it. But I would hit the keyboard so fast that some of the keys, a lot of the characters were like not in the right position because the carriage didn't have time to advance before the next key came.
I guess you could probably solve this problem then with your plotter.
Yeah.
So you built a plotter to solve this problem effectively.
Yeah.
The weird thing about typewriter keyboards is that like you said, it was designed to slow down that mechanical process.
Not so much slow down, but
avoid the hammer.
The hammer thing.
Because if you get two hammers trying to go through that one spot at the same time.
That is also like people say it's like they did it to slow you down. No, to have left, right.
Right.
And that actually is also very conducive to typing. So if you've got like sometimes I've like some kind of command that you have to type and it's entirely in the left hand, it's like ugh. Whereas if you go left, right, you can go a lot faster.
Right. Interesting.
So the criteria for making the hammers not hitting each other was actually also very conducive to typing fast.
Oh, really?
So
I've heard the opposite. I've heard that it's kind of like a funny quirk that the keyboard layout of a typewriter was designed so that it would kind of set a limit to the overall pace that these hammers are moving through.
Yeah.
Like a delay between. And it's kind of like a funny little quirk that with computer keyboards, we adopted that same layout even though
Yeah.
it has nothing to do with a typewriter at all, and I think it has more to do with trying to get people to use computers and just saying like, look, it's just a typewriter with a screen.
The Dvorak keyboard is, admittedly is faster, but the thing is, it's like 10% faster, and it's just not worth the switching cost. And so we're gonna be stuck with that forever.
So your brother went to Waterloo as well?
Yeah. And that inspired, that to me is like, we went down for campus day and I saw the university at the same time he did. And, he told me about all kinds of stuff. So it's like, it seemed like an obvious thing to go there. So I applied to 3 different universities, and Waterloo was one of them. And they offered a small scholarship. I think I could have gotten a slightly bigger one from a different, but it's like, I liked Waterloo. So it's like, it just seemed like I wasn't strategic about it.
Right.
It was,
all the universities here in Ontario are pretty good.
Yeah.
Like generally, if you want to learn, you can learn.
But I think it's like, for being a tech nerd type of thing, Waterloo was just the place to be.
Right. You could probably could tell by the people you meet there.
Yeah.
Probably by the things that your brother said to you as well.
Yeah. And it was just amazing coming from Northern Ontario. It's like, there's so many smart people here.
You go to a place where you find people who could be your peers, who are interested the same length that you are in the things that you're interested in. Yeah.
So I had this sort of, coming to Canada, I remember at some point I formulated opinions like, Canadians are not as smart as Germans, which of course is a very prejudiced and whatever kind of, and I realized like, that just can't be true. But then when I went to Waterloo, I realized like, you know what? Given my sample of Canada, it was true for.
Right.
Mm-hmm.
Because I was in Northern Ontario, and if you want to be somebody and make something of yourself, you move away. And so there's a negative selection bias that's happening.
Mm.
And so it was true for the subset of people that I had met.
Mm-hmm.
And I mean, a friend of mine, he was from Belleville. I said, like, he referred to it as a recessive gene pool. And I was like, what do you mean by recessive gene pool? And he's like, well, all the active genes have moved away. So like Belleville is, a lot more central than Northern Ontario, but I guess it's also a bit of a backwater compared to places like here.
Yeah.
Those societies like get rented by like the attractors of the cities and all the opportunity, and people will just go to the clusters, right? Like I feel like to some degree the internet can help. Has helped reduce that a bit.
And I was like, that's this whole remote work. I was like, cool, get people out of their bubbles.
Yep.
Because this is not representative. You live in Waterloo or Toronto or California, San Jose or something like that, and your impression of the world is totally out of kilter with what society is as a whole.
You cannot believe how bad San Francisco is these days in terms of being a bubble. It is so bad. It's like, come on, guys, like you should leave the city sometimes and talk to people who are slightly different than you.
Yeah.
Why is it that like I'm looking at this, like maybe I'm reading too much into this or something, but your brother, he like, I don't know, man. This is like a really cool website.
Oh yeah.
And like just like the focus on documentation. He's like, hobbies that I've gotten excited by include photography, bicycles, physical fitness, automobiles. Like this is like a very artistic person.
So yeah, this website is so year 2000.
Yeah, I think the Microsoft front page, right? Like the
this is before front page.
Even before that.
Yeah.
So like, who is his like?
Text editor and you write HTML. That's how you do it.
Yeah.
It's like, but who are the references?
There's no CSS that
exactly.
exist.
Yeah.
But like, who are his references? In the sense like when I look at this person, like even if you go back an image, it's just like I if I was just, this guy looks to me like he could be a filmmaker, he could be an artist, he could be an engineer, but he leans more when I read the documentation, the style of the photos, this strikes me as a person that is very artistic. Like, look at this image.
Yeah, he had, like in our family, we don't have artist pretenses. So it's like, oh yeah, that looks cool.
Yeah.
So it's like, oh, that's a cool.
But what about, were you guys watching like movies or like?
Well, on TV, yeah.
Yeah.
But we weren't all about, it's like, we weren't about the cinematography or anything like that. So it's just like, sometimes it's like, oh, that's a cool composition. So you just kind of stop and take a photo.
Super cool.
And we got into black and white photography at some point, because that was a cheap way to photograph.
Right.
And you just develop it yourself. And it's like, wow, it's like, I can have the developed photo the same day I took it. That's amazing.
Damn.
That's awesome.
Wow.
Again, it's like
Yeah.
different perspective. And it only costs 15 cents a photo.
Yeah, exactly. Yeah.
As opposed to 40 cents or
Right,
so when
yeah.
you're getting it developed.
Yeah.
Can you? So after this, you kind of were first exposed to woodworking from your dad. Then you started having early experiences with a personal computer.
Yeah.
You and your brother really start jamming. That seems like a big special
so we're
moment
kind
in the basement. You guys are always making
I missed him
shit.
when he went off to university.
Of course, yeah. You miss him when you miss him. Sorry, when he goes off to
on the other shirt now, I'm getting cold. Temperature's just not quite right for me. But I like it cool. In the house at home, I'm always dressed with a shirt like that, and then this fleece on top of that. And, keep it set low.
So yeah, so so he leaves, and now you're kind of on your own.
That's
He's
right.
in this place called Waterloo,
Yeah,
and then I guess a few years later, you end up in Waterloo.
that's right.
Okay, and so when you're in Waterloo, this is a pretty pivotal time as well.
Oh, yeah.
for you.
Oh, it was amazing. The first.
What was it like?
So you get a sense of passing time, and it's it was kind of that first semester, from September to Christmas time, that was 2 years. It
Right.
felt like there was so much new stuff.
Yeah.
Because I felt kind of up to that point, it's time's just kind of flying.
Yeah.
And suddenly it's there's 4 months that went by, and they took
Really long time. Yeah.
felt like 2
Yeah,
years, because
yeah.
there's so much new stuff, and how our experience of time is a function of
How much?
newness.
Yeah. Exactly. How many new experiences you have?
And so it was kind of wow.
Yeah.
So that was the first semester. It was amazing.
Right. Yeah. And it was mostly probably from meeting other people or
Yeah,
and who are
the
interested in the same things. Yeah, the
courses,
courses
and,
themselves.
that
Yeah.
are more technically challenging and stuff like that.
And it's
there's
also
labs.
the access to the labs as well to
Yeah.
actually do the thing itself.
Yeah, and peers that are smart,
Right.
And just having access to things,
Right.
there was KW Surplus where you could buy all kinds of random junk, and it
Right.
was
KW Surplus.
yeah. Oh, it was truly a
pull
surplus store at the time. Now it's military this and that,
Oh,
but
yeah.
it was all technical parts,
Right.
and
Exactly. Yeah.
crap like that. It was
Yeah.
just an
don't have to
amazing
wait. Don't have to wait when you need a part. You don't need to wait anymore. You can just go and get it.
What
yeah,
year
you can
was
still
this?
find it.
Is this it?
So I started university in 1988. Oh yeah, with the tank out front.
It had a tank.
Yeah.
Whoa. So you started.
Yeah.
So what was Waterloo like in 1988?
Less developed.
Yeah.
So there's all much smaller. So a lot of stuff that's there wasn't there back then. So it was
Water under the bridge.
I mean, again, it was that existed. That was still fairly new. That had only been built a year or two before I got there.
what is this?
That's the Davis Center.
Oh,
That was the fancy new building back in '88. I mean,
Right.
they've built a lot of stuff since then.
Do you know what this is about? The faculty are revolting. I told one of my colleagues as we shared a congenial drink under the bridge one evening in the summer of 1988. They certainly are, he agreed. And I hastened to tell him that I meant the particle, not the adjective. The faculty were, in fact, revolting that year, directing their frustration and disapproval against two of the university's senior officials in particular, Doug Wright, the president, and John D'Alandria, the vice president. Wow.
Yeah, I had nothing to do with that.
You don't know anything about this.
Yeah,
You had nothing to
certainly
do with
Doug
it.
Wright, I remember it was the president for the longest time when I was there. Yeah, and they had proper.
Was this how it was like? What
Got
was
a
this? What it was?
computer?
Yeah.
Like?
Who cares about the university politics? Just let me in the computer lab.
Yeah.
Was this what it was like?
That's already a bit later
Oh, I
because
see.
but what they actually had most of the computers were PCXTs,
Go back, Rob.
4.77 megahertz PCXTs with 640K RAM,
Which is more than you've ever.
Like that.
and
had access to.
no hard drive because they're all networked with the Waterloo's own LAN technology.
That's really cool.
Yeah.
Wow. So you're growing up here. It's like a whole new world for you, obviously.
yeah.
New people. And then I guess,
Oh yeah, the service tunnels. Oh yeah, that was quite a few years into it. But
what is this?
so these service tunnels only existed in myth because there was no web yet at the time.
In myth, as in people,
the
students
sort
just
of
talking about
mythology
them.
that there's this tunnel network.
Yeah.
And this came from Feynman. I had thought of this technique for picking locks, and I was reading Richard Feynman's Surely You're Joking, Mr. Feynman. He
Yeah.
described. He also mentioned lock picking. It's I used a wire with a bump on it, it's like, oh, so this technique actually works. Like I had thought of this. I wonder if this would work. And
you like knew how a lock worked.
Yeah.
And then you had the assumption that, well, obviously it would be easy to pick a lock.
No, I didn't think it would actually work, but Feynman described the technique. So I was like, I knew exactly what he was talking about.
Yeah. Okay.
Because to lift the pins, that they would get stuck in just the right place. Because as you're applying a little bit of torque to the cylinder, things are not super precise.
Right.
So that the pins will get stuck right at the plane where they're interrupted, where it's supposed to shear. And if you jiggle them enough and lift them enough, eventually you get all 5 of them stuck in the right place, and then you can turn the cylinder.
Interesting.
So I was actually in my first co-op term when I tried the technique first, and they had these padlocks on the toolboxes, which turned out to be really easy to pick.
Right.
So like I could get one of those open in seconds. They were just the right looseness.
Okay. Interesting.
And then talking with some friends is like, where it's like, oh yeah, let's
do it.
Started picking open some random locks. And stumbled at some point. We're just in the Village 1 residence, which was connected to the tunnel system.
Yeah.
Just opening pick some random doors.
Yeah.
And eventually
just to try and find these tunnels.
Yeah. And then we get to this grid, to go back to the first photo. And I was just like, holy crap. It just goes on and on and on. But there's a locked door. And it felt like forever to get that. It's like, okay, I got to get that open. And my friends were watching it, and I was like, damn it, just open, open up. And eventually I got it open. It's like, whoa.
Holy shit.
That's awesome.
And so we're exploring all night in the tunnels.
Oh my God.
We totally hadn't been planning to spend the entire night in the tunnels.
Yeah.
And I don't know, at some point we panicked and exited in one of the engineering buildings. So then we are wearing like T-shirts.
Yeah.
In the winter.
Yeah, in the middle of winter.
In an engineering building. It's like, well, now we're walking back outside.
Yeah. So when did you go back? When you put this when did you put this post out?
Oh, that's part of my original website.
No, I mean, like, did you put this shortly after you guys did the tunnel thing?
No, because there's no web yet.
Oh yeah, okay, yeah. So you told people that you were down there though?
Yeah.
And then you took these photos.
Well, it turns out it wasn't as novel as we did. So there's
really?
a friend in my systems engineering is like, I said, I just use a master key. It's like, you have a master key? It's like, yeah, one of those. It's like, can I copy that? It's like, sure, no problem.
I guess these tunnels are convenient because you don't want to be walking out in the cold to get to your classes, right?
Yeah, so that so the master key at some point, I don't know, had gotten out of hand, and a lot of people copied it. And I was fortunate enough to use, there was the thin one and the thick one. So I copied it onto a thin pattern, which fit into more locks than some of the other ones. Now the university knew that these had gotten out of hand, and certainly where there's anything that was important was secured with different locks, which were medical locks.
Yeah.
And the first time I saw medical, I was like, wow, this is like made for picking because it's got such a wide slot. But there's not one medical lock. I'm sure a lockpicking lawyer would be able to open one of those, but I never got a medical lock open, even though they have such a beautifully wide passage to get your lockpicks into.
Yeah.
But the pins also need to be turned in just the right way. And so I never opened one of those, which is just as well. Although at some point, so there's 3 of us who liked it more quiet, and there's a bunch of rowdy people on the floor. This is like 3rd year.
Yeah.
And at some point they're out partying at Oktoberfest, and my friend Keith, the guy you met.
Yeah. Oh, so he went to Waterloo.
Let's go. Let's grab something from each of their rooms. So we knew I couldn't pick those locks open, but I built a device to open those doors anyways, which worked on all but one of those guys' doors.
Wait, so you robbed them?
No, we took a personal item out of each of their rooms and put them in the lounge. So they knew that we'd been in there, which made them believe that we had a master key, which we did not, but we didn't do anything to try to dispel that rumor.
Oh, you just wanted to, yeah.
So they were freaked out. Like,
do you know what this thing is? Waterloo man among adventurers who roam underground tunnels.
Oh yeah, that went in the newspaper, yeah.
Is this about you?
It must have been a slow news. Yeah. So they interviewed me.
About this tunnel thing?
Yeah.
Damn. That's awesome.
So that was in the KW record at some point.
Super cool.
I think it might have it was close to the front page too. I was like, must be a slow news day.
I mean, it's interesting though. Damn. So at some point, you're kind of like you're in Waterloo and you're hanging out with these other like minds. It's like a whole new world based on the way you grew up.
Yeah.
Like, it's not just your brother. You realize that there's like a world of other people that want to tinker and make things and do stuff. It's cool. And I guess it sounds like you made like a lot of really good friends during that time.
Well, I'm not the most sociable. And like the thing is, I was already kind of too nerdy for most of them, even in engineering.
Yeah. Like, what do you mean?
Well, most people who go through engineering aren't that nerdy.
Yeah, it's more of a means to an end.
Yeah.
Right.
Like there's a huge difference between someone who's legitimately interested in it, and so a lot of people are kind of go through college through means as a means to an end. And sometimes people who don't go to university but do it on their own volition tend to build more expertise in the thing itself.
Yeah.
And I feel like more and more over time, university is becoming less of a place to find these like minds.
Yeah.
This is my impression.
Well, there's only so many of them.
Yeah, exactly. There's only so many of them, and it's hard to find people who are that motivated to be that into something and push things all the way through.
This might be a super dumb question, but I'm just gonna ask it anyways. When you say like most engineers are not that nerdy, like what is a nerd?
Well, it's just somebody who really like on their own just loves to play with the technology,
right?
And who writes programs just for the heck of it and stuff like that. So a lot of people is like, well,
it's
like
like
a path career.
How much you push to get to a certain point.
Right.
Like nerds will really push very far, a lot further than the average person would to satisfy an interest. So someone might have the same interest as you, but someone might be more nerdy about that, and just like the degree to which they push.
And to solve problems that don't really need solving.
They don't need to be solved, exactly. Just because, it's kind of like a masculine ego thing. I think a lot of the time for me personally, and for people I think are also nerds, they just want to see if they can do it. They like almost being able to solve the problem is a quest to find out if they can solve the problem.
Right.
Yeah, exactly.
And like the end isn't actually the goal. It's like really just like, can I figure this out? Like, and when you do it enough, it becomes like a fun little game to play, like and imposing constraints on yourself is a really great way to make it more difficult. And for me personally, the thing I'm looking for is actually the respect of other nerds. That's actually the thing I'm really looking for, which kind of sucks if you're like, stuck out in Northern Ontario and there's no other nerds that appreciate how difficult, how much sacrifice you've put in.
And I didn't have to impose constraints. There was plenty of constraints to begin with. Like, it was like, oh, I just buy this part from AliExpress and it'll solve it for me. It's like, you have what you have.
Yes.
Right.
Today, like, I feel like writing a computer game, you can just load up an LLM and ask it to write the game for you. But it's not impressive anymore. What is impressive is doing something that's actually difficult, something that's like constrained. If you do it with artificial constraints or even actual real constraints, it's a lot more impressive.
Yeah, but if you write this game by hand, nobody's going to really appreciate it.
It's true. Yeah.
But then it's like if it runs on a Commodore 64, that is a constraint that is like very real.
Yeah. There's a entire subculture of people who like try to get LLMs and machine learning models to run on older computers. Like they're just.
Can you find that, Robbie?
Well, one of my LLM tests is like write this routine in 6502 assembly language.
Yes.
Which, to see how, they've gotten better even at that sort of thing. Not that 6502 is that obscure, but
they're pretty good
kind of
these
like,
days.
a little bit off the beaten path.
Yes.
And like even the local LLM on my PC at this point, it's like, oh yeah, it knows how to write 6502 assembly language.
They're getting crazy good.
Yeah.
It's kind of nice though, because it helps remove the toil of doing these things. Like I probably for your drum project and your dot matrix project, probably writing the code was the thing that took the most time. This is why.
Oh yeah.
By far.
Yeah. Oh yeah.
But now that part has been sped up considerably, the possible things that you can make have like probably exploded.
Yeah.
Because the constraint on your time is now removed.
Yeah.
There's so many amazing things you can now build because code, like writing code to do the thing was the bottleneck. Well, and you still have to understand and know what you want.
I feel almost like LLMs were made for me.
Yeah. Because you're building with your hands and doing things in the physical world.
Spelling is a major problem for me. And I would miss, it takes me 10 times, I write this 20-line routine. Well, it's going to take me 10 shots at the compiler before it compiles because I mistyped my variable.
Exactly. And it's almost like it's a typing aid almost. Like, and you're going to very much precisely spec out exactly where you want the memory to be and how you want the data to flow through your computer program and like what kind of operations it's actually going to do. But it makes the writing part itself 20 times faster, 100 times faster. It's ridiculous. It's
but the thing is, sometimes you just want to fart around because you're not sure what you want. But it's like, if I'm going to get it's like, I'm not going to bother with AI on this one because I have to really describe it clearly.
Yeah, exactly. Sometimes you have to describe it so clearly that you might as well just write the code yourself.
Yeah. So when you're not quite sure what you want and you just want to fart around a bit, sometimes Yeah, it's like, okay, if I know exactly what I want, then I can tell the AI to do it, and it'll do a good job of it.
Yes. One of the videos that you posted recently I really liked was when you were using your CNC router to do the PCB traces, and you wrote your own program to do the CNC movements.
Yeah.
And I feel like a lot of the time, software like that, you would have never written yourself.
Oh,
but
no.
then when you have an LLM doing it for you, it increases the value of the hardware that you already have. It increases the possibilities of what you can build.
Yeah.
That's like super, super cool.
Why, like, don't you think that changes the relationship with the difficulty of projects though? Like in the sense, like it is kind of like making it easier. So that obviously changes something, right?
It pushes the difficulty to the creative part.
Like,
being
what do
able
you
to
mean?
see what is possible if you mix things up the right way.
It's in some ways like a higher level programming language.
Interesting.
So people might have felt the same way when compilers came along, like
Right.
to be able to, or let's say writing Python code,
Yep.
compared to in the 1950s when people were writing machine code, like ones and zeros to run on their.
My mom would have these, put the punch hole cards, and she would sew some of the holes back on when she would make a mistake.
Yeah.
She went from that to writing, assembly, to writing C, to doing C++, to doing Python.
Yeah.
Java,
So I
Python.
think like programming the first computers to programming Python is a bigger leap.
Yes.
Except there wasn't one leap. Like LLM is like suddenly it's upon us.
Yes. Yeah.
I mean, okay, the LLMs have gotten better, but in such a short amount of time. So going from writing ones and zeros literally to writing Python or something like that is a bigger leap than going from that to LLMs.
Can you just describe why?
Well, just the labor savings.
Right.
So I actually, this anecdote, somebody, von Neumann, the famous computer scientist, is like, oh, I wrote an assembler, that helps us do this. And he was upset. This is like, we do not waste computing power on clerical work.
So, yeah, exactly. Yeah.
Like, I was like,
Yeah.
put that into perspective.
Yeah. Yeah.
Because computing power was so precious.
Yes.
Whereas nowadays it's like, oh.
There's spades of it everywhere, and every single device in fridges these days, unfortunately, have enough computing power to basically be a mobile phone. It's kind of
I was playing around with this. So it's like, to put this in perspective, if you got to do an LLM query and it takes it, 10, 15 seconds to solve, it's like, well, how many computations is that? Okay.
quite a lot.
And let's see, how many grains of sands are on the dunes in Prince Edward Island? So that LLM query,
Yeah.
if you think of every grain of sand
Yeah.
on Cavendish Beach as a computation,
Right.
that LLM query is one computation for every grain of sand on Cavendish Beach.
Yeah. It's
Holy shit.
That includes the big dunes behind the beach too.
Yep.
It's just insane.
It's remarkable how cheap they are, actually.
Yeah.
It's remarkable how cheap the LLM subscriptions and queries are per token.
Yeah,
Because it's
yeah.
doing so much computation.
Yeah.
It's
It's like it makes no sense to run local LLMs unless you have a really good reason that it has to be local, like confidentiality.
Yeah. Or it's like a cold day.
It makes no sense to invest in your own hardware because things are still evolving so rapidly.
Yeah, they're very,
it's
very,
just
very fast.
it's just wasted money.
How are you using LLMs?
For programming a lot. So I've done a lot more programming. It's just made it more fun.
It's just, you're still thinking computationally.
Right.
And that's the fun part, is like thinking about how to solve the problem, but then the laborious task of sitting there and like looking up the documentation and checking back and making sure that you're running the compiler. Like
Figure out how the APIs work.
Yeah, exactly. It's a big pain in the butt.
It gets you a working thing. Of course, then it's like, okay, I can improve on this.
Yes.
And it's gotten like just in the past year, it used to be you get LLM to do something. It's like, okay, now change this, or now change that, and now change that. It's like, okay, that's as far as I can go because now it's starting to forget what I told it in the first place.
Yeah.
I'm losing context, but the LLMs have gotten in the past year so much better about essentially distilling past context so it remembers the important bits.
Right.
So that, was it last fall or something? And I was like, wow, I just kept going on and on and on, and it didn't lose it.
Yes.
I was using Google Gemini at the time, and I thought Gemini is amazing, but I think it's just they've all kind of
Every other month they get better and better.
so that I can just keep playing around. Like I don't have to restart the project or something like that. I can just keep that context and keep adding to it and revising and revising and revising, and it just seems to.
Now I
remember things.
actually interact with it through my command line interface. So I load a computer program, a command line interface, which actually allows the language model to run tools like bash tools. And then I SSH to my server from my phone, and I just text it over my phone to tell it to do things like, hey, there's so-and-so file in this module. Can you try this experiment out? Can you try this different rendering method? And sometimes it does make mistakes. I'll review the code on my phone. But it's
I don't trust. I'm a little bit
That's nuts,
like I prefer LLM to be in this box, and I'd rather cut and paste out of it myself, so that
yes, you can review every single change it does.
Exactly,
It's taken a lot of discipline for me to like make sure that every single thing it does, I understand, because I feel like if I lose the understanding of what's actually happening, I lose the ability to figure out what the next step is.
And I've been watching a lot of videos. There's this one guy who is a bit of a pundit. I don't remember his name, but he keeps talking about AIs and such. I decided to temporarily subscribe to him, but of course these guys kind of get repetitive. But he's like, the highest level of AI is just basically AI owns the code.
Yeah.
But then, that of course you building up technical debt in some ways.
Yes, you are building up technical. You need to understand.
Say, no, you shouldn't do that. And I'm kind of like, well, I'm just kind of conservative that way.
It's like an engineering manager. An engineering manager needs to understand what code that they're like the engineers in their team are committing, because he's making higher level decisions, understanding where other teams that he's interacting with. You still need to understand the code, even if you're offloading the work to other people.
Well, I disagree with that, because you can be a good engineering manager who has a good enough sense of who to trust.
Okay, yeah, fair enough.
That they have a sense of how it works, but they don't necessarily have to get into the code. So I've had good managers that
okay, fair enough. Yeah,
didn't necessarily go. I mean, they have a good understanding of the technical problem and what's doable, but they're not necessarily looking at the code.
That's true. Yeah.
When you move to like higher and higher levels of abstraction like that, like for example, like the API, you don't have to understand how it works, right? How do you maintain that discipline? Like when you go from something like assembly or something to like Python, right? Like there's a level of
you need to understand what your computer's still doing. Even if you're writing Python, you need to understand how that Python is being executed, because it gives you the ability to push the limits.
I do find it a little bit. It's like, if I'm writing JavaScript, it's like I'm standing on top of this heap of stuff, and then people, it's like, and I use this framework, and it's like, what do you mean? It's almost like I'm already standing on top of a heap of
adding
stuff,
more
and
slop,
you want to be another layer on top of that. It's like, excuse me, I'm already more high level than I'm comfortable with.
It pushes you to, when you get too far from like
the hard work.
Simple. When things are simple, they're more difficult to do. Maybe it's more, you have to be more careful. When you understand things a lot better, and it allows you to do things that other people wouldn't be able to do. It allows you to use the resources a lot more effectively.
Yeah, a lot more efficient.
Like, it allows you to provide interfaces to people that feel good. A lot of software today is very slow and clunky. It doesn't need to be slow and clunky. You just need to understand what your phone, computer, et cetera, are doing to render the thing. And it can render instantly. It can render, like, websites don't need to be slow. They need, like, the HTML pages that we were looking at for your brother and your own. They load instantly. Because it's an HTML page. Why are you loading all these frameworks on, adding all this complexity? People prefer ease over simplicity, but simplicity is what gives you optionality in the future, because you can build, you can build on the drum project that you built for the plotter that you built. Was only possible because you understood things from the fundamental, like how they work. You can kind of, and when you can do that, you can kind of project further in the future of what's possible when you fully understand the
I
principles.
have this theory that, it's probably easier to understand an assembly language program from the 1980s than it is modern software. Not that assembly language makes it easy, but there's just, people had to keep it simple. First of all, there's a much higher threshold. You have to be much better to actually get anything done at all. So the people who were writing the code were much better, and then you had to keep things simple, because and now it's like there's pulling this and that and the other thing, and there's less penalty for complexity.
Because coding has gotten so easy, now I don't use any frameworks, or I use as little frameworks as I possibly can for my work. If I ever need something, I can just program it myself, and that way I fundamentally understand how it works, because I was the person who designed it. So I know about all the quirks and the edge cases that I need to manage or deal with.
When you say program yourself, you mean you're using?
I'm obviously not handwriting the code. It's a lot of code.
So I just spit it back.
You get the LLM to regurgitate the piece of the framework that you want.
Exactly, precisely. You can even actually ask the LLM to go pull the framework and then go find the specific function that you want, and then add only that function, and then you can read that function and add it to your code base. So you don't have to take on other people's tech debt into your own software. Keep things fast.
So in a world where you have like AI, and it enables you to do so many more things, it's like what is nerdy or what is interesting, I guess, change, like the level of difficulty of what you're pursuing has to increase by a lot.
Yeah, or like
Yes.
the
Right.
outcome of what you're doing has to increase a lot. It was
The
really,
outcome?
Like, yeah, it's really about impressing other people. Like that,
Yeah.
for me personally, that's what it's about. Is like impressing other people.
Yeah.
And it has to be more difficult. So like, you know, you can do this by finding areas of improvement that are unavailable to others because they're not willing to do something that's difficult. For example, how cheap something can run, or how crappy the hardware, or how generally available the hardware it is that you're getting this thing to run on.
Yeah.
Like that, like I think like there's like a lot of difficulty at the tails of these different qualities when you can push things to the limits. So I think that's what it is. Like for me personally, it's like finding like little edges to push. Cheapness is like a huge part.
Are there any examples that you know of that are like, oh, you saw a project where you were like,
dude,
oh
there's this
shit.
guy on YouTube. You probably might know him. His name is CNLOHR, and he got ESP32 to send out radio messages over LoRa by bit banging a GPIO with a wire attached to it and using the harmonics of the EMF to send messages over the air. It's called LoRa. Yeah. I can't believe he's done this. I cannot believe.
Yacine, can you explain this?
So there's an ESP32, which is a microcontroller.
Yeah.
And you can turn on GPIO, which is one of the little little wires that could go out to machines. And the GPIO can do things like turn on LEDs and stuff.
Yeah.
And you can turn it on and off really quickly. Mm-hmm. And he was able to attach a free hanging wire to one of the GPIOs.
Which is that thing.
Yeah,
right
exactly. And then he was able to turn on the electrical signal on and off in a way that the harmonics.
The modulation is kind of. So I've hacked this. I made a video about it too, like a remote control, 49 megahertz remote control toy.
Oh, that's
So I
awesome.
was actually able to generate 49 megahertz or some approximation thereof, and actually control the remote control toy just by
That's awesome.
toggling the IO line.
Yes.
Although I used the PIO state machine in PyPico.
How did you like figure out how'd you reverse that? Like, how'd you figure out how to send what messages were what?
So this started, I was just playing around with the cheap scope that I bought.
Okay.
Which I was like, I should be able to pick up what this transmits.
Right.
And so I just put the remote next to the scope.
Okay.
And it's like, oh yeah, there it is. And it's like, oh, this is so crude. All it does is on and off.
Yeah.
And then I started reverse engineering. So like different patterns of controls just had different patterns of on and off. I was like, well, I can do that.
Yeah.
And then it's like, okay, so then next problem is I need 49 point something or other megahertz. So it was not a nice clock multiple.
Right.
So once again, I was like, I don't think LLM can do it, but let's challenge LLM.
Right.
And it's like, oh, I'll just use the PIO state machine to do blah, 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 blah. Which, it didn't get it quite right, but it's like, oh, that's a good idea.
It kind of gives you, it puts you in the right direction sometimes.
So, it's like, I know what it's getting at, and it's got it didn't count for these clock cycles here, so I'll just fix that up.
That's awesome.
So
man.
I use the
That's
PIO
cool.
state machine to make this non-even clock multiple. So I'd go like, instead of going 1 0 1 0, it'd be like 1 1 0 1 1 0 1 1 0, and then every once in a while I'd go back to I'd have to phase shift a little bit. So, but overall, like the frequency counter, I'd use this frequency counter on a scope, and it's like, I counted it right.
That's awesome.
And just a short little pigtail, and that had a range of about 5 meters for I should have used a longer wire that would have more range, and that could control. So I could.
You're doing the project. You're looking outside for the van with the black van with the antenna on top.
Oh, I wasn't too worried about that. I did much worse when I was looking at it. I actually literally interfered with some people at some point. I had this. I had built a base station, which like Mobitex, that was audio frequency. Mm-hmm. And so I just used a scanner to figure out, okay, this channel doesn't seem to be in use. I'll use that channel. And at some point, just listening to it with a scanner. So somehow they must have had the uplink and downlink in the same spacing, because I could hear somebody talking on the uplink.
Yep.
Did you hear that? Man, that's brutal. What is that noise? It's like, oh, that's me.
Oh my
Maybe I should switch to a different frequency.
Oops. Yeah.
So that's
amazing that you were able to. You basically did a similar version of this project.
That was with what I did back at Program. That was just using test equipment. That was way simpler. Yeah, and what I did is to get the modulation. That is not trivial. That's the hard part. Yeah. So all I had to do is turn 49 megahertz on and off.
Because you understand what these machines are effectively doing, like how they take the clock and how you can run instructions off of those clocks. You can do projects like this.
But people have done actually FM transmission, like FM radio transmission with a Raspberry Pi.
People have done analog. This guy's done an analog output and then an STSC or something.
Yacine, can you explain to me the free hanging wire bit?
It's basically an antenna,
right?
And you can bang it in a certain way that the harmonics can create I don't know how electricity works yet. I'm still learning, but basically, EMF is a property of electricity going through. It's just magnetic waves.
Antenna is just where the electrons go flying off the end.
Yeah, pretty much. Yeah.
Holy shit. So it's just like a wire where the electrons.
Well, it's like when you have like those old telephones with a giant antenna on top of them. Right?
Totally.
That's what it is.
The antenna is like so the thing is electricity. It goes a lot better in wires, but especially when higher frequencies, actually, it goes a lot better outside the wires. Now, LoRa is kind of getting...
It's like a certain way to modulate the information. So it uses this chip pattern, and there's a modem involved in it. And basically the way the signals are propagated out allows it to travel a lot further distances.
Right.
Not sure why, probably just physics.
Well, actually, the funny thing is, like, when working on Mobitex, it's like, imagine... you have a base station and you got the radio here. If I took and the base station is 1 kilometer away. If I took a coax cable and hooked it up to the antenna there and ran it to my modem here, or let's say it's 2 kilometers away, the signal traveling through that wire would be less than if you put an antenna on both ends of them, because it would be so attenuated by the wire, because it's a dB every couple of meters or more than that. So basically the attenuation through the wire is greater than through the air.
Interesting.
And for the microwave towers, that used to be very commonplace. Like they don't actually have, I believe they didn't actually have a wire going to the horn antennas at the top instead of waveguides. So you send it as a wave through a pipe, essentially.
Fascinating.
Because the attenuation for high frequencies through wire is just so
really
high. Yeah, it's really bad. Yeah. But so if you're talking like 60 hertz, like that's going through the wires. Like there's a trivial amount that goes through the air.
Yeah.
A detectable amount, but it's nothing. Whereas you get to gigahertz, it actually goes through the air a lot better than it goes through the wire. And so you look at like a little microcontroller that has an onboard antenna, and it's an area that's like 2 centimeters by half a centimeter is the antenna to get that into the air. It's like, it's nothing. It's just a bunch of traces on the circuit board that are shaped in a certain way.
Yep. I been meaning to do some PCB traces and just make all kinds of goofy antennas just to mess around with it.
It's a bit of an art form. Like that really evolved during the time that I was at RIM, where that sort of like RIM got really dramatically, and others too, probably partially helped by the simulation aspect of it, which required a certain amount of computation power.
Yeah.
How did you end up at RIM?
Oh, I was graduating and looking for a job. And there was this little company, and they were looking for somebody who had experience at either Microsoft or Borland, and some experience with lasers. Those are 2 bullet points. And it's like, oh, I'm going to get that one. It was the most interesting job ad that I looked at.
What was the job?
Oh, just working like software development.
Right.
And so I did not wear a suit for that interview because I'm just going to go in there and nail it.
Yep.
And I did.
BlackBerry, so RIM, I should say, sorry. So you have, RIM is this company in Waterloo.
That's right. Later it became BlackBerry.
What later became BlackBerry. What year was it? So you went there right after school?
Yeah, it was 1993.
1993.
And it was a bad
When was
time.
that company founded?
1984.
How many people were at RIM at 1993?
Oh, they had an in and out board that had 16 slots on it, and there was like 1 slot left for me and 1 more slot.
An in and out board?
Who's in and who out.
Oh, okay. So it's like 20 people on the team?
The receptionist.
Oh, okay. So roughly 20 people on the team.
Not even.
Oh, really?
Yeah.
Damn.
So when they assigned the employee numbers, I got it number 13.
Holy shit.
Now, that's not to say that I was the 13th, because there's at least one guy who left before they gave numbers. So they gave employee numbers for the purpose of insurance of the, so they started having a benefits thing. So then they needed to have employee numbers. So at that point, I was the 13th most senior person there, which is not to say that I was the 13th person to work there, because there had been a handful of people who had left or been let go even before I got there.
What was RIM doing in 1993?
They were doing some wireless, but I'd like to say I was the last person who was not hired specifically for wireless.
Right. So like, what do you mean by wireless? Like, what were they doing? Like, they weren't making a handheld device yet?
No, they weren't making it. So they got into this in a roundabout, like they was mostly a contract engineering firm, but they wanted to get more into products, and they had like some product lines already, but the contract engineering thing was still alive at the time. But they had, one of the contracts that turned into a product was the thing they called the DigiSync.
DigiSync.
Which was used by the motion picture industry, which was essentially, so when things were kind of hybrid, so at that time they were already editing digitally. So you do the edit digitally, and then you cut the film.
Is this it? The RIM DigiSync?
Yes.
Damn,
Oh yeah, the
this is
DigiSync.
crazy.
Yeah,
It looks pretty nice.
Yeah. It had a 16-bit processor in there, which was actually an automotive type processor.
This is really nice. Like it's got like good typography and stuff.
Did you say an automotive processor?
Yeah, I think it had 16K of RAM and 48 and 64K of flash, although it can only use 48K or something like that.
Still today, quite a lot.
It had actually flash memory, which was a new sort of thing that you didn't have to pull the RAM out of it to reprogram it.
So Matthias, what did this thing do?
So it's essentially a barcode reader. So the 35 millimeter film stock, some years earlier, like less than 5 years before that, the Kodak decided to put barcodes along the edge of. So the film stock is just like 35 millimeter film.
Right.
So you got the sprocket holes on either side, and so the outside edge of that. If you got your Kodak film, it says like a bit about the film. So for the film stock on one side, they would put a barcode every foot or every 6 inches. And that barcode had like, what slot of film it was and how far into the film you are.
Right.
And so what the motion picture industry went for, and I think the CFB, the Canadian Film Board, originally contacted RIM to make a barcode reader, and then they productized it. It read the barcode as the film went through. So you had this little thing that the film went over and it would read the barcodes. At the same time, it had a shaft encoder, so it could know. So even when you're not on the barcode, it could tell you exactly what the frame number is based on those numbers.
Okay, interesting.
So as they scanned it,
shaft encoder, what is it physically?
That's a thing, a rotary encoder.
Okay, a rotary encoder.
So optical, so it wasn't something that goes click, click, click. So it could count how far along the film you are.
Okay, interesting.
And every time a barcode went by, it like, okay, we're here.
Right.
So you scan the whole thing in, and then you essentially video edit on the computer.
That's awesome.
Because you don't want to touch the original footage because
that's
precious,
Yeah, exactly. Yeah.
You don't want to scratch that up. Yeah. So they would then edit it with video, primitive video editing stuff.
Right. So this is almost like giving the film like metadata almost.
Yeah, exactly. Damn. So then they scan it all into the computer, and then the editor, the director or whatever, the film editor would edit the film together.
Okay.
This is where we want it to go, but of course this is like shitty low resolution stuff.
Yeah.
So then when they're happy with the cut, then you hire somebody with white cotton gloves, well paid, to go to the original film stock and physically cut
and tape it and stuff.
Cut and tape it.
Yeah. Crazy.
And so then they'd use a DigiSync again, because then the guy would have like a cut list.
Right.
Okay, go to this frame. So you put the film in there and you just wind it to the thing.
Yeah.
And it tells you, here, cut here.
Right.
Damn.
So that you can get it frame accurate. You're not going to be off. It made the, not that I ever got exposed to that itself, but certainly the guy who's now doing.
How did you guys even get into this? From contract engineering to
RIM got contracted to, like this is before my time. The DigiSync was already a product when I started. RIM got contracted by the Canadian Film Board to make a barcode reader for this, and then they productized it. And this is actually version 2 of the thing at least.
Okay, cool.
And that sort of became a standard in the motion picture industry.
That's awesome.
It's a great name.
That's really cool.
Research in
like
Motion.
It's not easy to.
I love the logo.
These sorts of solutions.
The DigiSync, it is a cool name.
It is a cool name.
Was there any communication with Kodak, do you think, to put the barcodes and all these different things in there?
Well, I think this product is instantiated before my time. So I think Kodak just decided to put the barcodes on there because
So there's some really smart people there, like very, very smart people working at RIM.
When Kodak was still like a thing,
exactly,
and made film.
So this is an example. So this is like you go to RIM, they're doing like contract work, and this is like their first foray into product, right? This is one of the first products.
That's true. Yeah, that was the first. Well, they had done other products, but this one was actually quite. So there's other products that were done before my time, like they did LED signs for factories and stuff like that, but it didn't have the staying power that this one did.
For sure.
So this one was a substantial part of the company's work at the time. And I was hired to work on that product. So I was not hired from anybody after was hired after me had to do with wireless. So I was hired to work on that.
So you're the last person that they hired that wasn't for wireless.
That's right.
And then were they getting into wireless business? Were they already in the wireless business?
Yes.
Or they? So
they weren't making their own. They were just writing a library for an Ericsson modem.
Okay. Yeah.
So they got into that because they wrote some protocol converters, which was also through other contracts.
Right.
And these were things that were sold. So there's these Mobitex modems, which were not internet or anything like that. Their own proprietary protocol. So something that goes, for instance, with between a point of sale system and the Mobitex network, so you can have wireless point of sale.
Right.
Which nowadays is like, you just you get your your barcode reader that plugs into the audio jack or whatever is like, duh.
Yeah.
Back then, it was like, whoa, wow, you can take credit card wirelessly? You mean you don't have to have the ka-chunk thingy?
Yeah.
Like,
I think the interesting thing when I look at this, just riffing on it, is I look at it and again, this just might be my interpretation of it, but it has an edge to it. Like when I look at it, it has like vision. Like,
yeah, it's a pretty looking product, isn't it?
Yeah, it's really cool. And like the logo, the name, Research in Motion, DigiSync, the way that text is put together, the teal line going through it, the color coding, and the balance of the
I don't know where that logo came from. Again, that logo.
But I mean, it's like really good, right?
Yeah,
and it's nice. It's like the balance of numbers on the object and like the buttons and everything. Like clearly, this is like whoever worked on this put a lot, like had vision.
Oh, there's the NFB logo on the corner there too. Bottom right.
Oh yeah. NFB is fucking awesome. They're amazing. So you come in and then, oh yeah, look at that, man. It's clean.
Yeah.
It's really nice. Okay.
It's
so
like just a like simple embedded system.
Right.
You know?
Yes.
I wonder if I could get one of these.
Oh, I don't know where you
I want one of these. It'd be super cool just to have.
Yeah, you never know. It could I think it's like nobody's using those anymore.
Okay, so then you come in and you see this thing, and so now what was the first thing you worked on at BlackBerry?
So the reason the reader, the film reader it was an LED based, and so the film had to be in the focus plane for that, which means the film had to go over an extra sprocket,
right,
to position it for that reader, and that was an issue for the film industry because it's like, there's one extra sprocket this film our precious original stock has to go over one extra sprocket.
Right.
That's causing extra wear and tear to the film stock. It might, like they didn't like that. So Mike had the idea we should use a laser so that we can just have the film, we don't have to actually guide the film into the focal plane. Right. And so I was hired to work on that, and that did not go well. And then I blew up a lot of lasers. In fact, I had this one laser diode. So a laser diode at the time was still an expensive sort of thing. To blow a laser diode, it's like, oh man, it's not like, whoops, another one. And the laser diodes are a little bit temperamental. You actually need a circuit to prevent them from blowing themselves up. Right. In that you have to if you drive it to a certain level to get the beam out of it, if the temperature changes, that level is enough to melt the thing. Okay. So you have to have this feedback circuit where you take the feedback, from how much laser is it actually outputting and regulate to that. Right. Because if you just give it a fixed voltage, it'll either not lazy enough or it'll blow itself up at that same voltage. Yeah. And at some point I misread the power supply or something, and I turned it up and it blew it up. And there was and then the other laser diodes, they all just blew up after me after that. So I'm like, I don't know what was special about that first laser diode. And Mike Lazaridis, is starting to get questioned. And at some point I went back to the university and just sort of looked to see what other jobs were posted, because I was feeling kind of glum about this.
After probably the fifth laser diode.
It turns out this was it was not good for me, but it was perhaps fortuitous that I blew up so many lasers. Because then Mike's going, it's like, well, first of all, it's like, he's questioning my abilities. And perhaps I'm not careful enough and all that. Right, and I was also kind of like, huh. But it's like, if these lasers are so easy to blow up and there's a bit of static electricity with this film, perhaps we shouldn't do this.
Right. Yep.
Perhaps we shouldn't work on this product.
Perhaps we shouldn't try to put a laser on there.
Oh, I see.
Which really, I mean, as things evolved, the product became less and less necessary. Right, yeah. So it was the right choice. It turns out to be the right choice for the wrong reasons to decide to abandon this laser idea.
Yes, it was a dead end.
It was a dead end. Right. It would have, I don't think it would have, there was all kinds of other technical hurdles to overcome. Right. So lasers, there's a speckling problem because it's coherent light, so you have to modulate it and all that. So there's a whole lot of complex things that would have still had to be solved, which would have eliminated sprocket, which the film industry didn't like, but it wasn't really that much of a problem.
I bet you they probably didn't have any other products they could have used anyways.
Exactly.
So who cares?
So, it was fine. Yeah. It didn't need the laser. Yeah. And so that freed me up to work on something else. Right.
Interesting. So what was that?
So then I had to do some work on the software, and I could not understand that code at all.
Was it not well written?
It was not well written. Yeah, so there's two parts. There's the barcode reading, which was written in assembly language by a guy who was very good. Yep. And then there's the rest of the code, which was written by my boss, which I couldn't make heads or tails of. Right. And so I just started coding in simulation on a PC to do this, and it was working. It's like it's like, we can't just throw out this code. There's a lot of work in this. It's like,
Yeah.
Well,
I've actually replicated everything that's in there, and the code is much smaller.
It's easier to rewrite the code than to read it and understand.
Yeah, I mean, like, and I'm like, you guys keep revving the software on this thing. You should not rev this software any more than you need to rev a calculator.
Yep.
Right.
Why does this? It's like, this'll, there was one more rev after that, but it's like it became a solved problem.
Yeah.
And so I was free to work on something else, which became our own. Mike Lazaridis at that time had this audacious idea that we should build our own wireless modem, like the hardware.
Wireless modem.
RIM had been contracted to work on part of the software layer for something from another company. And he had the audition, and then that kind of got kiboshed. It's like they canceled and all that. It's like, why don't we just build our own?
Yeah. It's like, you see,
are you nuts? We don't have any equipment for that.
Yeah.
I didn't say that.
You built a wireless modem?
We built our.
Do you remember what it was called?
Mobitex modem from. It didn't really have a name. When we released it, it's called the RIM 900.
RIM 900.
So it was a Mobitex modem. So we built that from scratch, and I wrote the.
It was this?
No, that was later on. Like there's not going to be pictures of that. It was the thing that goes inside
in those
boxes.
Else's.
It was a module that went in something else. I wouldn't expect there to be many.
Yeah, I think it's this thing. I think it's actually this. It looks like a module.
Cool. Yeah, that's it. That's without it being in the case.
OEM radio modem.
Yeah.
So you worked on this?
Yeah. So I wrote almost all the code that went into that thing.
So that was kind of how you proved
DSP code.
That's awesome.
So that's kind of how you earned some credibility at RIM, right?
So
they saw what you did on the software side, and then
explain what the software does. Like, so I actually don't know what a modem is physically. It's like, what is it actually?
So a modem is something that, like in terms of like a modem, like that goes over the phone line.
Yeah.
It takes your digital bits and modulates them in such a way that it can go over the phone line. In this case, it modulates them, and there's a wireless the wireless transmission and the wireless receiving.
Right.
And the demodulation and turning that into bits, and then there's a packet switch protocol, and then there's all kinds of challenges because you don't just talk to one other radio. You have to keep looking around. I'm talking to this tower, but is there a better tower? And what if this tower doesn't work anymore? How do I retry?
Right.
And that complexity is baked into the modem.
That's right.
And the modem is a software, or is it also like hardware?
Well, we built the hardware.
Okay. Yeah.
So that one had an 8186 processor on it.
Okay.
They wanted to go for a lesser processor. So there's lesser processors that we looked at, but I'm like, they were just awful processors.
Right.
And there was a chip to do the Mobitex protocol, the modulation demodulation protocol. We got some of and this company was desperate to sell it to us because I think they were the only customers. And then Mike Lazaridis looked around and he found this ADSP 2100 DSP where you could just load the firmware. It was self-contained. It had the RAM in it.
Right.
The firmware, it didn't have flash, but you could load the firmware from the interface to the CPU.
Okay.
And so we put that on there instead of that other chip. And of course, then we had to write DSP firmware, but right away it's like, oh, we can do things that this other chip doesn't. And we can do the calibration in this thing. We can eliminate a whole lot of analog stuff. We can do the final channel and filtering in there and all that sort of stuff.
You can do so many things in software if you know what you're doing.
Yeah, and they still kept trying to sell us to us. It was like, there's no way we're going back to your stupid chip because this is cheaper.
Better,
Might have been even lower power. And like we've already, we're using so much functionality in the DSP that we can't go back to the other chip.
Have you ever done any radio stuff before this, or did you just like jump into it from the software side?
No, I can't say that I've done radio stuff.
So what was your development loop like when you were like testing the protocol? Like, I'm imagining there's analog signals over the air that gets to your chip, and then you have to write code to turn that into digital output.
Yeah.
What's your development loop like? Are you on a computer? Are you like sending actual radio signals to this thing to test in real life?
Yeah. So there's various RF test equipment that the company had acquired. Okay. This one, the modulation was relatively simplistic, and it was just GMSK. And actually, our first modem was actually used an FM discriminator as it turned the analog signal that comes in over the air, which actually is a complex, more like think of it as a complex number.
Right.
It turned that straight into a baseband signal, sort of like an FM radio does.
Okay. Yeah.
Which is not ideal for decoding.
Right.
Does not make for ideal sensitivity, but it certainly made it a lot easier. So our first product used a discriminator that way, and for the transmitter we used a 2-point modulator, which there was some like quirks with the hardware. I'm like, if I pre-distort the signal this way, then it'll come out just right.
Right, interesting. And then you find that out through experimentation?
Through experimentation, yeah.
That's really cool.
So there's a lot of time spent in the labs with oscilloscopes and stuff like that.
Yeah.
And like analog electronics and oscilloscopes.
How long did it take for you to change the software, make a change, and then like after you've written the change, you have a hypothesis, you want to test it. How long did it take you to get it onto the board itself and then do the test in the real world?
There was actually, in terms of decoding, like I had an idea for an algorithm, and it's like, I think this algorithm might work really well. And I just went straight from idea to implementing it in DSP assembly language.
Okay.
And then realized there was a flaw in my algorithm. It's like, rats.
Yeah.
And then I realized like, I can still fix this. Like if I do this, and this is, and it's like, that works really well. So I went straight to DSP assembly language.
Fair enough. Yeah.
And so, which is a bit silly, but it's like, I wasn't that familiar with stuff like MATLAB and stuff like that.
Yeah, but it kind of like is truer to what's actually happening on the machine. And when you're working with things at that level, you need to have a lot more certainty in what you're doing. And when you have more certainty with what is actually happening, when you can like actually trace through the steps and predict what's going to happen a lot better, it is, you have to spend a lot less time looping.
Yeah. Well, and that DSP was fun to program in assembly language. It was a bit of a very taxing because, processors are pipeline, they'll do stuff. So this one, you have to do it completely manually. So it's like, while I'm doing this, I need to make sure the data for the next instruction is already in place so that I can, in the next cycle, I can have this data. So instructions have 3 components. So you can do 2 memory fetches and ALU instructions. They're 24-bit wide instructions.
Right.
Kind of weird that way. And you have 2 memory buses.
Right.
So in one instruction, you can use a data address generator to fetch something from program memory and do a simultaneous fetch from data memory and do a multiply accumulate at the same time. And so to do one of these loops, you kind of have to prime your loop because first of all, you got to load the things before you start your loop, and then you loops.
There's no way to do this sort of primitive from a higher level, right? Like
there was actually a C compiler for it, but it sucked.
Yeah, exactly.
I did end up using that C compiler for a prototype later on because it was very easy to get something suboptimal just to try something.
Yeah.
But then it sucked.
Yeah. You look at the assembly afterwards and you're like, this isn't what I wanted to do.
No, because that was not that instruction set. I don't know if you know much about C6502.
No.
Okay. Like that instruction set is not suitable for assembly language. Neither was this.
What was it? C6502?
6502, the microprocessor.
Okay. Can you find that, Ravi?
It's a very simple 8-bit processor. It was very popular because it was cheap.
And that was in here?
No. But like that processor, there was never a good C compiler.
I see.
It didn't have the things that a C compiler expects. And this DSP also was not designed for, it was meant to be programmed in assembly language. And that's what we did.
Damn.
So the 6502 was in the Commodore 64, the Commodore PET, the Apple II, the Atari, like the Nintendo, the first ones. It was in everything.
Were you the only one who was working on the software, or were there a team of people that you
There was other people working on the software.
But it was probably like Pareto, right? Like someone is doing most of the software work, and then there's tasks dispensed to other people.
So there was the mask protocol is what they called it. So the protocol for getting the packets.
Right.
So it was a packet switch modem. That was written by somebody else. That wasn't written by another guy.
So each person is responsible for a module, and then they default that.
There's Michael Barnstein was one of the partners. He wrote that protocol part.
Right.
And there's another guy who was going to write the DSP, but I kind of got impatient and wrote it myself. And then there's a protocol stack, which I wrote. And then there was the scheduler, like the operating system, which I also wrote.
Okay.
Which was just a preemptive task switcher.
Right. Okay.
Not like an operating system.
Yeah.
It's just a
Still an operating system.
Little kernel that allowed, preemptive multitasking because that was really necessary.
Yeah. Fascinating.
How much fun are you having during this process?
Oh, that was fun. That was fun. Yeah.
A lot of fun.
And they're like, you should use this RTOS. And I'm like, why? I just write my own. It's like, we don't have to worry about licensing anything.
Exactly.
And it'll be a lot smaller. It was like 300 lines of C code.
And it's easier to understand. And when there's a problem, you can actually fix it because you made it. It's like, it is so important. Optionality is important.
Once the product got to a certain level of maturity, it's like every place I use them as semaphore is actually a design error. So let's get rid of the semaphores.
Yep.
So it's like, stop using them because it's like, they just cause problems. They cause priority inversions, big problem. So don't use them. And it's like, okay, now I can take the semaphores out of the microkernel, the kernel, and it'll be that much simpler.
Exactly. Yeah.
What was the confidence like? Was this like a confidence boosting project in a way?
I guess so. Yeah.
Not for you, but also for RIM.
Yes. Yeah. So that project really established my reputation within the company.
Right.
And there was rival companies that tried to do the same thing. You had problems with this and problems with that.
Yes.
And like there was no QA department or anything like that. So it's just like,
just do it right.
I just made sure it worked.
Just
and
make sure,
it was
make sure it's
not,
right.
you know, I just ran my tests.
When a
I had
program
my
is
regression
simple,
tests.
there's only so many pathways. There's so many states it can be in. And as long as it's simple enough, the amount of states is actually tractable to be tested.
Yeah. And I was sufficiently on top of it that our lack of a QA department wasn't the problem.
Yes. Yes.
So you have the DigiSync, you do a component of that. Like you do a software component of that.
I rewrote all the,
you
except
rewrote
for
it,
the
and
barcode
that
stuff. I rewrote the whole thing.
Yes, and that's when people start in that company start saying, "Oh, maybe we can trust this guy on the software side of things." And
I'm not sure about that, but I was just available because the
Yes.
DigiSync was like, it's like it didn't need any more software revs. It's like,
right.
This doesn't need, you know, it's like this is done. It doesn't need revs.
Right.
It's just like a calculator doesn't.
Exactly.
You don't upgrade the software on your calculator.
Yes,
you shouldn't
yes,
have
yes.
to upgrade on this thing either.
But then
I was available.
you were available. So then you go to the RIM 900, and now you're really like kind of like working on the software component a lot. And it's like it's a lot of your vision is and decisions and taste and whatever is being reflected in how this is made.
Yeah.
And so I mean, through this process, that's what you're saying. Like the team starts to trust your instincts, your taste, your decisions. So what happens next?
Well, we make the product and we ship it. And
No, I mean next product.
Oh, next product. So the Mobitex that went on.
Okay.
So then we also got into other there was a data tac network which did
Data tact.
Data tac, that was a Motorola invented thing, which I didn't think it was as elegant as Mobitex, but somebody else worked on that, so I didn't know about it. And it was a bit Richard. He a key to writing software is knowing when to say no. It's like, I want this feature. Why do you want this feature?
Yeah.
Because I need to do this. Well, let's not have this feature. Let's do it that way.
Guarding against complexity.
Yeah. And he was not as good at, and so one of the things we had done, we had designed the product with 256K of flash RAM for code.
Right.
And 128K of RAM for data.
Right.
And then when we got closer to production, it's like, well, can we cost reduce this thing? It's like, well, I'm using less than 128K of code space.
Yep.
So flash, cut that in half.
Yep.
How much RAM are we using? A bit over 32K. It's like, let's make it work with 32K cost reduction.
Yep.
Idle power consumption, can we reduce that? We had originally had some other circuitry that allowed sort of a deep sleep, which was not part of the processor. It's like, but what if we cut the clock speed in half? Well, that'll cut the that'll cut the idle power. Can we run it at half the clock speed?
Yeah. This is like pushing things to the limits. Like,
And
you can find advantages that other people are completely blind to, because the easy thing to do is to just get a better processor.
Yeah.
So
but then you completely destroy people on cost.
So we cut the clock speed in half, but then we had to go to analog devices. Like, okay, your DSP is designed to go from 20 to 40 megahertz. Can we run it at 9 megahertz?
Right.
Oh,
like,
shit.
Why on earth would you want to do that? It's like, well, will it work at 9 megahertz? And they're like, yes. Cool, we'll run it at 9 megahertz. So we cut the clock speed in half to cut the power consumption.
Yeah.
And like the software was efficient enough. At first I was like, well, let's see if it works. Like, you can do it.
Yes. It's like,
so it usually goes the other way. It's like you add more, now you need more power, you need more. It's like, no, like when we went to production, we cut everything in half.
One thing some good developers will do when they're like managing engineering teams is they'll hide a process in the server, whatever thing you're deploying the software on, that takes a bunch of resources for no reason. Like they'll introduce a bug or something that like will take a bunch of memory. So when it's finally time to release, they can just fix the bug and then they won't be over budget. Because the engineering team is going to keep on eating away the memory that they have in the budget, right? So you just add a bug that like swallows up half the memory. They don't notice it. And eventually when it comes to ship time, you just fix the bug and you're like, hey guys, we're under budget.
Because I had complete,
super interesting.
I had control of what was running in there.
And you know, with like LLMs making people so much faster at programming, we can have more situations where one person can own an entire module. And then you can have these decisions. It takes a lot of energy and effort. And it's hard to convince people how important it is to keep things simple. Because it's always easier. Why don't we just buy this thing? You know, I can go home and barbecue at 3 p.m. People don't understand how important it is to keep things simple and like to push things to the limits. It's hard. It's like kind of like an instinct that you build over time.
Just pulling dependencies willy-nilly.
Yes. Oh my God, I hate
at some point there's this, what was it, the magnetic encoder, and it's like I wanted to use that, and it's like I like to download some piece of code that works with this thing. So then it's like, okay, it works. Now I can start optimizing this thing, and I downloaded this library and that library from Adafruit, and finally got this thing going. And it's like the dependencies had to pull in. And then I started looking at it with a scope, what does it do?
What's it actually doing?
And it's
physically?
like, it turns out what I needed was 4 lines of Python.
Yep. Yep.
Like-
is the signal getting pulled high? Yeah.
It's like I replaced the whole library with like 4 lines of Python. Now, granted, this library could do more than I needed to do, but
that's the problem. Is like people try to make things easy and they add complexity to like increase ease. And simple requires understanding what's actually going on.
Yeah.
But what you get with simple, even though it's more difficult because you need to understand what's actually going on, you increase your understanding of the world and you increase your optionality. It's easier to expand on less code than more code.
Why is that?
Like I like to say, it's like people write reusable code, and I'm like, the probability of code getting reused is inverse to your the reusability.
Yes, exactly.
Because you add all these things so that there's hooks and all that. So, and what do people do when they modify your code? They hack around the interfaces.
Exactly. Yeah.
They don't try to figure out, because whatever extension mechanism that you thought of, it's not what people end up using.
Yes.
And so you take like one of the most reused pieces of code, Linux.
Yeah.
The guy said, and originally this only runs on a 386. It is not intended for this and that. It is my project that only runs on a 386. That's all it does.
Yeah.
And that is how it conquered the world.
Yeah,
not
exactly.
I'm making, as opposed to the GNU herd. Have you heard of that?
Yeah. Yeah.
The GNU kernel that was part of the, be the centerpiece of the GNU
That's
system.
interesting.
Yep.
And, Linus sort of stole, this is why like Richard Stallman's like, it's the GNU / Linux, because it's like, you can't just call it Linux. There's all this GNU stuff in here.
Yeah. The kernel's like, it's the simple thing.
Yeah. So it's like you write things simple and people will reuse it.
Yes.
There's two key themes I'm hearing from what you guys are saying. One is like reusability and one is optionality. And so with and they might be the same thing, but with reusability, what you're saying is that, when people, when the creator of Linux said this should run on a 386, by setting that constraint, he's improving the reusability of his design. Because if it can run on a 386, it can run on anything essentially, right? Is that what you mean when you say like the?
Well, he didn't have ambitions that way. Like it runs on my computer, and other people, it's like, well, this is a free Unix-like thing.
Yeah.
I mean, there was Minix, for example, but there was licensing concerns there, and there was free, there wasn't any sort of free alternate. FreeBSD didn't exist.
Right.
There was things were tangled up with licensing concerns in terms of the whole BSD thing, like Cisco claiming ownership and stuff like that at the time still. So this was like a unencumbered Unix-like thing, which initially wasn't all that well developed, but it somehow caught on, and I think Linus Torvalds also had the right mixture of both being a reasonable person, even though he claims not to be, and having the right amount of crankiness.
Yeah.
In terms of keeping things under
control. You have to be slightly cranky.
Exactly.
Like simple code is useful because you can understand it, and the better you can understand code, the more you can co-opt it into your own system.
Exactly.
And pulling a dependency in, for a lot of people, it means importing a library that they use through some process. But what it actually means is that you're packaging actual code up with your own code.
Yeah.
And if it's simple enough that you can understand it, the best way to import code from somewhere else is to look at the code and copy it over.
Yes.
Like that's the best way to reuse code. Like sometimes when I write software and work for like large corporations, people will be like, oh, we shouldn't, rewrite code because there's this module and we should just, reuse this module. Right. Well, sometimes you should just rewrite code because it's like a lot simpler. It's a lot easier to understand. It's kind of inline and associated. And sometimes you might want to change it relative to other parts. It's hard. There's
like, you should not write your own TCP stack.
No. Yeah. But TCP, it does what it does. I can understand what it does. I can understand its set of behaviors. Like it's definitely not simple, but it's reliable, I guess. Yeah, like it's hard to describe. It's almost hard to describe the value of simplicity.
Right.
Really, like for my work, because I've redone everything myself, I can do things that other people can't.
Right.
Because I understand how things work. I understand how the software is laid out for my specific use case. The design of the software, the way the software is organized, is related to what you actually want to do. And reusing things means that, or sharing things with other people, is that you kind of have to muddy down how specific it is for your specific use case.
You writing things from, you writing as opposed to pulling a library, of course, is of great benefit to you. Yes. But if somebody then has to take over your code, that benefit decreases a lot because instead of having to learn the library, they have to learn what you've done.
Yes.
So it's...
Well, I'd like to think I'm a decent enough programmer to understand.
I've recently, like this whole toolpath thing that we're talking about earlier. It's like, it was one of those things. It's like, oh man, this is a hard problem in terms of figuring out the offsets, because you can get corners that you can't get into, and it gets fragmented. And I was just kind of like, well, I mean, this is hopeless for LLM to solve it, but let's just challenge LLM. Right. It's like, okay, I want you to do this. And it's like, and the LLM was, well, I'm using this library. It's like, oh, there's a library for that?
Yeah, that's true.
It's like, and I was like, no, I wanted you to do that. Part of it's like, that's cheating.
Yeah, exactly.
On the other hand, it's like, oh, that's brilliant.
Yeah. I mean, it's also like you kind of satisfy your curiosity when you understand something all the way through. And when you use a library that already exists, you're almost kind of getting robbed of the understanding. Yeah. Because I'm sure there's things you could do that you would only be able to know that is possible. It's like what you're kind of after is knowing what's possible to begin with.
I was not looking forward to trying to write something that offsets.
Right, sure.
Creates offset toolpaths. And here it's like, oh, it's a solved problem.
I think like there's people out there who have are using computer vision for pick and place machines. I'm sure you could probably use computer vision somehow to offset it appropriately.
I suppose, yeah, you could.
Or you could attach like a LiDAR sensor.
You could bitmap manipulate in terms of just like copying it, like smearing the thing around, and gives you the offset that way. But then you have to now go back and find the edges.
Right, true. So maybe you could use a LiDAR sensor that's like accurate enough, and then just like move the toolpath around and then to a tool head.
But that's inelegant. So this library is called Shapely.
Okay.
And so you can just say, okay, I want you to offset this thing. So imagine you've got a square, and it's like, okay, we need to offset by, say the square is like 10 millimeters by 10 millimeters, offset by 1 millimeter. So of course it becomes 12 by 12 now, and the corners rounds the corners, because offsetting from the corner, it becomes a circle. Easy enough for that. But now suppose you have the letter C and you offset it.
Okay.
At some point you offset it far enough that the inside of the C becomes cut off from the outside.
Right.
See, now this is where things get complicated, because now you've got these island effects.
Yeah.
And when does it become an island? When does it disappear? Right, you can't just take the path and offset it.
Yeah.
Now you have to look at this path that you've offset. Does it intersect with other paths that have offset?
Exactly.
And where do I cut it? Where do I eliminate it? Because it's not possible for the tool to get into the gap. And so I was well aware of the complexity of this problem. And it's like, oh, somebody solved this problem.
Yeah, that's true.
I will happily use that library.
Yeah. LLMs are actually really, really great for that, for like finding out like the space of possible solutions. Because there's so much crap out there that, and sometimes it's hard to like filter down. They're kind of like searches into the compressed.
I find in terms of discovering things, or for my website, I was redoing the store, and I need to send registration keys.
Right.
So I was redoing that, and it's like, I had this tool that I could send an email. So it's like, okay, I need to use this tool to send an email. And it says, well, I'm just using the email library in Python. It's like, oh, there's a library. Oh, of course Python has a library for that.
Yep.
It's like, I'll just use this library instead.
Yeah.
Like, oh, that's brilliant.
Yeah. It's kind of remarkable how much stuff you can automate with these tools. Like it's kind of crazy.
Yeah. What's the crankiness bit?
You just need to be kind of like an asshole. Because people will tell you, no, you're wrong. It's like, can there be 100 people telling you that you're wrong? And can you still say, no, you guys are wrong, I'm right? Like, are you kind of like a bit of an asshole in that regard?
I think at some point, Linus, like people were, he of course gets accused because, he does kind of sometimes go off on a tangent and kind of hard on people. And it's like, your success has turned you into an asshole. And his retort was like, you are wrong. I've always been an asshole. Maybe not quite that word, but it's like, I've always been a jerk.
Maybe he's successful because he was a jerk, right? Maybe he's,
Linus rants. What is this, Robbie?
Oh, yes. They're
wrong, Alan. You're not getting it.
I love reading his rants.
Loading firmware as part of suspend resume is wrong. What the heck is your problem? Go back and read it. If it wasn't loaded before, then it wasn't working before either. Why the hell do you keep on harping on idiotic issues? Stop being a moron. Just repeat after me. A catching firmware loader fixes all these issues and is simple to boot. Stop the idiotic blathering already.
And like,
holy shit.
So like there's this is important role. So
you could just like, you could feel the keyboard just getting fucking.
Steve Jobs was that guy at Apple.
Right, yeah.
Who was like, I don't care what your procedure says, fix it.
Yep.
Oh, hell no.
Mike Lazaridis was that guy at RIM.
Yeah.
I don't care what your design is. This is stupid. Fix it.
Yeah, exactly. Yeah.
And so Linus is that guy for open source, and he's got enough credibility that he can get away with it.
Yes. And it helps move things along as well.
Oh, hell no. It's a fucking disaster. One notifier was broken. So let's add another random one to fix that. The definition of insanity is doing the same thing over and over and thinking you get different results. Let's not do that kind of idiotic thing. Notifiers are evil crap. Let's make fewer of them, not add yet another random notifier for some random reason. Fuck them. But how I hate those random notifiers, and I hate people who add them willy-nilly. Super.
He's got a point.
So yeah, of course.
Why is this?
That doesn't always go over well.
Yeah.
Why is this important?
Because you don't want people to doing dumb things in important software.
Yeah.
Like this is actually,
it's a good form of discipline or something.
LLMs in that they are so agreeable and all that, that they. I get LLM to write this, like, and then I'm looking at this, like, wait a minute, you've got like almost the same functionality in these two different places. Why is that? It's like, oh, let me fix that. It's like, didn't you think of that before?
Yeah, exactly. Yeah, exactly.
Yeah. Interesting.
So you need some sort of discipline that way.
Yeah.
And you know,
I feel like that's super hard.
Yeah. Well,
I feel like, you know,
so there's two, I found like, there are two developers sort of I can think of at RIM. So there's David,
right,
who was a great guy, who could pick up legacy code and just work on it. And
what's his last name?
Kennedy.
David Kennedy. And
then there's another guy I hired, Fa Tran, who is somebody who we bought this code from another vendor for the GSM stuff. We ended up rewriting it in the end. And he's just, he couldn't, it's like, this is just, this shouldn't work this way. Yeah. So Fa had a very clear notion of how things ought to work.
Right.
And if they don't work that way, and I'm like that too, I'm more like him.
Right.
It's just like, you get so caught up on this is so wrong.
Yeah.
I need to fix this first. And of course you can't, because it's like, it's a code base that's existing already. You don't, you end up, once you get started, you tear the whole house down.
Yeah, exactly.
And there's somebody like David Kennedy, who is perhaps more agreeable, like an LLM, who just kind of like, I'll work with it.
Yeah, might as well.
So David Kennedy's great when you got the legacy code base, and he'll tolerate it and he'll make it work. Those guys are great in that sort of situation. Then you got this Tran guy, who is great conceiving the project, where it's like, I've written this.
Right.
And I've realized the architecture is not optimal.
Right.
Yes.
And it works, but I will refactor it because it's not the best.
They have the discipline to doing it.
They have the need,
because they could always take the easy way out.
Yeah.
But they know in the long term it's better to factor things appropriately. Exactly. It's extremely painful. You could always do things the easy way.
Exactly.
But taking shortcuts to some people is just intolerable. It's just like, man, I can't.
But there is some. But I think the point that you're making is there are moments where that is not the correct approach.
Oh, absolutely. Like I said.
Yeah.
So when you got this code base, and just to make something work in there, the more agreeable type of person is the person you want.
Yeah.
When you're doing kind of, you're starting things from scratch, you want the person who is just got an intrinsic, it ought to be this way. And those people are difficult to get them to work on legacy thing, because they're like, oh, this is just all wrong. I can't, it's like, because they see this and they want to fix it, and you can't. And it's like,
it's one or the other. I feel like it's a personality trait.
Yeah.
You can't really have both.
Mm-hmm.
And so, and there's work for either kind. Yeah. So when you got the legacy code base, the guys that just sort of have a notion of this, it ought to work this way, are going to be really frustrated.
Yep.
Yeah.
And when you're starting out, you want somebody who has a very strong notion of this ought to work in the most simple way and all that. And I will refactor it when I realize that the design is not best, that my original design is not the best. They will
tear it all up, start again.
And this guy, this Fa Tran guy, I had him write some code, and the discipline of this guy. So I don't remember what it was that I asked him to write, and he'd been working on it for 2 weeks. So it's like, how's it working? It's like, I haven't run it yet. It's like, you haven't run it yet? You've been working on this guy and you haven't tried it yet? So, but then when it was ready and he ran it, it worked.
Wow.
I was like, holy shit.
Yeah, that's not easy.
That guy's good.
Yeah, that's actually not easy at all.
But I was kind of like, what do you mean you've worked on it for 2 weeks and you haven't run it yet?
Yeah.
Yeah.
That's like being able to think computationally like that is, because at the end of the day, like writing the actual code is just a laborious chore.
Yeah.
But coming up with the idea of how data should flow through the system.
Thought through, and like a much better programmer than me in terms of not having like just silly mistakes.
Yeah.
So I was like, wow.
That's awesome. I feel like, there's like a push and pull too. Like sometimes you kind of want to one-shot things, and it's better to be able to do that because your def loop is bad. But sometimes you can optimize your dev loop so much that you can make a bunch of mistakes, and you can kind of like, as long as you have a clear picture of where things should be, you can just iteratively get to that point.
Yeah.
Sometimes you don't really know until you actually design and build the thing that it's not good.
Sometimes, you just implement part of it. It's like, can it be done this way? And it turns out, no, it can't, because
you have to check. You have to actually
the hardware doesn't work the way you think it does, or
the data sheet's wrong.
Okay, so let's not make that the basis of my thing. So I like to start with, it's like, okay, let's start from the bottom up.
Right.
Pick the most difficult thing. Right. And figure out how to make that work. And
the riskiest part of your project, of your design. Yeah.
Yeah.
You have to actually test it. Like, this is the thing I've learned, is like, you gotta keep on testing things. You get, like as soon as as soon as you can, get the whole thing end to end working, and pick the highest risk thing, and then iteratively improve it.
Yeah, and then build on top of that.
Yes.
Super cool. What was the first thing that you worked on that resembled what we now know as the BlackBerry?
That would have been the interactive pager 950. So this is the bar of soap one with a wide keyboard.
Yeah.
So that was, at the time, this was like competing with pagers. So the pager was the
this.
thing that
I remember this.
Yeah. So like, there's a guy we hired, Victor Kulikaskas. I loved him. He's an very much old-fashioned guy.
Again, this is like,
and he's like, we're
beautiful.
writing an operating system for a pager. And it's like, it was like, but pagers don't have operating systems. So this is a bit of a schism, because we made this thing. So there's decisions that were made early on that became the wrong decisions later on, because, as you approach something like an iPhone, which we never quite got to, but as you get to a smartphone, the smartphones most definitely need operating system.
Right.
So we went from a pager, something that competes, essentially a two-way pager,
right,
to approaching smartphones. So the decisions that were right for a two-way pager became the wrong decisions.
Right.
Later on, and I got, it's like people point out, it's like, you made the wrong call on that. It's like, yes, but it was, it's like, if we'd done this the way you think it ought to be done, we wouldn't have built the thing when we did, and we would be where we are now.
Yeah, totally. When I look at this again, now, we looked at that DigiSync, and when I looked at that DigiSync, I saw like, vision, clearly a company that values like the design of a product. And when I look at this thing now, I see the same thing. Like, this is like a beautiful.
Yeah, that was a cute little product.
Yeah.
And that was, so the predecessor to that one was a bit fragile. So this one was super robust. So all the empty space was filled in with like rubber that was just the right shape. And so the sales guys would, or quite often it's like, I'd show it to my friends, they'd have their phones like, well, can your phone do this? And I take the thing and just drop it.
Yeah.
Do that.
Yeah.
No.
Yeah.
And the sales guys would take the thing and like throw it on the conference table and bounce it off the wall.
Yeah, whatever. Exactly. Yeah. That's awesome.
That was a cool product. So that had a 386 in it actually, which was like, whoa, the computing power.
Yeah.
How many people?
Have an operating system on it?
How many people worked on this?
Oh, quite a few, because the at that point the application stack was more work than the. So I worked on the operating system and protocol stack area of it. So the operating system became a bit more sophisticated for that then, and then there was a whole layer of applications on top of that, which were quite complicated, and there's architecture problems with that. So when we went to when we switched to an ARM, they decided to redo that with Java. So I kind of like, it was, let's put it this way, it was done badly enough that the rewrite was justified of the upper layers.
Right.
And then the lower levels too, like changing processor. And at that point, I wasn't in charge of that anymore.
Right.
Which of course also makes a like a rewrite more attractive. This one worked pretty good. That one had originally we designed it with 128K of RAM and 256K of flash, which turned out to be not enough. So it shipped with 256K of RAM and I think half a meg of flash.
What did this device do?
Oh, it was just it was a way to send
it could send
emails.
It could send emails?
Yeah, so of course,
I thought you said it was a pager.
Yeah, but then it's to do a message. Like SMS wasn't big at the time yet.
Oh.
What's an easy way to send a message? Email.
So this was sending emails?
So originally this was sold through RAM Mobile Data. And
development
it had its
name
own email address, and Mike Lazaridis realized very quickly that is a mess. Because then, now you've got the two email addresses.
Yeah.
So he decided with the BlackBerry that the thing didn't have its own email address. It was a bit inspired by the Palm Pilot.
Okay.
Whereas before people were trying to build standalone PDAs that
Yeah.
were their own computational device, and the Palm Pilot was just an accompanying, like a piece of your PC that you took with you. So I said, I want to do it the same way. So this thing would synchronize with your Outlook account.
Right.
Yeah. Microsoft Exchange.
So you had, when you sent from your pager, it was in the sent of your Outlook.
Interesting.
And when somebody sent to your Outlook, there was a summarized version, without the attachments that went to your
So like,
pager.
that was like an application layer. You would do like an Outlook email client.
Yeah.
And then it would just like interact
So
with
there's a whole team of people that like hacked into the Outlook server that you'd run in your office had an API for doing that sort of thing, which
like
wasn't designed to be used at the scale that we were using it at. So there's all kinds of problems these guys had with making that work, which I was completely had no part with that, but I remember hearing the guys complain about how, they had to do all kinds of kludgery and all that to make it work reliably.
It's like new technology stressing infrastructure
Yeah.
that didn't have any expectations of growth of like new technology relying on it.
That,
it's happening today with like LLMs and GitHub. I don't know if you guys have noticed, but GitHub's down all the time. It's because you have these like LLMs are constantly pushing out commits. People are doing way more software with LLMs. So like every jump in tech, and I think this is like a jump in technology, existing infrastructure gets like really, really stressed. I
guess especially if they get their agents to actually operate. Like I know I'm like putting a lot more code on GitHub just due to LLMs, but it's like I don't let the agents run. I don't let the LLMs run wild on their own.
Most people have never done a Git commit in their lives. They're now doing Git commits because they're just like telling the LLM, "Can you put this code up online?" Here's and ask them for their credentials. Yeah.
No, I don't do that. Like I'm kind of
don't trust them yet.
I'm in the loop. Like
fair enough,
I'm a control freak.
Yeah, fair enough. I feel like being a control freak is kind of important to like keep things like good. Like one of the things about this device I see is there's so little real estate on the RIM 950. I feel like all products are, as companies grow, and I'm imagining BlackBerry's growing at this point very fast, like teams. The product itself becomes real estate that different teams start fighting for. Right. Like how much screen real estate you have, how much applications.
Well,
space for applications.
Because there's only room for like the whole screen is used for whatever it's doing at the time.
That's true.
So you're not sharing screen real estate.
Yeah, sure, fair enough. Yeah.
The screen was 132 by 65 pixels, I think. A bit of a weird pixel aspect ratio in that the pixels were wider. And so recently I'm using one of these little 1.3 inch plasma things off of AliExpress, which is 128 by 64, and it's like, man, it's pretty close to the resolution.
It's very similar,
the first BlackBerry.
I think I have one of them in my box here, actually. Like they're very good screens, those little OLED screens.
Yeah, exactly.
And it's fun to design things for it too. Like I think I just saw the video you're referencing where you made a chocolate.
The chocolate melter. Like getting that graph one there was fun.
And it's like it almost like the lack of resolution drives you to make things cooler. Like it helps you exercise your design muscle. You have less resources to display what you want on the screen.
And like imagine if I had a 640 by 480, it's like, okay, now I need to make it pretty and it needs style.
Yeah.
How many people were at RIM when this product launched?
Oh, I see at least 50.
50.
Oh, maybe more, maybe 100. I don't know.
Yeah. And so what was the response like to this product compared to other ones?
Well, the 950 people, like even the predecessor, people loved it. So even though Motorola had like other products, it's just this one just worked. Yeah. So people loved it. And then when it was combined with the email, it was called the Crackberry.
Yeah, for sure.
Because
not yet though, right? That because once you got once it was called the Crackberry, that's like it's like in mainstream culture. Right. Yeah. But I don't know if it was a mainstream culture.
Wasn't mainstream, but it was big on Wall Street. The Wall Street guys were really big on it.
On this specifically. Yeah. On this one.
So it's funny. So when September 11th happened. Yeah. I actually had never went down to New York, but I built this thing and it got set up for me. I had this thing. It was like a 700 megahertz rack mount server kind of computer, which I could dial into because this is at a bank. So they're like, no, you do not connect to our line. So I could physically dial into it, and it had 4 Mobitex modems attached to it that I could basically had as monitors, so I could listen to the base stations surrounding that. And so I had it constantly like plotting traffic density and stuff like that, and logging just to see what's going on. And then September 11th happened, and afterwards, like, I should see what happened with the logs. So up until the planes hit, the traffic was mostly downlink. Right. People receiving their emails and a few sending. And then as soon as the planes hit, it flipped.
You see the
the traffic went mostly uplink because like business got shut down. Right. And everybody's like, honey, I'm okay. I'm alive.
Yeah.
Everybody
Holy
is sending these
shit.
messages. You know, everybody's out of the buildings,
Right.
communicating with their loved ones. I'm okay.
Yeah.
I wasn't in the, you know, it flipped. It was just kind of cool seeing that in
That's
the logs.
fascinating. You wrote all the software for yourself. You set this infrastructure up.
Yeah,
You set up the loggers and stuff.
These were, I just used a modem and modified the firmware, so it just spit out a log.
That's a lot of work. What drove you to doing this? Like, did you have a business use case for this?
Yeah. We used, so I had, because everything was flaky. So RIM was really king of flaky technology in that we knew how to deal with the flakiness.
Right.
So that we
What do you mean by flaky?
When everything was flaky, RIM had a serious competitive advantage because we had control over everything. We knew how to make it work.
Right.
Right.
You have like all the way, every single layer, the whole vertical stack. You controlled the operating system, the application layer. You controlled like the
so there's quite a few times where it's like Mike Lazaridis is like, and again, he was a driver that way. It's like, somebody sent me this email. It did not arrive at my device.
Oh, I see.
Why?
Yeah.
Like
being obsessive like that.
Figure it out.
And it's like, you have to actually figure it out.
So the guys who were dealing with the infrastructure, like the talking to exchange servers, were looking at their logs. I remember one time I was like sitting in bed, dialed up. I didn't have home internet yet.
Yeah.
Dialed up to the RIM server, and I'm going through my logs because I had I was logging all the packets that were going across the air just with a receiver. So I had a few scanners that were monitoring all the base stations around there and logging everything. So I could say, it's like, okay, your subscriber number is this. I can tell that a delivery attempt was happened here or did not happen here.
Right.
Did you come up with this system yourself?
Oh yeah.
Oh, that's really cool.
That was fun.
So this is like probably the first, because I mean, like this kind of became standard practice, you know, through the like Web 2.0 revolution of like logging everything and creating really great dashboards and stuff.
Oh, there was no dashboard.
I mean,
it was all grepping.
Yeah, exactly. Just like grepping a file. Yeah. But this is like, I guess like the proto version of that where you're setting up, you know, good monitoring infrastructure.
Yeah.
Like this was kind of relatively new. Like it's really interesting. You kind of came up with that and set up the infrastructure for it. Like, how did you have the foresight to know that it's necessary?
Oh, it's just
Or did you just
so
get yelled at?
at some point, we decided we should build our own Mobitex network.
Okay.
And Mike, in his wisdom, at some point decided that maybe that wasn't such a good idea, which initially I was kind of ticked off about because I enjoyed working on that. It didn't get that far, but I had some stuff working on it. So all the bits for that stuff ended up being very useful for other things.
Right.
So the time that I spent working on that was not wasted.
Right. Okay. Fair enough.
Although at some point he did get ticked off at me because I was using the sound card as my A to D in my development.
Right.
And there's a bug in the sound drivers on Linux.
Okay.
That kept it from working. And there was a newer version of Linux with newer versions of sound drivers where this bug wasn't the problem. It's like, I can make it work now.
Yep.
And so I set up our own base station in-house.
Yep.
This is where I had the transmitter going illegally.
Yeah.
And I said, we're shutting this down. Why are you still working on this? Because like, damn it.
Yeah.
I was so close to having this thing work. And it's like, now that this bug is fixed.
Yeah.
But so I used the sound card.
Right.
It had two scanners that were modified so that the output from the discriminator pre-audio got fed into the sound cards before it got distorted by the audio phases.
So using the sound cards to
and
demodulate,
I was demodulating two
signals.
channels at the same time with just a Pentium processor, which is plenty fast for that.
Right.
And it had two of these PCs going. Right. Each one connected to two scanners. So there's all the base stations that were within that I could hear. And the base stations would cover a much larger area.
Yeah.
Like the cells were huge. So everything that was going on in the Waterloo region on Mobitex, I could log.
Right.
Damn.
At some point, and I'd print out the contents of the message. So one of my coworkers is like, you really should switch to BlackBerry. It's like, yeah, but this works. Like the older system is like, I said, okay, go stand in front of that computer and send yourself a message and watch the screen.
Yeah. Pops up.
There's a message scrolling by.
Yeah.
It's like, that's why you should use BlackBerry.
Yeah.
Because it's encrypted.
Yeah.
Because it decoded all the messages and showed it right on the screen.
It's kind of, Have you ever messed around with SDRs? It's getting super accessible these days. It's kind of ridiculous.
it's very tempting, but it's like okay, I could use what's there, but it's like I don't see how I could contribute that much.
Fair enough. Yeah.
It'd be fun to play with, but it's like it's a rabbit hole to go into, and it's like
how many rabbit holes are there already available?
I don't feel that I could really contribute anything super new to it.
Right. Yeah.
So to control the remote controlled toy just by toggling the IO line is kind of novel.
Exactly. This is true. Yeah.
But so the SDR, it certainly has a lot. There's a lot you can do with it in terms of monitoring stuff.
Yeah.
I'm like, it lacked as a spectrum analyzer. It's like,
but you've already done the more impressive thing, right? With using hacking sound cards.
It's like I can use the SDR stuff to really do something cool with it, it would be an awful lot of work.
It would be a lot of work, yes.
Yeah, so it just hasn't been...
But probably less now with LLMs helping you.
That's true.
Yeah, I really want to build like radars, like just like patch antenna radars. Because like how hard could it possibly be? You just take the signals from every single part of the antennas and you just need to get the timing right.
Yeah, well, the transmit to receive timing is the difficult part.
Yes.
Because you need to get that down to microseconds.
I'm sure.
Although people have been doing work with passive radar, which is kind of cool
Yes.
because you're just listening and watching things bounce off of other things.
Yes. Yes.
Yeah, so I was playing around and was this 1 gigahertz scope and was like, well, what high frequency signal? And I was trying to actually get a signal out of, I wasn't sure what frequency the cordless phone went at. So I just called the cordless phone, called our landline with my cell phone, and I must be at frequency above a gigahertz.
Right.
But then I saw some bursts and it's like, oh, this is from my phone.
Right.
Oh, that's 700 megahertz.
Right.
And at some point I'm kind of like, I should figure out how to demodulate this because I did that for Mobitex and I did that for GSM. And it's like, wouldn't it be cool to do that for whatever it's using, which is LTE? So I started asking LTE about it. It's like, oh, let's not do that. It's way it's way more complicated than I imagined.
Yeah. It's like, but even the fact that you know that you could do it, for you even to try to do it in the first place is kind of awesome. I think that like when you understand things from their base principles, you realize how much stuff is possible. So you attempt it in the first place.
Yeah, and the thing is I could capture this transmit burst, not by like an SDR will always demodulate and downshift it. Like I was just sampling at 4 gigasamples per second and capturing the 700 megahertz. It's like, that would, so now it's like it's megabytes of data for this one little burst. But anyways, I thought it'd be cool to demodulate it, but then I thought it was just a root race cosine QAM type modulation. But it actually uses something called orthogonal frequency division multiplexing and then some other transformations to just to make it easier on the analog from the phone. I was kind of like, oh gosh, this is
quite a lot of stuff packed in. Yeah.
It's like, it was a good learning a bit more about this, but I'm like, no, I'm not going to.
There's only so much time in the world.
There's only so much time. Yeah. And it wouldn't be that cool.
Yes.
People wouldn't appreciate just how many hoops I'd have to jump through, which were, if it was just a QAM type modulation.
Is a lot of your project like the decisions for your projects based around your YouTube channel?
Well, I love doing the tech type videos, but they don't do nearly as well because the audience most people are just going, I don't understand. So I kind of alienate most of the audience that way. And this is where ElectroBoom is really good because he's not as thorough technically, but there's just enough antics and all that people, even if you don't understand it, it's fun to watch.
I'd say like probably I'd rather have 10 viewers that are like appreciate the stuff I'm interested in than 1,000 viewers but maybe appreciate the stuff.
Yeah, but those 10 viewers don't give you a lot of ad information.
This is true.
And those guys that are really savvy, they're probably using ad blockers on top of everything.
Yeah, this is true actually. Yeah.
I gotta get some water.
Yeah.
So.
Yeah. What? Yeah. So when you go from when this device drops, what is the device that makes like BlackBerry like takes it to its prime? Like what is the device that you felt like was the absolute tipping point in that company?
So the Mobitex really established RIM and
Mobitex.
Yeah. So
can we see that?
So the BlackBerry. So there's the one with the square screen that had the 160 by 160 LCD. Yeah. This one I always felt is more pocketable. Then we went on to GSM, which has got a lot more bandwidth, a lot more advanced. But
this device, the Mobitex, is the one that you think was like the tipping point at the company.
That established BlackBerry, and
can we see that, Robbie?
A great debt to Qualcomm on that front.
Right.
Not that Qualcomm tried to help us, but Qualcomm so royally screwed up the cell phone market.
This Mobitex?
Yes. So Mobitex was meant to die much. So Mobitex in Europe died because GSM became dominant. And even though it wasn't packet switched, it was so dominant, it just overshadowed everything else. And Mobitex died.
Yeah.
I'm just going to read this because I'm not familiar with this. Mobitex is an OSI-based open standard national public access wire packet switch data network. Mobitex puts great emphasis on safety and reliability with its use by military, police, firefighters, and ambulance services. It was developed in the beginning of the 1980s by the Swedish Televerket Radio from 1988. The development took place at Eritel, a joint venture between Ericsson and Televerket, later on as an Ericsson subsidiary. So why does this matter?
Yeah, it was just, it was designed for like utility truck drivers to
Right.
be able to send messages.
Right.
Right.
Okay.
Because it's like there was no, to send messages back, because
Right.
paging existed, but
Yeah.
this way you can send text messages back
Right.
and forth. And originally it was like the carrier was 1200 baud shared,
Okay.
and then there's encoding on top of
Yeah.
that. So it's fast enough for
Yeah.
someone. And so the Mobitex network we were using was 8 kilobits per second, which by the time you have protocol overhead, you could compare it to maybe a 1200 baud modem.
Okay. Yeah.
So internet, forget it.
Yeah. Exactly. Yeah.
TCP, forget
Yeah.
it.
Yeah. Not enough.
Yeah.
So this is something that, right here. It says it is also used by the first model of Research in Motion's BlackBerry and PDA, such as the Palm 7. During 9/11 and 2005 hurricane rescue and cleanup operations, Mobitex proved itself to be a very reliable and useful system for first responders. So this was a system that RIM used and built the product on top of.
What helped, especially around 9/11,
Yeah.
because it's like everyone gets their cell phone out and the network's completely congested because
Right.
you're using a certain amount of channel when you do that, whereas you're sending out one text. So, and then again, also a lot of the bandwidth got freed up because the business stuff just stopped.
Yeah.
Right.
And so you could still get through. The downlink was actually not busy. You could still
Right.
receive messages. It still worked, whereas
Yeah.
the cell phones were hopelessly congested.
Right.
So yeah, Mobitex really shine in that sort
Right,
of scenario
yeah.
because, it's like, honey, I'm okay. And then
Yeah.
of course you go on for 15 minutes because it's like, it's so traumatic, right?
Exactly.
And the channel's tied up.
Yeah. Exactly.
And
Yeah.
so the cell phones became useless in
Yeah.
9/11. Whereas if
Damn,
you're sending a message like,
that's
honey, I'm
nuts.
okay,
Right.
you're not tying up the channel.
Yeah. Exactly. Yeah.
So it wasn't that the system was so superior. It's just
Yeah.
in this scenario, it was the right system.
Yeah, there's like more bandwidth. Like there's like each individual message took a lot less bandwidth, so a lot more people could communicate at the same time.
Exactly.
So 9/11 was like a key event in like RIM's history in a way.
Yeah.
Right.
Yeah.
Because it kind of like proved out the like value of that technical stack.
Yeah, there's a lot of people that sent their last message on
It's fucking crazy.
yeah.
Yeah. So how many people were at BlackBerry during 9/11?
Oh, it was over 100 at that point.
Do you remember what was happening at that time? Like, can you walk me through like what your experience was at 9/11? Like where you were, what was happening?
I was actually not. I was on holidays.
You were on holidays, but obviously when it was happening, you found out.
Yes,
And so-
actually, yeah. So this is at
You probably were interested in what was happening at RIM at that time. Did you think that like when you heard about what
it
was
seemed
happening?
like the world was ending. I remember hearing about it, and then it's like I took my GPS.
Yeah.
It's like because it's like did they switch off the GPS network? Because I expected that they
Right.
would have
Yeah.
out of precaution.
Yeah.
So I turned
you
on my
checked.
handheld GPS receiver, took it outside, and it's like, they didn't shut it down.
Yeah.
Because
Why
it's like
did you think they would shut it down?
because people might have used GPS to guide things.
Oh, okay.
Threats. I mean, this is a huge part now.
So you wanted to know if RIM shut it down.
No, like the U.S. government.
The
was-
U.S. government.
The U.S. military.
And you
they were shut.
used your BlackBerry to validate.
No, there was no GPS on mobiles
Okay.
at that time.
So what did you?
I had an E-Trex
got
GPS
it.
receiver
Got
that
it.
people use for geocaching and stuff
Yes,
like that.
yes.
And
So-
went outside, turned it on, it's like, it's still getting a lock. I'm surprised.
Interesting.
Yeah. It's like really like that end of the world scenario where
Oh
like
yeah,
you
it
expect your
seemed like
GPS
it
not.
Yeah.
seemed like like COVID.
Yeah, yeah.
Like that
Yeah.
sort of level.
Okay, so you checked.
Except there was a lot.
Yeah.
It only lasted a day or two.
Yes.
Before things were kind of like, okay, the world has not ended.
Yes.
Totally. So you check this GPS device. I mean, you hear the news. You check this GPS device, and you see that like the GPS is not turned off. What other kind of things do you think to look into at that moment?
Well, we watched. We had terrible reception on the TV. First of all, I was kind of like, my brother checked Slashdot on the inline and found out about it because we didn't have the radio going. This is like in Northern Ontario. TV reception was rather terrible.
Yeah.
And I had just actually the moment it happened, I had taken a picture of a flower on a rock on the lake on a kayak.
Okay.
I looked after. It's like, what did I do?
Yeah.
It's like that corresponds about the time that
It actually occurred. Yes.
And so then I got back and I was just I was a little bit annoyed at Markus, my brother. It's like, you had to find out about this.
Yeah.
I could have gone the whole day not knowing about this.
Yes.
Right.
Damn it.
Yes. It ruined your day.
And I remember looking on the TV and they showed the tower collapsing. And because it's in such a terrible coverage situation and you have signals bouncing off the cliff, so you have all these vertical stripes
Right.
on the thing. And it's like, and they show the thing collapsing. And I'm like, is it really gone? I can't be sure
Yeah,
because there's all these vertical lines on the screen from the echoes off the cliffs.
Yeah.
It's like, okay, is it really gone or is there still some stuff there? I can't be sure.
So your brother found out through the internet. He was on vacation with you.
Yeah.
It's interesting. Yeah. Like you had
and red slash dot, that was the thing back then.
Yeah.
So I was kind of ticked off, and then it's like there was concern, just like people are concerned about Bush being crazy the way Trump is crazy.
Right, yeah.
So it's like, is he going to start World War III?
Yeah.
So there's concern about and of course, it's like the attacks had happened, but it's like, is there anything else in the works?
Yeah.
Which is why they downed all the planes.
Yeah.
Exactly. Yeah.
They cleared the airspace, which was an interesting physical experiment in retrospect, because it showed that the contrails do affect the weather a little bit.
Yeah.
So it was just like, holy crap,
Yeah. Like, how long did you keep those logs for that you went and like tailed and like saw the difference in?
Oh, I just left. I don't know if I even downloaded them. I don't remember.
Oh, yeah.
I was just kind of an interesting observation.
No, like, I mean, like how long, like I guess like at what point do you want to go to work and like deal with the fallout of like the how will
I didn't have to deal with it. It's just, I got back from vacation, I don't know, a week later or something like that.
I guess an event like that.
I'm kind of like, oh, I should look at those logs.
Yeah.
It's interesting that like the mainstaying feature of BlackBerry arises from a lack of resources, right? Like it was able to work well because it has like a lack of bandwidth.
Yes, and that's like
it makes it reliable.
So that's like, RIM so they had everything went through the network operations center so that RIM could keep an eye on it.
Right.
Like something went down, call the guys, get them to fix it and deal with that sort of thing. So that was an added reliability.
Right.
The network operations center also compressed things the heck out of things using Burroughs Wheeler so similar to BZIP2, that sort of thing.
Yeah.
BZIP2, I'm not sure if that existed yet, but it was a new compression algorithm, the Burroughs Wheeler transform, that was used for compressing the messages, so we could deal with low bandwidth, low reliability, and we built our own hardware, so we had like the stack on
total vertical control. On the stack,
so that really made RIM good. And I remember at some point I'd already left RIM. That RIM's assets became liability because the network operations center became a point of failure.
Right. Yeah.
There's some news stories of when it went down a few times. So that became a point of failure.
Right.
It was not adding reliability; it was subtracting reliability because the networks and your modem, your phone could just access the POP3 server directly and get the messages. Yeah. Sure, that uses way more bandwidth. Who cares?
Yeah. Exactly. Yeah.
The
technology moved on.
So we didn't need the compression wasn't needed.
Right.
The network operations center wasn't needed. So it was just an extra layer of complexity that became a liability.
Yeah. Interesting.
And I mean, Mike Lazaridis used to say like, Moore's law does not apply to wireless.
Yeah.
Because you cannot cram more bits into the channel.
Yeah.
But what happened is the cells became smaller and the channel got reused more often.
Exactly.
And wider bandwidth got allocated towards it so that in the way Moore's law, not at the rate of Moore's law, but the more bandwidth did become available.
Yeah.
And, the phones became more powerful and all that. So the RIM approach was no longer appropriate.
The engineering assumptions, the assumptions that the fact that the assumptions were based on changed.
Yeah. The thing that made the BlackBerry great originally were no longer the decisions became wrong.
Yeah.
Sort of like the pagers don't have operating systems.
Yeah, exactly. Yeah. Their software is only ever correct in a certain amount of time, and it always expires because the world is very chaotic.
Yeah. Yeah.
But before those decisions became wrong, they became like super right.
That's right.
Right. Like, and I guess it sounds like, 9/11 demonstrates the correctness of a lot of the decisions, right? Because you have all these other systems failing and then this system's like really working. Yeah. And then it sounds like, again, it was like another perhaps confidence booster for the company in a way that it's like, holy shit, we didn't just create like a product that people like using. We made like a fuck ton of right decisions across like this whole technical stack to the point where this historical event happens that has like something that none of us have ever seen before.
Yeah.
And our system is so well engineered that when these other systems failed, right, our system was still running.
It wasn't that it was that well engineered.
Well, I mean, but whatever. I mean, like, well, maybe not well engineered is not the right term, but I'm saying like, obviously you're like, hey, we made a lot of right decisions. Maybe we know what we're doing.
Yeah.
Right. And so I did you find the culture of RIM around then started saying like, hey, this is special or something like that.
Like at the time, we were already like, we need to move towards this GSM thing. So
Yeah.
we came along with GPRS, which was the packet switch layer on top of GSM,
Right.
which was complicated as hell.
So what is that?
We were already working on that. But what really helped the whole, like, I should get back to Qualcomm. So I think we owe a lot, RIM owed a lot to Qualcomm, because Qualcomm said, we're going to have the CDMA system, and it's going to be so much better than anything else. It's going to be so much better than GSM.
And
It'll be so great.
Yeah.
And we're still working on it, but it'll be so good,
Yeah.
but it'll be there. And so that overshadowed everything. And so you had all this diversity of systems.
Right.
So you had the old AMPS system. Then you had DAMPS, which is a digital layer on top of AMPS, where you triple the channels. You had some GSM networks. And then you had IDEN, was another network technology. I'm not sure if there's another one.
So I have a super dumb question. So you have like GSM, CDMA.
Oh yeah, and the CDMA was coming, kind of thing.
Right. Why do these, like what is it about the characteristics of one network that make it different than another network?
Well, Qualcomm, because they had all the patents on CDMA, it's like CDMA is going to.
But what does it do? Like it has
CDMA
different like
had certain advantages about using, like, had advantages over GSM in terms of being able to reuse the channels if everything was right.
Okay.
But what happened is, because GSM was so much simpler, people figured out how to hack it to cram more things into it. So the advantages of CDMA became less and less over time. By the time it got out there, the advantage of CDMA were much less, and the disadvantage of CDMA with the greater complexity stayed.
Like GSM was open.
Yeah.
And people could like hack on it and
yeah,
build on
and
it.
all of Europe went to GSM. Right. So it greatly set back the development of like moving to GSM and GPRS in North America. In the meantime, BlackBerry was there and it worked on this ancient network.
Right.
And it just worked.
Right.
And so that allowed BlackBerry to, if GSM had grown like it had in Europe, BlackBerry would have not had the window of opportunity of, BlackBerry exists and the competition was just not ready because everybody's waiting for this awesomely, insanely great CDMA system.
Yeah.
So because they were
to get working than they anticipated.
Yeah, fascinating.
So because they were waiting on this, like, potentially amazing network design called CDMA, because they were waiting on it, they weren't really like innovating on their own.
That's right. Yeah.
Right? And so it created a lane.
Yeah. And so RIM expected to, we had this custom chip from Intel that we used on this, and they were like, we're shutting down the line. So if you need to make you have to do your end of life order.
Yep.
And RIM's or maybe it was even like, there was like, okay, I think it might have even been that we had to get them to restart the line or something like that. So RIM placed like a rather large order for this modified 386 chip that we used in the BlackBerry rather late in the game, because it's like, we're still selling these things.
Right. Yeah, exactly. Yeah.
And that's where the money is right now, even though we know the future is like GSM. And we're also working on IDEN and this other system. They're also working on CDMA. So we're working on all the different cell phone technologies, but it's like, damn it, right now.
Right.
People are hooked on this.
This is what people are using. This is what people want.
Product. Yeah. And so they had to. So I remember, there was this huge order at the end of the life.
How big was BlackBerry at this point? How many people?
Hundreds of people.
Yeah, probably it's kind of crazy to be in a company that's growing that fast.
Yeah. It was
lots of chaos.
Like, I worked at every different size of company because I started a small company and left the big one.
Yeah, exactly. Yeah.
It's also so crazy to me that this is all happening in Waterloo, Ontario.
Yeah. Like, well, I mean, by the time I left, they had like they'd bought up various companies. The Ottawa division was fairly good size. They were working on the CDMA part of it.
But it's just nuts.
Yeah.
Like that it was just there, and you have this company that is creating like this thing that is not just like, it's like not even a product anymore. It became like a cultural
thing. Yeah. I was very lucky to, work on something that people recognize, it was like
unbelievable. What is this, Robbie?
Other than this building our own network thing, which might cancel, but again, all the pieces of that, almost everything of that I've reused for other things.
Yeah.
It's like, I didn't work on stuff that got thrown out.
Exactly.
A lot of software developers have to deal with.
This is a very common experience. Like your project just dies and all the code.
I had like the ability, it's like, no, I don't want to work on that. I think that's crap.
Yeah. I guess because you had all the seniority at the company. So you basically could do whatever you wanted.
Yeah.
What is this, Robbie?
That's a picture of the university. That is that? Yeah, that's from top of the Dana Porter Arts Library.
Did you take this image?
I think that might have been, I've certainly been on top of the Dana Porter Arts Library.
So this is
at some point to take
In the
postcards.
halls.
At some point, because like through the engineering society, it takes some. There's no drones at the time, so to take some photos from up high for making some postcards.
Yeah, you have to
I got lit up on top of the Dana Porter Arts Library, which I mean I'd been on top of the math building and on top of like illegally. But I mean, in this case, I hadn't been on top of the Dana
The Feynman
Porter.
trick.
Yeah, I hadn't attempted to get on top of the Dana Porter Arts Library, but this way I was up there legally.
In the early days of Research in Motion, when the company had but one building near the University of Waterloo and funds for only one sign, Lazaridis insisted that it be installed facing towards the university on the back of the building. I don't really care if anyone else knows where the building is. All I want is the students to know where the building is.
Oh yeah, that was important.
This guy, you've referenced him a couple of times in like a very complimentary way, especially in relation to the design, very much like related to design. What was this guy like, Mike Lazaridis, and what is your take on working with him? And you know, you it seems like he was a critical person. And
oh yeah,
can you describe what it was like working with him and maybe what his design philosophy
the movie
was?
didn't do him justice.
Right.
The like that made him look like kind of a bumbling kind of thing.
Right.
And Jim in charge of everything. Is like in terms of technical stuff, Mike was definitely in charge.
Right.
Like he was basically the Steve Jobs of
Yeah.
He was so initially, you know, when the company was still small, to have lunch with him was no big deal.
Right.
As the company got bigger, of course, you know, he was surrounded by a layer of yes men.
Yep.
And he didn't necessarily want people to tell him his ideas were stupid, which is something I would like.
Do.
I was like, sometimes like, wait, so you want to do this? It's like, there's going to be this problem and this problem and this problem and this problem. But like, that doesn't make any sense.
Yeah.
So, but you know, and at times I remember we're coming back from a meeting, and Mike and Jim had done a great sales job and they placed a huge order for a modem that we had no idea how to build yet.
Right.
And it's like, man, you guys sure pulled a snow job on those guys. I said, and Mike got angry with me. Because it was like, how dare you? Blah.
Yeah.
But I mean, he was a good guy that way.
Yeah.
So it wasn't like permanent damage.
Can I get audio on this?
But you know, he had sort of the audacity, and there's times when I questioned his ethics because, you know, he had sort of that audacity, but I realized later on, it's like, for a businessman at his level, he was a very ethical person because the standards of ethics, when you get that high, really drop.
Yeah, they do. They do. They really
and
do.
you know, like this guy might have been more audacious than the people, you know, the average engineer I worked with.
Right.
But for somebody running $1 billion company, he was actually quite ethical.
There's like a lot of selection process that there's a lot of selection that happens at that level. Yeah. And sometimes you kind of do need to like move fast and break some legs.
Yeah.
What do you mean by audacious in this context?
Well, it also kind of, you just see that smug look there. Like that is so Mike. He almost felt like Rim's success with a manifest destiny kind of thing.
Yeah.
Like what do you mean?
In that, you know, it's like Rim got a bit cocky. Like when the iPhone came out, it's like Rim didn't take that very seriously, and that sounds like it's just arrogance. But there were so many products that came out by bigger companies
Through the process
that just went nowhere.
Yeah.
That he kind of felt that this was just part of the pattern.
Right.
I remember, so by the time I decided to leave RIM, I was like, what am I going to do next? So I interviewed with Google, with their Android team, actually.
Right.
And talking with those guys, they're like, well, we have to do this because Apple's doing it and we don't want them to own the mobile space. And I'm like, shit, Apple's doing it too?
Yeah, exactly. Yeah.
It's like, and I said even before that,
Yeah.
it's like, there's only two companies that can kill us.
Yeah.
The telecoms, they're too slow moving.
Yeah, exactly,
They just don't have it together technically.
Yeah.
There's only two companies that they have to be fast moving and $1 billion companies.
Right.
There's only two companies that fit that bill: Google, Apple.
Right. And the only two guys who could, are doing
Both
it.
doing
yeah.
it.
Yeah.
And I got back, I was still working at RIM at the time because still trying to figure out what to do next. I'd announced my end date already.
Yeah.
And I was talking to Mike and was in his office. It's like, I said, you know, both Apple and Google, and he may have already known, like he may have had
It's amazing what people tell you when you're interviewing with them.
Yeah. So it's possible. So he didn't react very much to that. So it's possibly already that this was not news to him.
Right.
That he might have had insider, the thing was, the fact that this was happening, like insider people probably knew already, but I was like, that was new to me. I said, do you realize that both those guys are doing it? Those guys have it together.
Yeah. They're actually quite dangerous. They're pretty good.
That's dangerous.
They're pretty good.
Have you seen the latest sales figures? Like the stuff was selling like gangbusters.
Yeah.
Like BlackBerry.
Yeah. Oh yeah. I was like, things were going really well.
Yep.
In terms of sales, but I was like, but it's like, and he's like, I was just like, never mind.
So everything was going gangbusters.
He was like, I was like, never mind, we're done here in terms of not in terms of this meeting. It's like like I don't care what the sales are right now.
Yeah.
They're great. That's completely different from.
So things are going gangbusters, and then you're like planning to leave. Is it because you foresaw something?
Even before I knew this, like I was kind of, I didn't like the company was, we want to be one of those, like those big telecom companies, and like, no, this is stupid.
Yeah.
So there was like what it was called a men's club at the time. There's Motorola, Ericsson, Nokia, Siemens. Those guys controlled the GSM spec. They got royalties for every GSM device out there. Right. RIM wanted to be one of those guys.
And you felt that
Careful what you wish for. Look at those guys now.
Yeah.
Motorola, Ericsson, Nokia, Siemens. Do they make mobiles?
Yeah.
None of them.
No, exactly.
So you felt that you felt that pursuit was maybe
I didn't have the vision. I just didn't like
instinct, but you instinctually felt something
I just
was
didn't
off.
like. I just felt it wasn't the right fit for me anymore. I was like, you know what? I'm constantly fighting these guys. Things are becoming more bureaucratic. I am trying to push back the tide, and I'm like, you know what? You can go this way, without me.
Right.
I'll get out of your way. There's various engineers that were kind of disappointed because it's like, you're one of the guys that are pushing back. It's like, yeah, but you weren't helping me push back.
Yeah, exactly.
Right.
There's a lot of energy, and I think like when you have the seniority, sometimes it's easy to push back because nothing's going to happen to you. But for like, I guess like some of the fresher engineers, it's probably very difficult for them to push back.
It's very difficult. I felt in some ways that, it was more because that I had the recklessness and the seniority that I could afford to take the risks.
There's also a certain point when you get in your career where you're like, what are they going to do? Fire me?
Jim had this plan of buying Waterloo Maple, the guys that made the Maple math software competition compared to, what is it, the other math algebra kind of software. And I was like, why would we want to do that? We already pushed all the good people out of that company. Jim had some kind of scheme anyways. And everybody was kind of like, and I was like, I can do this.
Yeah.
I'm going to talk to Jim about this. And it was rather poorly timed. There was a couple of people in his office. It's like, I'll come back later. It's like, no. Jim's like, no, it's right now. There's Chuck Meyer and some other lawyer guy. They were at the little round conference table in the corner of his office. It was a good sized office. And so what is it? And it's like, well, this buying Waterloo Maple idea thing, it's...
What is Waterloo Maple?
There was a tech company. They wrote math software that could do like symbolic math.
Yeah.
It's a stupid idea because it sounds like one. Those are the words I used. And he exploded at me. And I was kind of like,
Wikipedia page.
Stand there. Do not back off. Do not duck.
Yeah.
He exploded at me.
Yeah.
I swear those two guys at the conference table were ducking. I was like, Jim, when he gets angry, he's known for being fierce that way. I was like, okay. I was like, my instinct
remember
was
what he
like,
said?
Duck and run. I was like, do not.
Yeah.
It's like, stand there.
Yeah, exactly. Yeah.
Like, at least stand your ground physically.
Yeah.
Damn.
Yeah.
Do you remember what he said?
I don't remember, but it was quite the barrage. And afterwards, like, Mike Lazaridis came to me and just like, afterwards, like, Matt, it's just like, don't do that. It's like, so it wouldn't have been nearly, it's like, so if I had Jim alone, but I think it also,
in front of everybody else.
He felt a need to, like.
Yeah.
But what did you say? You just said like, this is a bad idea?
This is a stupid idea because it sounds like a stupid idea.
Yeah. But like, you just said it straight up. Yeah. Like buying this company.
Yeah.
Yeah.
So I got vindicated in some ways. So like to Jim's credit.
Yeah.
We were at a RIM company picnic like later that summer, and he said the deal fell through because they wanted this and that. So he had some kind of financial shenanigan that would have made it make sense.
Yeah,
that somebody's going to get their intellectual property and be able to sell that at a profit and da 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 da.
Yeah,
sort of do almost like one of those private equity kind of hollowing things out and getting the cash. I don't know. I don't remember. And also the talent. So there was some kind of deal that he was trying to pull. He was a master at that sort of thing. It fell through for obvious reasons.
Yeah. It
so he's like that whole thing fell through, and he wasn't like, and he smiled while he said it. So like he wasn't that bitter at me, and I sort of felt, it wasn't. I didn't say it. I was like, no, it was a stupid idea. Yeah. But it's like I kind of felt vindicated.
Yeah. People like that don't take things personally, even though they do get angry. They're getting angry in general because they're like fiery people.
Yeah, but at some point, people said that he was upset at me because he called him a slime ball. It's like, I did. And this was relating to negotiating stock options. And I said to Jim, it's like, the problem is, Jim, I can't fully trust you on that because you're just too damn good at that.
Yeah.
And it's like, what do you mean? I said, you're a slippery guy. Now, I just meant that it's hard to get a hold of you, but slippery guy can be interpreted as slime ball. Yeah. A slippery guy kind of, I hadn't thought this through that way. I just meant slippery guy as in I can't get a hold of you that way. You're just too good at this. Yeah. And he took that, and you know, it's like, then it's just like, yeah, I guess I can see how he interpreted it as a slime ball.
But it seems like even though these two guys had their quirks, like when I hear you talk about it, just as an observer, I wasn't there, I don't know these people, but it seems like you have a level of respect for these guys.
Oh yeah. I mean, they definitely had their. I had my disrespect for them too, of course.
Yeah.
But yeah, you know, they knew how to. They did things that I would have never, if I was in charge of the companies, like, no, I would not have been so audacious, but they made a lot of bets and they worked out.
Right, yeah.
Mostly.
There's like selection bias, right? Like companies that grow very quickly tend to have founders who like to take really big risks.
Right.
So you don't see the successful ones because they're dead. They're like bankrupt.
Yeah.
But then the ones that are successful, well, yeah, there they are.
Exactly.
And sometimes it's like it sounds like they have like a lot of technical talent and they can like kind of see where they could skate to where the puck was going.
Yeah, and like Mike, he was more of a hardware guy, but he definitely, you know, he understood the nuts and bolts. Like he used to do the design work himself.
Yeah.
So he had the background. So what makes people like Mike special is he's got the technological background, so he can talk the talk. He can inspire the engineers. He's not like some guy who doesn't know what he's talking about.
It's hard to herd engineers.
And he's got the audacity and the confidence, which is a big factor to get like the deals and stuff like that, to inspire other people.
Yeah.
The reality distortion field.
Yeah.
Right.
You know, the famous Steve Jobs reality distortion field. He had a form of that. Like talking to other coworkers, like, yeah, you know, you talk to Mikey, you know, we're talking in his office and he's got these ideas and it's like, this sounds great. And then a few hours later, it's like, this makes no sense at all.
Yeah, exactly. Yeah.
He was so good
very good at selling things.
Yeah.
And it's hard sometimes, like one of the bottlenecks to engineering companies is motivating engineers who are very smart.
Yeah. And I'm sure Elon Musk has got that sort of thing too, you know?
It's like when they think about things from first principles and you can kind of follow their reasoning and they also respect your own ability to reason through things.
Yeah.
Like they're actually partaking in the process of engineering and being creative.
Yeah.
And having the confidence to like actually push through things and do the crazy bets, like even taking crazy technical risks. Yeah. Sometimes when you take crazy technical risks, you end up motivating engineers because you motivate that bone, which is like telling you, hey, this would be a really cool thing to brag about. Totally. You know, this is a really difficult thing.
It's almost like a stunt.
It's almost like a stunt.
Like, you know, taking an order and a deposit for a product that we're going to sell this company that we had no idea how to build.
Yeah.
Exactly. It's like, whoa, it's like, are you crazy?
Yeah.
That's super cool, man. Damn. So when you decided to leave, it was just a different company and a different relationship with you and whatever you want.
Bureaucratic and whatnot, and the technology. You know, we're moving to 3G and that sort of protocol stack, and the way that was done is like Hugh Hind, who was in charge of that sort of thing, is like, well, you know, see, this is all these legacy problems, and there's this group that we bought that figured out a way of just drawing little flowcharts and stuff like that and having the code generated.
Right.
And they've done this just as an example. So we bought this group. So then, you know, and then, you know, because we have there's all these C legacy problems and we're going to eliminate this. And it's like, my response was, it's like, yes, all the legacy problems are in C because all these other systems have no legacy.
Yep.
Right.
Because they fail.
Yep.
You know, the unsuccessful projects have no legacy.
Yep.
And they ended up having to move in, like, you know, it's about as inefficient as Python, where it's like, we're like, okay, you want to store this thing. It's like in our code that we've written in C to store this 3-digit identification was a 16-bit number.
There were decisions that made the software complexity kind of blow up.
Them, in their system, well, there's 3 items here. So you've got the item, which of course must be malloced and linked to the next item.
Right.
So, okay, so you have like the malloc, of course, has at least a next pointer, a size in the next pointer.
Right.
And then the item.
Right.
And the next, and the point, not just the pointer in the malloc list, the pointer to the next item in the list. So every one of these digits now uses 4 32-bit words.
Yep.
And you got 3 of those.
Yep.
So you got 16 bytes. So you got 48 bytes.
Yep.
And we use 2.
Yep.
Crazy.
You know, it's like, it's just.
The interesting thing about you is that like you worked at BlackBerry. Well, I mean, first you grew up in this way that is very different than how I grew up. And then you went to Waterloo. Yeah. And then you went to BlackBerry. And you're at BlackBerry at this pivotal time. So you saw that whole thing.
Yeah, it was
an exciting ride. It's an exciting ride. And that's like that would be like a story. Like that's like a life. Well, but then you went.
A movie was made about it. Books
for sure, exactly. And but then what's crazy is like you you live you created this like successful YouTube channel after.
Yeah, that's after I left RIM, I had something else lined up because I was like, what is a man without a job kind of thing. So I had something lined up at another engineering company. So I had that lined months in advance because I was going to wait out my last stock options, which turned out to be backdated ones.
Yeah.
But anyways, RIM covered it.
Slippery.
Yeah. It was Audacity. The backdating was so audacious that they picked like the best date as opposed to like if I had been doing the backdating, I would have like, let's not pick the very best date.
Right.
Let's pick one that's close to that one.
Yep.
So that it's plausible that we were lucky. Whereas they just picked like this. And so many times in a row that it's like it became implausible that was not backdated.
Yeah.
Holy shit.
And that last set of stock options there was like, okay, we have to do this today. And we have to sign these, you have to get this paperwork done now. And it was not communicated by email. It was entirely in person. And we have to get this done today. And I was like, okay, whatever.
Yep.
And then I realized afterwards, oh yeah, that was the backdating.
Yep.
Because when you give stock options, you have 90 days to file that with the government that you've given stock options. And so it is favorable if the strike price for options is at a low price.
Yes.
So the way backdating works is since you've got 90 days to file it, so we could have filed it, let's say January 5th was like a really low price. Now we're February, March, April, we're early April and we're like, holy crap, the stock's gone up. So if we had issued stock options on the January 5th, that would have worked really well.
Yeah.
Well, we could have done that and sat on the paperwork until now. So we will sign the paperwork, dated January 5th, and file it now, like immediately. Yep. And it's still within the 90-day window. We're perfectly legal.
Yep.
It's one of those things, there's felt that you could get away with, just like you can get away with driving a little bit over the speed limit. It was okay. Or if your house burns down and you have a broken TV, you don't tell the insurance company that was broken. You tell them that was a brand new TV.
Yep. Just a little bit over the edge.
Yeah. So that was kind of, and Jim had a bit more audacity that way, perhaps.
Yep.
So it became statistically implausible that these were not backdated. Anyways, I got some of these backdated options and, the company covered the tax difference. So the government says it's like, since these are backdated, these no longer count taxable as stock options. And then RIM covered the difference. In fact, I think the execs out of their own fortunes covered it.
Yeah.
So, and even though I had left RIM by the time that got settled, they covered everybody's.
That's awesome.
That's cool.
I was kind of like, well, I'm not going to put my life on hold until this is settled. So I might be out extra taxes. I'll take that chance.
Yeah.
So what is the story of this YouTube channel?
So the guy I was going to work with at this engineering company got fired before the time came. So then I was kind of like, well, I've got some projects of my own that I work on.
Right.
And the YouTube channel wasn't. So one of them was a stock chart.
Can you find it? Really?
So I knew somebody who was into technical analysis. So this website no longer exists. I sold the domain. And there's a complete they didn't use any of my technology, but there's a company that wanted to do exactly what my website was about. So they just wanted to, they wanted the domain because it was already established as doing that sort of thing. Where you look at a stock pattern. So there's people that believe that looking at the pattern of stocks, the way it's going, that this will tell you whether the stock is likely to go up more than down or something that you can, you don't have to be, you don't have to predict it very well. You just have to be right more than wrong.
Okay.
And so it's like, well, if some people believe in these patterns, we should test that. And so I should write a program and I might just program, make it a web thing so anybody can test it. So I started working on that. That was chartgame.com. And
what was it called?
Chartgame.com.
Chartgame.com.
That's a crazy domain to have. That's a good domain.
Well, it was available. It was not the first domain idea, but yeah, that's why I did. They paid me like $10,000 for it. Yeah. The company that bought it, but it's like I wasn't maintaining the website anymore. Exactly. It wasn't my thing, so I was just happy to get 10,000 and just shut it down.
Yeah, exactly. Finally free up the server.
Yeah. And then the other thing was my woodworking website, which again is called woodgears.ca because that was the first domain that I thought of that was available.
Yep. Also an awesome domain.
So I remember I was at work and I was just like, oh, let's try that one. And it's like, oh, ping woodgears.ca. Doesn't exist. It's like, okay, that's available. I should register that one. Yep. That's what I'm going with.
Can we see woodgears.ca?
One of my favorite websites, by the way.
Yeah, and so it wasn't about YouTube at all originally, but I built some of these things like the marble machines.
Right.
And I put a sound sample on there, but that's already a big file. And it's like, I want to put video on there.
Yeah.
Is this like then this YouTube?
Is the design of this
Oh, that's my latest video. That was.
Did it always look this way?
Yeah, almost. Yeah.
Damn.
There's lots of people. It's like, oh, you should redesign it to be more with current trends. And it's like, there's a company that makes a phone that's just square with rounded rectangles and it's got square icons in it. I think they're kind of successful.
Yeah, exactly.
Can you go to the?
Keep it simple.
Do you know how to get to the earliest chronology, Robbie? The earliest.
The chronology. Click on one of these, then scroll down all the way to the bottom. So 2008. The website is older than that, but that's the first time I started doing things more regularly.
So this website became where you started documenting projects.
That's
I guess.
Right. And it's all about the AdSense revenue.
Right.
Which for a while that worked fairly.
Like how much would you make on that?
So for a while, my peak run rate was about $100 a day.
$100 a day?
Yeah.
Okay, so $100 a day. Why did you call it woodgears.ca?
Because that domain was available. Woodgears.com was taken, and the guy.
That's fine, but like, why Woodgears? Did you have a vision of what you were gonna do, or were you just?
Because like to do things with, I was into the mechanical type of thing, so to make gears out of wood, and like scroll back to the top, see the banner all the way to the top. That banner is some wooden gears I had made even before.
Oh yeah, that's a photo.
So I just photographed some gears on the table that I made, and that became the banner.
That's awesome. That's super, super cool.
So that's where
how to make wooden gears.
Yeah, that
there's
that page.
There's a German guy. He made an OpenSCAD library, and that's how I make my gears.
Yeah, well, there's all kinds of stuff online for that. Yeah. Now. So one of the things I did at some point is like when I realized Perl was not my programming language, where I was just doing something in Perl, is like, this doesn't work because you use the wrong characters to delimitate the string, and that means the string behaves differently. And I'm like, I was just at that point, I was like, this is not my programming language. Yep. And so just to learn Python, I wrote something. I just thought of something. It's like to draw involute gears on the screen. And then after I got the website, so I picked a domain before that. I was like, well, wouldn't it make sense if I had something to help you make gears on the website? So I ported that to Flash.
Okay. Yeah.
Because that's the way, JavaScript wasn't that far along. So everybody used Flash for that sort of thing. YouTube was Flash based. Yeah. So I rewrote that in Flash. I ended up rewriting that in JavaScript later on. The Flash programming language is essentially JavaScript with different APIs.
Yeah.
So the porting wasn't
the involute math is not easy. It's
not that bad. The downloadable gear generator takes a bit, like it calculates undercut, which is
this is cool.
Yeah.
The basic gears like that is not that complicated.
Like I guess like when there's all these different types of optimizations you can do to minimize the contact, to minimize friction of the gears.
Well, undercut is more for really small gears. It doesn't actually makes the gears worse, but certain gears will just not work if you don't do undercut.
Interesting.
How did you get on a cadence with this? Like you create woodgears.ca, you document a project. You have to be on some kind of, this is really nice, but you have to be on some kind of like a cadence to start getting AdSense revenue, right? Like you're doing projects. Oh yeah, I had
you're looking at my brother's website. So at about the same time, I made my own website.
Right.
And then AdSense, it's like you Google get rich quick, and AdSense would come up,
right?
Because people believed in that sort of thing. Right. So like that was actually. There's a lot of people that were into, it seemed like, so I was like, I put some AdSense on some of my pages and very quickly,
just feeling it out,
after a bit of optimization, I was at a few dollars a day. It's like, well, let's see how far I can take that.
Yeah, it's a constant little game, optimization game. You start pushing up and up and up. Yeah,
exactly. So it was about that. And then just some of the stuff, well, I should really have video of that. And then the videos started taking a life of their own. And now the video totally dominates. Like people, I get way more traffic. Well, no, I don't get that much traffic on the videos as I used to, but it's like the traffic. Eventually I realized like I was getting way more traffic views on the video than I had views on the website.
On the website itself.
As in the traffic was coming from YouTube, and it was also a good discovery mechanism because YouTube had the recommendation algorithm. Right. So people would find me through YouTube's recommendation algorithm. So the videos became around 2010, 2011. I realized
I actually,
this video thing is really important.
Very recently found out about you, probably 2 years ago or something. I found out about you because I actually looked up wood and gears. Because I wanted to build robots out of wood. Like I was like, why can't we just build robots out of wood? I feel like it's a pretty decent material to build it. Yeah. And I was like, well, why can't we make gears out of wood? Because I have a 3D printer, and I was like printing gears to just mess around.
The one thing you need to use is Baltic birch plywood. It's the ideal material for that.
Yes. It looks really nice too, actually. I love plywood. Plywood is such a remarkable material.
Very strong and durable gears. Like like 3D printing, it's just not that.
It depends. I recently got a resin 3D printer and it's actually pretty good. The problem is that it costs like $240 per liter of resin, the specific engineering resin I'm using. It's also kind of messy.
Yeah.
But the resin material is pretty tough.
And it probably then if you don't use it for a few months, it probably goes bad on you.
No, I think it's fine actually.
Okay.
I don't know. I haven't tested it yet.
Yeah.
You have to test these things, but resin 3D printing is awesome. I've been able to print out like a small 75 millimeter drone frame, pretty decent. I've been able to print a chicken ball. So
chicken ball?
Yeah. So chickens, some chickens get eaten by coyotes, and you can actually put them in a steel cage and a steel ball, and they run around like hamsters.
Oh shit!
So they can be free run, and they won't get picked up by like predators.
Do you have chickens now?
I don't have chickens, but I do have a drone that's in a chicken ball.
Oh, you have a drone.
So actually,
I'd like to see what the chicken ball looks like after the
Yeah,
coyote tried to get the chicken.
No, you can buy these off of like AliExpress, and they'll send you an actual ball,
chicken ball,
and then the chicken's happy. It's like
but how coyote proof is the chicken ball?
Well, the coyotes can't get
that heavy.
See a chicken ball?
It's the coyotes can't get in.
Yeah, but it can't be that heavy. Like I'm sure that it gets a little bit bent up.
I think it's made out of steel. It's like a steel wire.
Got it?
Yeah, but it can't be heavier than the chicken. You know, how strong is it going to be?
Well, it's rolling around, so the chicken's like rolling it's like a hamster wheel.
Yeah, but it's like this ball has to be this big.
Well, these are
that's true. Yeah.
This is not the chicken balls you're talking about.
No. I guess I call it. How about a chicken orb? I think it might have been called the chicken orb.
I made one out of wood.
Chicken ball is like what people order at Chinese restaurants and shit.
Okay. We should
Chicken
get Chinese
orb?
sync,
I made a ball like that out of wood, like a geodesic thing.
Oh,
I put
look
a
at
cat
that
inside for a bit. And the cat enjoyed it for a little bit, and then it's like I went out.
Did you write code to like come up with the plans for the geodesic ball, or did you just wing it?
No, this is back in the.
This is like a geodesic orb for chickens.
Yeah. Anyways, I resin printed one to fly a drone in because I was getting kind of sick of them crashing into my walls and breaking.
Oh, interesting. That's pretty cool.
And the lift was okay.
You just get bigger motors and you use bigger batteries until it starts flying.
So what do you think, Matthias? You think this is a good solution?
Well, I'd like to see what happens when a coyote tries to get into it.
You think it could get in there?
To find out.
Yeah.
You think it can get in there?
Well, it would certainly scare the bejesus out of the chicken, possibly damage the chicken, certainly damage the ball. I mean, it'd be better than without one, but
I would prefer, if I was a chicken, I would prefer to be inside a ball.
yes, I would like somebody to set up a wildlife camera and see what happens.
Yes.
And film the.
Do they have that?
Actually be a
Do you
great
have
YouTube
can you
video.
find chicken orb coyote encounter? Can you find that, Robbie?
You might have to look on what's that other YouTube alternative? I mean, all these alternatives end up being all full of right-wing stuff, but
This is why YouTube is going to win all of them. You can't even remember their names.
yeah. It's one of those. There's one of those YouTube alternatives. Because like the coyote attacking a chicken in the thing you get in trouble with that on YouTube.
Have you ever gotten in trouble for any of your YouTube videos?
The one I did about how bad you get zapped a trip at GFCI, I had uploaded just a test version and it said that it was limited. They got demonetized because because I was describing as I was turning up the current how much it hurt. And it promotes self-harm. It's like, fair enough.
Fascinating.
It's like, fair enough. It could be taken as that, if you just like, oh, it hurts this much now. Okay, now it hurts more. Ooh, that's hurting a lot.
That's the video.
As I'm cranking up the current to get to the 5 milliamp threshold that trips the GFCI.
Fascinating.
So I just replaced that. I used the footage and I just talked about it.
Right, yeah.
As opposed to describing, and that cleared it. So that's how that's the video I ended up uploading.
So, did you find it?
Oh, and one of my old videos.
There's nothing?
It was manually reviewed that got demonetized about talking about weaknesses of combination locks. So at the time, it's like, well, that's potentially illegal.
Right.
And that was manually deemed to be not monetizable.
Interesting.
So this is going back to, like 2000.
It's kind of frustrating how this is knowledge. This is information. Why should we not?
I don't hold it against it. It's like, it's talking about weaknesses of combination locks. So
I mean, at scale too, right? It's like if you have who knows who's watching.
I think I mentioned in that lock. So the master lock has this particular weakness that if you just close it and open it, like the only thing that you need to know is the last digit to, like they're a little bit weak compared to the Dudley combination locks. And I was talking about that weakness as well.
Have you ever built any locks out of wood?
Yeah, well, this is relating to my combination lock video, which again was for the sake of content because I figured that might do well. It did do.
Yeah, interesting.
So you leave BlackBerry and you're kind of like messing around with this woodgears.ca site. You set up AdSense and you're like, oh, there's some money here and I'm just making this thing. And then you're just like, okay, well, let's start working on this. So we looked at some of the old posts and you could see that the video is like an afterthought.
Yeah, well, a lot of them don't have videos.
Yeah, a lot of them don't have videos.
Until 2011 that like there was that most things had a video
and
to
then
go with them.
This go to the top.
Yeah, there's
here.
no videos for most of these.
Yeah, go to the top, all the way up to the top. Yeah, and then go to all the way, man, and go to popular.
Oh, it's the videos. Yeah. Oh, yes.
so at some point, this is only 8 years ago, but you started this channel like 19 years ago, right?
Yeah,
Something
like first video is 2007.
Yeah. So let's go to like 18 years ago. Go to that one, Marble Machine 2.
Oh, that one did super well.
It's go up, Robbie.
Yeah,
right, yeah, it's right there. There you go. Let's watch this. Okay, so Marble Machine 2. So you make this thing.
Yeah, and
this thing gets that's a lot of views, man.
And let me tell you what made this video so successful. What made it so successful is I edited this video to host on my own server.
What?
Or on my own, like on like where I was paying for the bandwidth,
right?
And
yeah.
I had to only so much space, so it had to be short.
Right.
Oh.
So
and at the time, people was like, "Oh, I'm making a movie, and I'll have 20, 30 seconds of credit at the end, and the big intro scene because I'm the director, and and I'm talking about this and that."
Whereas let's watch it again.
This one was just cut down, just the highlights.
Right.
And
what's the duration of the video?
Before people realized
30 seconds.
The formula was.
YouTube didn't.
It's really interesting, like how as we go through.
That's crazy.
So because this
was
was
a short form video,
because this was edited so concisely.
It's edited very well.
And when it showed the attention spans, it's like the attention span was like pegged through the whole video.
Yeah.
So it had the advantage over what else was out there, in that it was edited so short because people hadn't realized how important that is yet at the time. This video doesn't do well anymore. It gets hardly anything.
Back then, like recommendation systems were very dumb. So they would do like how long would you be watching a video? Like what percentage of it? And they would simply like have like actual hard coded things being like update this based on the percentage of watch time it has.
And it was no recency bias at the time.
There's no recency.
Like
recency bias is what?
That newer videos are our favorite because at the time there wasn't so much stuff out there to watch. So stuff that got watched a lot must be good. And so that video would get like 8,000 views a day, like day in, day out for months at a time.
That's awesome.
Were you aware, like, when you mentioned that the attention graph or whatever you're talking about, where it was like pegged at high comprehension or whatever, high attention,
high viewer retention,
high viewer retention. Sorry. When you were looking at that, was that data available when that video went up?
No. That was a brilliant thing that YouTube did because there's all these guys talking about this and that and the other. And then they came out with this audio, and I'm like, everybody just went to film school,
right.
Because suddenly everybody's realizing, oh, when I yammer on and on and on about this, my audience leaves,
right? You have
because
feedback.
It's not like leaving a theater in the middle of the show. You're not offending anybody. It's like, oh, people don't like me yammering on and on. I should do less of that. And suddenly everybody is like, oh. Everybody suddenly learned, gradually as they looked at analytics, it's like, oh, I should more of this and less of that.
Right.
And the content, and this is where YouTube became better than TV.
Right. Yeah. Like give people the feedback to improve their own content, and they could use it as a learning platform.
YouTubers now had way better feedback than the television studios had. They weren't going by what established convention is.
Right.
They're just going like, this works on this medium.
Right.
Don't do this, do that.
Yeah.
Super cool.
Suddenly, and that really improved the quality. Suddenly YouTube became, I shouldn't say suddenly, but it's like YouTube became a lot more watchable as a result of that statistic becoming available. I was like, that is brilliant.
Right. And so you watch these retention statistics and you like edit what your videos are like, or like you edit your videos based on what you think would improve retention or what people want to watch in the first place.
Well, I mean, I like doing the technical stuff, which I know doesn't get, and sometimes I'll talk about things which, the majority around times are like, way over my head. So it's like, well, that's the important bit. So I'm aware of it. So quite a lot of videos, like I'll shoot the introduction and I'll shoot the video, and then I'll go back and reshoot the introduction because I can make that 1 minute introduction. It's like, I'm talking for a whole minute. That's too much.
Right.
And then I can get 10 seconds out of it, which is still too much, but it's like I can shorten. So that I'm aware that this is the part.
And even the way you
try to minimize that sort of thing.
You show it working, and then you give the viewer the expectation of the payoff at the end, and then you interact with them through the entire video.
Sometimes. So this last video just did. It's got like a minute of talking before I get into the nuts and bolts of things. I was just like, oh, well, the one about the...
Can I get audio on this?
Reading lamp to attach to the wall.
Oh yeah, that's a recent one.
Right about
that one was kind of like, well, I didn't end up building a project after all, but I like a video anyways, and it did okay. So this is a lamp that my dad made. And as we're clearing out the house, I took that off the wall. And,
your dad made that?
Yeah, 20 years ago. And I improved the design a little bit because it had a tendency to sag down. So I'm added a shim there, which made the up and down have more friction, and also replaced the wooden screw with a.
So your dad wasn't just like
you can kill audio.
He made like contraptions and interesting devices.
Damn.
So I was sort of thinking I should build another one of these, and then went through design iterations where in the end it's like that's another one my dad built.
Oh, yeah, that's a photo.
And I was looking for a photo of that, and I couldn't find one. And afterwards, I realized, like, you know what? I have a pretty good photo of that, a much better photo of that lamp on my freaking website.
Yeah,
like,
there we go. Perfect.
So this isn't the best photo of that lamp. Only later on did I realize, like, I have a much better photo, and I put it on my website already. I was like, why didn't I look there?
Okay. So this is the one that your father made.
That's another one my dad made. So this one, it's just kind of like folds out.
Okay.
It sags a little bit and all that, but it's
how much I'm really curious. Like, are you just winging this? Like, when your dad's making something like this, does he just like from his mind?
Yeah.
That's awesome. That's so cool. This is great news for someone like me who hates planning.
Why? Yeah. Why do you keep asking that? You've asked it.
I hate planning.
Right. Like, what do you mean?
I think that you can get a lot better results by just winging things live than by planning something.
Right.
It's a lot more natural, and sometimes the outcome is a lot better.
Well, it depends. So there's I have to disagree with. So the first bandsaw I built, I winged it.
Okay.
The second one, I planned it, and it became that much better because, first of all, the first one I didn't know if it would actually work. So winging was the way to go. And then it was like, this works. This is what I've learned. And then it's like, you put all these components on the bandsaw. It's a fairly complicated thing. It's like, and as I'm going along, it's like, oh, I should put this here. Well, that's in the way. If I built it, I can't just move that.
This is true.
I'll just move this over a little bit, no problem.
Yes. Well, sometimes the fastest way to find out that you can't put it there is to actually build it.
That's true. So the first bandsaw I built was completely winging it, and it worked fine.
Sometimes I feel like planning ends up postponing action too long, for too long.
Well, there's a sweet spot.
Yeah, there's definitely a sweet spot. My default is action.
When I see like the YouTube channel, and then I look at like your website, and I look at like your past and the way you grew up and stuff like that, and also a lot of what I like about Yacine's work as well is like I like that you guys are always like making things, you know, like you're always doing things, and I think that's like super inspiring. How do you not get like some kind of a creative block or something, or does that happen? Like, you know, a lot of times I think people are deliberating what path they should or should not take, right? But, you know, you look at yours and it's just like, okay, fuck, I guess he's working on a reading lamp now. Or like, I don't know, you go to the channel, I guess he's making like a squirrel turret.
Wall lamp, so that was like, it used to be, you know, that you do a project for the sake of video, but the economics aren't there anymore. It does not make sense to do a project for the sake of video.
What does that mean? Do a project for the sake of video?
It doesn't pay enough to make it justify the effort. So now it's like, if you know, I made a video about building a king size bed, well, because we needed a bed.
Yeah.
Fair enough.
Might as well film it, you know?
Fair enough.
Yeah.
So yeah, some stuff like the one I just published yesterday, which I was quite proud of, but it's not getting the views naturally.
Yeah.
It's too technical, about measuring capacitance. So with a Pi Pico, it's like I have an electrode, and just by me approaching the electrode, it can sense me there.
Right.
And all I do is I have the electrode hooked up to a GPIO line on the Raspberry Pi. No analog circuitry.
No way.
Just a digital GPIO line. And I hook up, if I hook up a big enough electrode, like say a pop can, to that, it can sense when I approach that can.
That's so cool.
From the just from the capacitance. So if this was here, if I get this close, it registers.
That's so cool. How does that work?
It just measures the capacitance to ground.
Okay.
Is this
With a digital I/O line?
That's fascinating.
Completely digital.
How do you do that digitally?
Well, because there's analog components to that as well. So I drive the line high.
Okay.
And then you can select pull downs, pull ups or pull downs on there. So I turn on the pull down, set the line high.
Right.
And then I flip it to input and immediately pull it to see how long it stays high.
Interesting.
Because
Right.
it'll
That's
stay high for a
fascinating.
while because there's capacitance
Yeah.
in the chip itself. Like
Fascinating.
even with nothing hooked up, it takes it a few nanoseconds to
And
drop.
then you time that.
And I time that.
That's fascinating.
And then I do that
That's
thousands
such a
of,
great hack.
and then I do that thousands of times
Awesome.
per second.
Yeah.
And even though the thing only runs at 125 megahertz, I can get the average down to like the average time is precise to like 0.1 nanosecond.
Right. Yeah.
So the time it takes for that line to drop will vary by it as I approach this will change by
Right.
like maybe a tenth of a nanosecond.
That's awesome.
And I can see that. I can measure that.
That's really cool. That's super, super cool.
So of course, people feel like, how can you measure things to like tenth of a nanosecond when the thing
Yeah.
only runs at, well, you just average thousands and thousands
Yeah.
and thousands of samples in the
Yeah.
presence of noise. You can get the average reflects that.
Fascinating.
You're
This is the sort of
really
thing I
good at,
love.
yeah, you're really good at making videos, man.
See, so now I've got the sensor underneath the floor and it can sense that I'm stepping on this area. So
That's
you
so
could use
cool.
this to, like
Detect people walking by.
detect people. See, and I've located where the hotspot is and I stepped over and it still caught it
That's amazing.
because just by being near it. So
Yeah.
I'm showing here then that I'm just sort of looking for a spot with my hand.
Holy
Yeah,
shit.
there's a spot. Like that's the full spot. And now I'm stepping over it. See, and it registers just a little bit.
Super cool.
And then I demonstrate, it's like, see, I'm not even touching the floor and it's registering quite well.
I'm going to kill YouTube because they did not recommend this video to me. This is how it's not.
Well, this
show
is
up on
his
feed.
this is his like secondary channel, it seems like too.
Yeah, the more technical stuff. And here showing on the scope, rather than illustrated, it was easier just to demonstrate that. So I was able to very graphically demonstrate that on the scope, how, the line decays and all that. And then this is where I'm getting into where I'm measuring capacitance between two wires as opposed to the ground.
So you're like-
here I'm demonstrating how that works. So you see the line diverging because I'm driving the other line high or low while the decay is happening, and that's affecting how long it takes to decay to zero. And that difference tells me the capacitance between the GPIO lines.
That's
It's
awesome.
like no analog circuitry.
That's awesome.
It's like GPIO lines. That's it.
That's really, really cool. How do you come up with like? I guess you like. When do you come up with this?
I had no idea this would work as well. I just,
Yeah,
and
you're like thinking to yourself like probably this is going to work. Like I bet you this would work.
My original idea was that I could have between plates maybe the capacitance would be enough to whack the other line
Yeah.
over to. So I was kind of like, and I have Gemini have standing instructions like, if you think it's a dumb idea, just say so.
Right. Yeah.
But do it anyways.
Yeah.
Sometimes it thinks it's a dumb idea. It's like, you don't know what I'm getting at. Anyways, so I had it. It's like, well, if I do this and I want to get down to a picofarad, what do you think? Is this going to work? And it's like, dumb idea. It's not going to work. Never going to work.
Yep.
And like, and then did the calculations. Like, here's why. It's like, yeah, you're right. And then I had this idea of just letting it decay.
Right.
Because you also have to, not only do I need to get to the threshold voltage, I need to overcome the hysteresis, and it just doesn't work that way. But if the line is going from a 1 to a 0 anyways, then a minute amount of change just changes the timing.
Right.
And so I just set the line high every time and then wait for it to drop to 0. And I
Yeah.
do that like,
So like, it's like driven by motivation. Like you want to be able to. You think that this should be possible in principle. So you're
and
figuring out
this
any
is
way
where-
to do
this
it.
is where LLMs are great. You
Right.
know, I've been thinking about this idea for some time, and then I just sit down at some point. It's like, ask LLM, what do you think?
Right.
And it's like, okay, well, let's do it this way. And okay, write the PIO code, which is a
Right.
assembly language for those.
Which would have taken you an afternoon before, but now
Yeah.
it's like
And
instant.
it very quickly got to something that actually worked, and then I was hooked.
right. Yeah.
Super cool. So it's
So
like you're running.
this is inspired by Chris Helmke, who makes these screw counting things and all that, and he makes a YouTube.
Oh, I
video
love that
network.
YouTube channel.
Yeah.
Those mechanical
And so I
marvels.
had him in mind. So I was like, okay,
Yeah.
I'm going to demonstrate. Like this would work for what
Chris
Yeah. It's
Chris
Cal-
Helmke. He's a German guy.
Chris Helm.
Naturally, I have an affinity for him.
Yeah.
So I sent him a link afterwards.
Yeah.
Not right away. It's like a
Yeah.
few hours, the day later. It's like, oh yeah, I forgot to send him an email. He said, 2 people have already pointed out this video to me
That's
because
amazing.
this ramp is
Right,
very
this is-
much like the problem that he's solving. And he solved it with a piezoelectric thing that senses the vibration,
Interesting.
which he had to vibrationally isolate the part so that when the screw falls onto the ramp, he knows, okay, the
Exactly.
screw
Yeah.
fell.
Okay.
And
Interesting.
I'm kind of
Fascinating.
like, if you could use it electrostatically, which has its own problems too, because
Yeah.
that's his approach is completely immune to electrostatic interference,
Right.
whereas this approach is completely immune to mechanical vibration.
Right. Yeah.
So I emailed him and he replied back. Yeah, several people have already emailed me about this one. I thought that was kind of cool.
This is
love your videos too.
Holy shit.
This is where like YouTube recommending your videos to too many people can almost be like, it's almost like you want your YouTube videos to be recommended to the right people to help you build a network and share the knowledge that you're discovering. Like,
well, and this is where I post things on the second channel,
Yeah.
which is more technical anyways. So it's not gonna, the people who are just into the woodworking aren't gonna. It would still get more views on that, but it's like I hit more the right kind of audience. And plus, every time
Can we hit the can a
lose
PC run
subscribers.
faster out?
Yeah.
In
The
the
main one, sorry, on the second channel, I gain subscribers every time I post. Every time I lose
Fascinating.
subscribers.
I think this is the kind of stuff I'm into.
I was very tempted to bring the gadget here to show you. It'd be too much.
I was going to ask you to bring some stuff, but then I didn't want to bother you.
Oh, I would have totally brought the thing, but then it's like, you know what? I don't need to bring the laptop computer.
it's so cool how
So I don't need to.
it's so cool how when you need things, you just build it. That's like awesome. Like you just
Oh,
needed a
I've said
case
in
for
some of
computer.
my videos, and if I had a 3D printer, I would 3D design this manifold to get on there. But fortunately, I don't have a 3D printer, so I just cut it out of a piece of wood. I did have to design it. I just cut it out on bands.
Yeah, exactly. That's precisely right. Like when you're doing a 3D print, when you're using a 3D printer, you need to open up CAD software, which is kind of a hassle.
Would you say you're a better carpenter than your dad now?
Well, my dad did a lot more, and there's a lot of stuff in terms of trying different audacious sort of things. I feel I'm ahead of my dad,
Yeah.
but in terms of
What about just
building
raw-
good furniture, he was way ahead of me.
Way ahead of you. Would you say you're still using a lot of the raw skills that you learned like as a kid being around your dad and stuff in terms of what
Yeah,
you
just
do?
to be able to observe.
Yeah.
Like I said earlier, it's like, why do you even ask? You're going to do it differently anyways.
Totally, yeah.
But just to have the tools available and
Yeah.
to watch by example.
I think one of the really cool things about your work is the way that you blend computers with woodworking. I think it's awesome. I think it opens up a lot of potential for you to create something that interacts with the real world. In a way, perhaps, I don't know, where you have more control or something.
Other people they go to a 3D printer when it needs a little thing to go between here and there. I was like, I just, if you have the tools and you know how to use them, it's like, I take a block of wood and I'll cut it out in the bandsaw and drill a couple of holes in it there.
Yeah.
And, I have sort of a crude homemade milling machine and I have a metal lathe too now. And a CNC, which I do use for some things where there's no other way.
So you've seen like if you're pretty good with like woodworking, then a 3D printer is pretty fucking slow, right?
It's pretty slow. Like,
and then you got to buy the filament.
Yep.
And I'm cheap.
Yeah.
The material too from woodworking, obviously it's wood. It's a lot better.
Yeah.
Filament is just like a lot more plasticky and not nice.
Yeah.
There's different properties. They have different properties. I find 3D printing really great for helping CAD design. So I print the thing out. Sometimes I just resize it 3 times and I just print 3 different things to see if it fits. So I use it in tandem with like my CAD software.
Yeah.
And I just don't have a great wood shop yet. I don't have a good wood shop yet.
And then there's like, but there's things like people who build architectural models. Like, man, oh man, is 3D printing ever a solution for that?
Yes.
Because there's more intricacies, you mean?
Yeah. And it just does, the machine does it as opposed to, the first plastic things RIM got made, RIM had hand-built models of the thing built.
Hand-built models?
This is back in 93.
Like, what do you mean?
Somebody hand-built it from
hand-built
the CAD drawings.
Right.
Now, later,
how do you even do that? Like sculpt it?
You bend plastic and it takes a long
time.
Damn,
that's
crazy.
And
then I think it might have been 94. We got the first, and it wasn't called 3D printing yet. It was SLA prototype. So this is a resin printer type of thing. And it's like, wow, this is amazing. The machine did it.
Yeah.
I think the filament idea was still very much under patent protection.
Right.
Like the 3D printing, the rep and all that blew up when the patents expired.
Yeah, exactly.
For filament printing. So this was a resin printing type of technology and, super expensive, but still a lot faster than getting something hand built. And it was straight from the CAD drawings. So you could verify the design that way.
Yeah, exactly.
So it was like, wow, they could like have this thing made. Like, I don't know if called it 3D printing yet. They're just SLA prototypes, people call them.
Right. Interesting. I like resin printers. Like I've had good experiences with them. It's just sometimes you just need to get the thing in the same day.
Right.
And it's a lot faster. And it's
with the resin printer.
With resin printer.
Well, they're hugely faster than filament printers.
Like how much faster are they?
It depends. Like you can parallelize a lot better.
Okay.
So a filament printer can only print one thing at a time.
Yeah.
But with the way a resin printer works is that there's a UV resin or a resin that gets cured with UV light. And then there's an LCD or a screen at the bottom that emits UV light, and it emits a layer of UV light and then slowly pulls out your model out of the pool of resin or the vat of resin.
The fuck?
Yeah.
Really?
It's actually alien technology. It's super
Can I
cool.
see that? A
Yeah.
resin printer? So it's not it's not like what I'm imagining of a 3D printer where it's like
It gets
with
pulled
that
out of
thing.
It gets,
gets
pulled
pulled
out of
out?
a vat of liquid, like an alien getting pulled out.
How is that even possible?
UV light and
You just explained it.
yeah, exactly. Yeah,
He explained it, but
yeah. So like
I
the
don't
resin, yeah,
know.
it's when when people get their nails done.
like what he basically said was like basically there's liquid and then there's light and then we're just pulling the
part
fucking.
that I don't understand is like, okay, so it's
Oh my
exposed from
God,
bottom. What
that's-
prevents the stuff that you're building from sticking to the plate where it gets exposed from.
Wait, so this is what you're
I'm
using?
not sure. Like, yeah, I'm not sure what you meant.
So you're solidifying the thing by illuminating it from the
Yeah.
bottom, right?
Yeah.
Through this piece of glass.
Yeah.
Okay, so now you're hardening the stuff that's right up against the piece of glass.
Oh, it's actually not glass. It's a thin layer of cellophane plastic, and it's very low friction, low like
Low adhesiveness?
yeah, low adhesiveness, and it literally unsticks it off.
Oh,
And
okay,
it like
it probably has to go.
yeah,
every
like
time.
and the
Holy
cellophane,
shit.
like the plastic, will snap back. It has a little bit of give.
Oh, okay.
This is from me just like looking at it, being curious.
Yeah, I've never watched one of these things in
Yeah,
action.
it's actually really awesome, and the types of material you can do like ceramic out of these things. You can do like silicone.
Matthias, have you ever
That's
used
not real
this?
time.
It's not
No,
real
it's not
time.
real
They're
time.
not that fast.
Yeah.
Have you ever used something like this, Matthias?
I've gotten stuff.
But you've seen this before.
I've
right?
gotten stuff printed by PCB, which I'm pretty sure was resin printed because just the level of detail from it.
PCBWay is awesome.
Yeah.
So how much faster is this?
It's not that much faster.
Oh.
It depends on how many things you're making. So if I'm making like 10 of the same things, I can print them all at the same time because it's coming out of the vat of liquid all at once.
Okay.
But
Oh, I see.
So I guess the time it takes to harden each layer is a bit
yeah,
more.
there's a lot of post processing too. The liquid is quite nasty. It's quite toxic. So you have to be somewhat careful when you're handling it. But the material is so much nicer that I probably have something in my box somewhere here that I've printed. But the material is so much nicer and a lot higher quality. Like not higher quality, but can more impact resistant. Some of the material depends
Right.
on the type of material. You have a lot more options for materials because. So for example, like I'm working on drones that fly themselves. Part of the prototype process is they have to crash because I need to test things in real life.
Yeah.
And I have a resin material that can basically like survive
Resilient?
hundreds of impacts. Just
Super
like over and over again.
interesting.
Isn't there, although I guess it'd be hard to print something like a cage with, you'd have crazy support material if you tried to print a cage.
No,
with,
actually, I have done this. I've printed out a chicken orb, which is like a geodesic orb. I wrote the code for it. I have my own CAD software I wrote.
But there must have been a lot of supports for the.
No, it was just the orb is just, it was fine. I just tested it without support. It was fine.
Oh, okay.
Wow.
but
I hate
the-
supports. I
yeah.
always print without supports. If it
but
doesn't fail,
where it emerges at the top, you've got like such slow slopes. How did it do with
it was fine. Yeah.
It must have looked a little bit ugly though.
There was a little bit of like kind of deformities, but it was fine.
Oh,
I mean,
okay.
for my purposes, I just needed the thing.
I guess it's just kind of stretched the filament across and it
Yeah.
went okay.
It's like as it's coming
Oh,
out,
is
as
this
long
it?
as it's connected to the rest of the system, it'll be fine. Yeah. So this is precisely it. So that's the drone
I
frame.
sat on the chicken orb.
I sat on it, unfortunately.
Oh,
This
you
one
sat-
didn't make the cut. It has to survive me sitting on it. But this is it's basically like like I wrote code to produce that shape, and then so I wrote my own, or I wrote my own CAD software to interface with the CAD kernel from OpenSCAD, which is something called Manifold CAD, and I basically write JavaScript to define the shapes that I want. So everything in that is a polygon I've defined in start
Okay,
JavaScript.
so you
and
just
then
you have a machine generated input file for OpenSCAD.
yeah, or not. It's not OpenSCAD. So OpenSCAD uses a kernel, and I've taken that C++ program, and then I wrote JavaScript bindings for it,
Okay.
and then I interact with it, my own JavaScript
Didn't you
API.
just tell OpenSCAD that I want a member here and a member there, and
It's more like there's like primitives
Oh,
that are
shit.
available,
That's
like
cool.
it's manifold Boolean algebra. There is coming out of the thing, so it's fine.
What software is this?
I wrote the software.
so hang
Looks
on.
good.
Did you filament print or resin print the?
I resin printed that.
Oh, okay. No, I meant for filament printing.
Yeah.
I can believe that the resin.
Yeah.
printing
The
can-
resin printed. This would never come out of.
Okay,
filament.
that's where I thought you said you
Yeah.
filament.
Can you go back to the one with the drone in the thing? No, the other one. Yeah.
Yeah, and as much as I'm always kind of anti 3D printing for something like that, it's like, well, grudgingly, 3D printing is the way to go.
Yeah, there's just those things that are just like too small. I mean, I've actually been thinking about it. This is a fight I have with my co-founders all the time. I think we should just make the drones out of wood. I think we should make the drone frames out of wood. They're like, oh, but it'll flex. What about water? It's fine. Just like stick a piece of metal through each end.
So yeah, I wouldn't if I needed to create an orb like that, I would maybe try to use like some carbon fiber sticks, and I'd have a few loops. It wouldn't be as closed off.
Yeah.
But
probably fly better.
And then have a little bit more offset. So sure, the props would sometimes strike something, but most of the time it wouldn't be.
Why did you say that you're kind of like against 3D printing?
Oh, because everybody's like, you should 3D print. I get that comment all the time. So
right.
I kind of get my, I like to go again. It's like, oh yeah, I should do SDR. It's like, you know what, everybody else is doing it.
Yeah. Sometimes it's like doing the obvious thing is not super fun, and you kind of want to carve out a part of the field that people haven't explored, right?
Exactly.
I'm still going to get into building robots out of wood. I just don't have time yet, but I will have time eventually. Once I sell enough drones.
All right. I think that's a pretty solid point.
Yep.
This is awesome. You're a very interesting guy.
How long have we been at this now?
I don't know. I think it's been a while. This has been 4 hours? Did it feel like 4 hours?
That's no, not for me.
That was 4 hours?
4 hours? Yeah, I think maybe we'd call it a day.
Yeah.
Yeah, I think so. Was it 4 hours since the moment we walked in though? Or 4 hours since we went like live?
It's been 4:30 since you walked in, and 3:30 or 3:40
since we went live.
That's still
Wow.
one of your longer ones, isn't it?
I think so. Yeah. Well, I really appreciate both of you guys. I think you're really, really cool.
Thank you.
And I think Matthias, like, you're a very, very interesting guy. I think like I don't think maybe you realize you're interesting because you just like are who you are. But like me observing you and like Yacine putting me on and stuff, like I think it's really cool and it's really inspiring to see how you just keep making things. And it makes me want to do a lot more just like in the world and like with computers. And I don't know, man, I'm like, man, maybe I should learn carpentry or something like that.
You know what I love is our 8-year-old.
Yeah.
He's got his own workbench in the basement.
Yeah. That's awesome.
He's into totally. Now the stuff he makes is pretty crude.
Yeah.
Then it's like,
he's 8 years old.
It's hard to be a frame of reference because like of course you remember the stuff that when you're older and all that. I'm kind of like, well, I don't know. How crude was the stuff when I was that age?
Yeah.
But at least, he's got the drive. He doesn't care if it's crude. He just does it. I know there's a lot of crude stuff I built too.
And he probably has you as an example that you can just do things and
yeah,
build
but
things.
Totally.
So I don't teach him so much. Sometimes he'll ask, but it's like,
Right.
it's just like, it's like, sometimes like, that if you do it that way, that happens. But
Right.
it's like, he teaches me like my dad did. And
Yeah.
that I don't, I teach him like my dad taught me as in I don't.
Yeah, exactly.
I just make the stuff available.
Yeah, make it available, and that's really, really cool.
Yeah.
But for me, man, it's inspiring just seeing it. It's inspiring you just seeing what you're doing. I don't know how that works or why it is, but just seeing that, just seeing like, oh man, yeah, he has a setup. And then I'm like, wait, do I have a good setup? What's my process? Am I pushing myself? Could I try this thing? And just
do other things.
I do other things, but I mean, it's inspiring to see somebody just like be like, oh, well, how does that work? Or what about that? Like why like, just try this thing out. I think John was telling me something like in the research. It's like you just like you like garbage. You know what I mean? Like going through and using garbage as a creative prompt. It just reminds me
because I'm cheap.
Yeah, but it's just
nothing about creative.
Yeah, but it's just, to me, it's just cool.
I sometimes think, like tool companies might do well to see dumpsters around me with certain tools.
But yeah, I just want to say thank you to you both.
Yeah.
It was really, really cool to see you guys riffing like that as well.
Really awesome meeting you, Matthias.
Yeah.
Super big fan.
Thank you for everything.
Thank you.
Appreciate
Yeah.
you.